Hello everyone, sorry I was starting so late, but of course we have to celebrate Chinese New Year with a big feast, so at least I'm starting today's stream with a full belly. So, what are we making today? Well, we're making a stream deck. We actually planned this last week. What we're going to try and do is we're going to try and make a bare bones stream deck on a breadboard using minimal components. So, I mean, if you're really desperate, you can make your own buttons, but we're going to use our own buttons and our own pieces. And
we come sing a song?
I'll come sing you a song. Daddy's on his stream right now. Why don't you go say hi to Daddy's stream?
You want to say hi, Kira?
Hi!
Keep your shirt down.
Hi!
Hi, Kira.
Hi.
Hi.
You should be asleep. Come on.
Go!
Okay, let's open up Paint, and I will explain to you guys how I'm going to achieve this. Also, I'd like to also mention today's sponsor, Vegito Cola. I don't even know if that's actually what it's called. I think it's actually called Ocean Bomb. But I'm going to say it's called Vegito Cola because it's got Vegito on the front of it. I really want to try this. Apparently it's apple flavor. The only thing is that, like, that is so cool. I wanted to, like, just keep the can. This is freaking awesome. It's Vegito Cola. If they had this in the store, I would buy this. I would drink Vegito Cola. I don't know. Let me just... Okay, so what are we going to do today? Well, we're going to draw some diagrams. So the first thing we're going to do is we're going to talk about a switch. So the first thing I'm going to do is I'm going to draw up a little button here. Okay, this is going to be our little push button. Okay. I always end up doing this, but here we go. If I can just do like a little top to it like that. Maybe I'll draw it with a brush like this. Like that. This is bad. Okay, maybe I should use like fritzing or something. I don't know. I think I just got to draw it properly. Here we go. Do a little line. Ugh. Let's zoom in a bit. Draw what better? Yeah, I can draw a little better when I'm zoomed in. There you go. So this thing comes down, and then it would like press down onto a thingy. So the idea here is that we got our push button now, and with the push button we can do some other stuff. So we're gonna have the main thing here, which is I guess our microcontroller. Oh, here's Alan. Here's Alan, by the way.
Everybody.
Maybe we should reconfigure it so we can show both of us in the stream. Oh, we can kind of see you here.
Yeah.
Let me go over to here. I'll change the filters off. I'll change the alpha mask key. Let's just remove that. I guess we don't really need a circle mask if we're going to be both in the stream. And there we go. Is that good?
Hey everybody. Welcome to our show.
Woo! Welcome to the build stream.
Yes. Our design stream, and then it build later.
Yeah. Right now we're designing. We're in the designing aspect of it. And which is why I've got, what is it? Paint. Currently I'm doing the mock-up in Paint. Normally I just do it on a piece of paper or something like that. But you know what? I'm doing it in Paint today because... That's what we have. Okay.
we can't afford no CAD tools.
So we got I could use a CAD tool. Should we use one? Should we use one, Alan? I don't know. Okay, well, I'm going to do it here for now.
Paint.
Because right now the concept is simple enough that I can just use paint to explain it. So, what is this thing? I'm going to label it by labeling this is the... Okay, this is supposed to be micro, not 4, but whatever. That's a micro controller. Let me just do a C. Here we go. It looks like 4C, but whatever. This is supposed to be microcontroller.
Why don't we just type microcontroller or something?
Oh! Right, yeah, that actually makes a lot of sense. Actually, we should probably be more specific with this. This is going to be our at mega 328p-pu. Because that's what we got. We got all those, we got these little chips downstairs. Might as well put one to use. Although... Yeah, actually, this is probably the most suitable one because we don't need that much more outputs and we don't want less than...
Yeah, I guess we do have a USB adapter because we want to hook up...
Yes, you're right. So give me a second. We've got to put that into the diagram too then.
Yeah.
Because basically, if you don't have it programmed in Arduino, the Arduino does a whole bunch of useful functions for this chip. This is like the chip that's inside of one of...
The bare chip inside those... Well, everyone knows about Arduinos, I assume. Arduinos are little kind of mini boards, come from Italy.
Let's assume that they don't. Let's assume they don't. Right. It's like basically a programmable little board and allows you to change and program like the program inside of it so that you can have the pins of the chip do different stuff. That's probably as vague as I can put it in order to be kind of like all-encompassing, but basically you have certain inputs that are good for like reading sensors, and then you have other inputs that are good for like just outputting a signal.
What's an input?
Do you want to join the stream, Kara?
What's an input, Jordan?
You can't be heard over there, so I'm going to pretend I didn't hear you.
Oh,
okay. Okay, so I'm just joking, Kara. If you want to come over and sit down, you can totally join.
It's a chip.
It's a chip. It's a chip. Okay.
It's a chip.
What is a chip? A chip is like basically it's like these little. It's like a little piece of silicone with a bunch of little electronics inside of it, and it has little legs that come out the side. Usually, like.
It looks like a bug with metal legs. That's what it looks like.
It totally does.
Yeah.
Right, and it's got these little legs coming off the side of it like that. And the idea here is that usually there's an even number. So let's say that there's like 6 legs on this side. Then that means there's going to also be 6 legs on the other side because most chips are symmetrical. Not meaning that like maybe one of these legs might not do something. It doesn't mean that there's going to be functional, but they are usually symmetrical. With the Atmega 328p-pu, it actually has 14 legs on either side. So it actually looks like a little comb over here. So let's I feel like let's just do this in most simple format, because I realize that if I start drawing out all the legs individually, it's going to consume a lot of time. But we do have a way here, because a typical Arduino actually has the USB inside of it. Should we just assume that we're using an Arduino?
Let's use an Arduino.
It's going to keep it simple for now, because we'll talk about later about how we minimize stuff. But that's kind of something that we've been doing, because I've been super addicted to making these things. They're not technically Arduinos, they're like Hackduinos. That is to say that I'm using the chip that's inside the Arduino, and then I'm making my own board to kind of run it. So we're just going to use normal Arduino. Okay?
I don't have one with me right now.
I have one downstairs. Don't worry.
We'll illustrate to you people in a moment.
I think the one that I actually have downstairs, or the one that we're probably going to use, is the Demilanov, but we'll just assume that we're using the Uno. So I guess Arduino Uno. And then, of course, we have over here our buttons. We're going to start with 1 button just for demonstration purposes. And in order for a button to be detected, you need to either detect it on high or on low. So for most people, that means that it's going to be either a value of like 1 or a value of 0, right? But when you get to actually going... Oh, what happened there? Oh. The light went out?
Pulled into my desk, which apparently unplugged the light.
Okay.
No problem.
Thank you.
Technical
difficulties. Yeah. You have the grip of doing your job.
How do I explain this, Alan?
Okay. Well, of course, this is digital electronics. So in digital electronics, what is that? Whenever you have a voltage on something, that's called a high.
Yeah.
Number 1. If you don't have any voltage, that's considered ground, or 0 volts. That's considered 0. So
we'll actually write that on over here. This would be ground or 0 volts. right? And then over here, over 1, people are thinking that this is going to be like exactly 5 volts, right? But really, it's probably going to be like 0.1 volts and greater.
Well, actually, no. So for stuff like the CMOS inputs, you need about, it depends, 4.5 volts or higher.
4.5 volts or higher?
Yep.
So greater than 5.5. The reason why I say that is just because sometimes if it just occurs... Whoa.
Sorry. I haven't followed you just so I can follow you.
You scared the crap out of me. Kaiba scared me. He was very enthusiastic.
We'll keep it simple. It's 5 volts.
It's 5 volts, right? It's like
5
5 volts, basically. But the reason why I want to mention this is that it's not always 5 volts. Sometimes it's just more than 0 volts. And in the case where we're trying to pull it high, and we have this thing going through a 10K resistor to 5 volts, this voltage that's detected through this button is going to be much less than 5 volts.
It'll still be 5 volts, actually.
Really?
Yeah. And it's just that there's no voltage divider. It's just really limited current.
Oh, right. Okay.
Yeah. Mm-hmm.
So give me a second. So if we see here, and we're going to try and... That's what we're going to do. That's exactly what we're going to do. We're going to have it go through our resistor here. And we're going to have it connected to... I guess 5 volts, right?
See, actually, for Arduino, so there's some this is a little technical detail. So the Arduino is using a kind of chip technology called CMOS. The thing about CMOS is that when we have signals going in, inputs, those inputs, it always wants to be either high or low, but never disconnected. It doesn't like that. You don't want to ever float. So what we do is we have to guarantee that we never have any kind of floating voltages. So built into Arduino is something called a pull-up resistor. So you can actually change it. So by default, it has a trickle of voltage to...
But I think you have to set it to like pull-up voltage, right?
Yeah, you do.
So when you go into the Arduino software, there's like a setting that you can set the different pins to different modes. So if you want to use the pull-up resistor, you actually have to set the pin, whatever this pin is. Right now we haven't labeled it, but whatever this pin is, you're gonna have to change that mode to pull up if you want to use the pull-up resistor. But let's expose the pull-up resistor. Imagine that this circle here is like inside of the Arduino, so you can see here. And what is this? Is it 10K? I think it's like a 10K. Is it?
10K typically built in. It's internal. Yeah.
Yeah, it's like
10 or 20K.
Okay, so let's just put a little zoop in there. Oops. Ah.
Actually, it goes to +5. It's a pull-up resistor. So it goes actually straight up, zigzags, and goes up to internal +5.
Oh, I see what you mean. I see what you mean. So it's like, it's actually like...
Screw the rules. I have money.
Oh, what? We just got a donation? Who we just got a donation from? Mew Mew just tipped $88? Holy moly.
This is an auspicious number for Chinese New Year.
88. For Chinese New Year.
Yeah.
Thank you for your donation, Mew Mew. If you weren't literally in the same room as me, I'd be so blown out of the water.
I just tipped you $88 and you're not blown
I'm still blown out of the water. I'm just like...
Now the whole evening's worthwhile.
Yes.
Did you see the tip message?
No, I didn't see the tip message. I should go take a look at it. How do I check that?
It says, please plug my channel.
Please plug your channel. Okay, well, subscribe to Mew Mew. Check out T Crazed. Check out T Crazed on YouTube. How do I check the alerts? I should figure out how to do that.
I guess you have to go Stream Elements, I guess.
Yeah, I guess I have to go to Stream Elements. Let me go into Stream Elements. Hopefully, it doesn't reveal too much stuff because right now everyone's looking at my screen right now.
I mean, you can look at it later. I just literally told you what it said. So
I know, but I should also find out what the heck.
I am PogChamp.
Holy crap!
You seem super happy.
I guess I can figure out. Let's look at it later. I guess next time I'll just immediately jump over here to take a look. But here we go. So this is gonna go right across, like so, and then we're gonna actually hit a pull-up resistor going up to 5 volts. So here's 5 volts. We'll just say put a little arrow there. Oops. Like that. Then one of these. And one of those. And that's going to 5 volts. I can't believe you donated $88. But I think it's also kind of awesome. Thank you. So we're going to go here. Let's pull this down a little more.
So you just want to jog sideways and then
that?
Yeah, and just go zigzag.
And let's take this one and then we'll do a little zigzag here. Actually, I'm going to zoom in a bit so that I can make a nice resistor in there. So it's like this, like that, and we'll label this 10K.
Yeah.
Oh, that's huge. It's gonna have like 11, 10K. So we've got our 10K ohm pull-up resistor now. Very good, very good.
So because you notice on that push button, you see when it's not pushed down, it'll be disconnected.
I see,
this
yeah.
is why the point you have a pull-up resistor always guarantees that you'll at least have +5 working.
And the main reason for that is because these pins that are connected to the Arduino, they really don't like to float. I think that Alan mentioned that earlier. But basically, if they're not set to either high or low, they will just
oscillate and give spurious values. It's going to act flaky.
And why does it float? Is it because it's basically just reading electromagnetic radiation in the air, right?
It is, because essentially it's just an end of capacitor. That's what it is. The way CMOS works is the gate is a floating gate. It's very sensitive to any static charge. So any kind of rubber hand.
Oh wow!
If you don't have it tied down, just that will actually cause.
Oh, see, that's crazy.
I'll call it. I'm getting input. I'm having a spaz attack.
I wonder if we can somehow do an experiment with that
we
one of these days.
Could at some point. Yeah, we have a floating input. We read Arduino, just have this output on the LED, whatever it is, or whatever signal detects, then just rubber comb and just brush it closed. Although you don't want to actually touch it because you probably can kill it if you.
Oh yeah, because you can actually just zap it and boom, it's gone.
So this end needs to be tied.
5 volts, right?
No, actually ground.
To ground.
Because
so what are you saying? Right. So this 5 volts coming through the this voltage coming through here. This 5 volts coming through the 10K ohm resistor.
Yep.
Is that 5 volts? It's little less than 5 volts, right?
No, actually, because it's disconnected, it experiences a pure 5 volts. However, when you connect grounded, again you have something a little tiny bit above ground actually, but it's pretty close to being ground because of course it's internal resistance to the wire at that point because it forms a resistor ladder.
I see. I see.
But effectively, it feels like ground whenever you push the button down.
Yeah, I remember looking at that. We were looking at that last time.
Yeah.
Unfortunately, we didn't stream it, but we were trying to figure out like resistances of wire and stuff like that, and how like if you have too small a wire, it becomes a fuse. That's important to know. So let's actually extend this down a bit so that it can go. Crap, that looks horrible. Okay, I'm gonna redo that. Okay, so we've got the ground here, and we've got basically our setup here of how we're gonna set up the Stream Deck.
And that's it. That's all you need.
That's
to do,
pretty
folks.
much it.
That's it, folks. Thanks for coming.
Thank you for coming. Thank you guys. Thank you guys for coming. We started late, but you know what? We made up for it by doing the entire stream in 10 seconds. This is basically what we're gonna do. And what we're going to do at its most simple and most basic is that we're trying to take the buttons that we're going to do, and we're going to actually create an array like this. So if we want to take this and expand upon it, so let's get rid of this. We don't need this anymore. We know what we're doing now. There we go. And what we're going to do is we're going to take this button here, and we're going to just copy it a couple times. So let's put one like up here.
Covers up. You may want to cut less of it.
No, I'm just going to spam it on top, maybe. Oh, yeah, you're right. I need to cut less of it. I see. Yeah, freaking... Paint sucks, guys. Don't use paint. Don't be like me. Okay, here we go. That's another one. And how about we start with 4? Maybe 4? Or 3?
I think that's the original plan.
I think the original plan was to have 4. So this seems like a good amount right here. So let's just go back and we're going to connect all these terminals together. So now these guys come into one long common terminal, and then these guys pull into ground. And you know, it's really funny because you always think of how like electricity moves in a certain way through a circuit. Except I realized that I had it all wrong for the longest time. Is that the source is actually where the electricity is coming from. It's not going to the source; it's coming from the source.
Although technically that's right and wrong as well at the same time.
Is it right and wrong at the same time? See, I don't really understand.
Yeah.
Apparently, I know my stuff, but I don't know my stuff.
Blame Benjamin Franklin. He got it wrong 250 years ago. And we had to live with all the consequences since. He got the flow of electricity wrong.
Yeah. And it messes me up because you always see...
Father of America? Founder of America? No. He was wrong.
He didn't know what he was talking about.
Well, maybe he did something significant like create the postal service and then the U.S. library system, but he got electricity wrong. Although we shouldn't do it like that.
Oh yeah, you're right. Sorry. No.
Yeah.
You're right. This is. Sorry, I got distracted by laughing at what you were saying. Okay, so what's actually going to happen is this top one's going to get connected to this top wire.
Yes.
And there's going to be multiple of these wires coming out.
Each one input requires its own pull-up resistor because each of them is a separate input. So each needs to be kind of...
Can you say, well, I guess you are my little bog champ? Aww. Oh, Kara got mad. Oh, how did you get Toodle's emoticons?
Well, let's use them. Because you subbed to her, I'm subbed to her, somebody subbed to her.
Fine. I guess you are my little pog champ. Come here. Okay, so here we go. So the idea here is that each of these is going to have their own little pull-up resistors. I don't know, do I have to draw the pull-up resistors if I just...
We'll assume, pretend everything is the same.
Yeah, so we're going to just say this top one is the same as these other ones that are going into the Arduino, even though you don't see them. Maybe I'll draw a circle over them or something just to denote the fact that it has the pull-up.
Actually have internally, but not all circuits are special like this that you can configure them to have pull-ups, so then you have to do it manually in this particular diagram.
Yeah, so we're just telling you, like, if you don't have the Arduino Uno doing the pull-up resistors, you can do this manually with resistors, but you're going to have to set it up on your breadboard in this way. And we might end up doing that if we end up making a really nice version. Like, maybe if we have a final version of the Stream Deck, we'll have... we will use something different. Although I'm pretty sure that even the Atmega 328 has...
Yeah, you configure each depends on pull-ups.
See, that's crazy.
Yeah.
You don't even need the Arduino component to have the pull-up resistors.
Yeah, you essentially don't even need to hook up resistors even with this thing. That's why you use these things these days.
Yeah, the Arduino, the whole package here is so cheap. For 20 bucks, you get all the stuff you need, and it can, with all the pins that you have, you can easily replace most of the hardware little component chips that you need. Like a lot of these little, little pieces, bits and bobs that you need.
And if you're really cheap, you don't even need that. Just barely buy the bare chips. And how much does they cost?
On AliExpress, I got a bunch of them for like $2.50 each. So if you're really cheap like me, you can just get them in bulk, and then you can have $2.50 Hackduinos for the price of your soul. Because they take a long time to well, not a long time, but they take a little more effort.
Yeah, take a slow boat from China, literally.
Yeah. Okay, so we've got this now. So we've got the push buttons. I think this is good. Should we?
Yeah.
Should we try and make this?
Yeah, we can.
All right. I will be right back. I'm gonna grab a drink and some breadboard stuff. Okay, I'll be right back.
In the meantime, let's discuss a little bit more about what's happening on this channel. So our goal on this channel is to have some kind of project to work on a weekly basis. Hopefully something that can be done within the hour and a half, 2 hours sessions that we do. We get to that. So currently working on Stream Deck. Stream Decks, what are those? Well, you're watching a stream right now, but of course control what you see on the screen here. We like to be able to not use a mouse, not use a keyboard. So what people do is they buy themselves those Stream Decks. Little units about this size, multiple buttons, you program them, and then when you hit a button, a macro fires and something happens. You get a new scene, music plays, commercial interlude, confetti blows up, whatever you want to. So our goal is to create a DIY stream deck, those custom buttons, because you can buy them if you want to, but they're pricey. They're willing to charge you maybe $150 for one of those things. We want to avoid that. So in this case, we're going to build our own.
We're broke.
Well, you shouldn't have said that.
Please donate.
And that too. Yeah, we're cheap.
I'll get the tiniest violin.
So hopefully we get some interesting projects done. Other goals, hopefully we can do something maybe like robotics and stuff as well too. That's all doable. 3D printing, we're going to be doing that hopefully as well too. We have 3D printers available for us. Doing some CAD design, various things. Example of something that's done in 3D printing is that here's a little project I've been working on my own. So there's a little gearbox with a little 50-cent electric motor on here. So this allows me, eventually I'm hoping to do a little bit of robotics. I have someone I teach on a regular basis, a high school student. He's into robotics at school. So I said we'll do some more projects. So in order to help him out, I decided I have to have my own robotic equipment. So I've made this little gearbox. And gearbox, all it does is that these little electric motors, they're nice. They don't have much torque. They don't have much turning power. They also spin way too fast. Like this motor on 3.3 volts, you're getting something like maybe about 3,000 to 6,000 RPM. A bit too fast. You don't want wheels doing that. So inside this box, it's a series of printed gears, and it reduces that motion a total of 16 times. So you get 1/16 the spin on this side, revolutions per second. We also have 16 times torque, which should mean that hopefully will make a robot move across the floor. But we'll test it out on a later date. Other things, I guess, that we have in terms of 3D printing. Well, I think tons of stuff in 3D printing. There's a little case for holding drill bits, 3D printed. So this is made of plastic called PETG, polyethylene. Remember, it's polyethylene. I'm trying to remember the T part. I think they're 8. I can't remember what it was. But that can be 3D printed. And well, yeah, we'll see what other things we can actually do in terms of keeping you entertained. Just see what's going on our stream right now.
So hopefully that gets him some. You guys should be watching the chat on your computer. Can you log into your Twitch and watch his stream? And then you'll be able to see the chat too, and he'll have something.
Okay, found some components. here's my question here is
Yeah.
does ESP32C have pull-up resistors?
I can't remember. We can look it up. We can check the specs.
We'll look at it.
Yeah.
If not, I will have to go back downstairs and look for more Arduinos. But I found some breadboards here. Found some buttons. And I found this kind of cool ESP32C with kind of like a breadboard pattern. You can see it's got like a... I'll show it to the stream. It's got the main chip and it like plugs into another thing. Here, you can see it.
Yep.
It's got like...
Yeah,
I don't even know.
Breakout and stuff, so that means it should give us... Yeah, it's a breakout board.
Yeah, it should make it easy peasy for us to set this thing up now. Okay. Now this is where I wish I could switch cameras to show you guys the build. What I could do is, let's see, if we can get the 3D printer going, we can try and set it to go for set up some more pieces. Although it's pretty much dead right now.
Okay, what is that? Heat up the hot end and lift it.
Okay, yeah. Okay, let's do that. Oh yeah, it wasn't able to connect last time.
Yeah, that's because the power supply.
Although, is it bad that I'm showing off my my local IP for my freaking printer?
Shouldn't matter. That's.
Oh right, it still needs my username and stuff, right? Okay, good. Okay, so
that's also a local IP address. Every single router in the world shows that address.
Okay, good.
I thought I was going to hack into this guy's computer, but why am I into my own? Why am I in my mom's computer? What's wrong with that?
Okay, here we go. Okay, well, I'm just basically pushing these buttons into the breadboard right now, and they make a really satisfying click when they kind of get in there. And also, they make this really nice satisfying click when you press them. I don't know if you guys hear that. Oh god, that's just good. That's really good. I like these buttons. I spent what was it?
You splurged on.
I splurged on the good buttons because I like the clicky click. You know what? Right now I can only fit 3 buttons on here, so maybe we'll just start with 3.
Well, that should be enough. So what do we need? Play, stop.
Ideally, they should be toggle buttons, right? Were we also going to put like indicator LEDs with them too?
We can program them.
Yeah,
we can program on this ESP.
Oh right, actually it's yeah. Let's just do that. Although, should I add an LED board maybe? I can get 3 LED colors. Then you can keep track of like if these are 3 toggle buttons. Let's say this one's start and stop play. I'm just saying. Okay, so that's 5 volts. And over here will be GND. Yes, please ask your questions. That's why we're here. It's always best when you guys ask questions that Alan's around, because Alan knows more than I do. He'll be able to give you a more technical answer than I will. I would just be like, yeah, it works. Don't know why, but it does. I keep trying to check on the chat, but every time I open the chat, it opens like the portal to hell, because it's like recurring screens. I'm tired of recurring screens. Okay, so we've got this all set up now. Although, should I delete maybe this bottom one? I kind of want the diagram to be the same as what I have here, so maybe I should delete the bottom one, yeah?
Yep.
Alan's gone and no longer watching the stream.
No! I think you're a mod, babe. That's all it costs, $88 to become a mod.
There you go.
So all of these lines here, let's give them names. Here, I'm gonna expand this Arduino out so y'all can see it. Let's like just drag it over, I guess, like that, and then I'm gonna extend the top and bottom here. But these are just these are the inputs, so we're gonna name them. I guess we'll name them.
I guess it's D9 to D10, 11, 12.
Yeah, so this will be like. Well, we should name these buttons first. Let's name the button. So this one's B1. For button 1, of course. B2. And a B3. Then we're going to have our inputs. This was going to be, I guess, D1, D2, D3?
I think D9 is usually the first
input
on most Arduinos.
D9. All I know is D13 is, I think, the LED, right? D10. And this one is going to be D11. That seems like pretty good there. So now what we're going to do is we're going to try and get these guys to represent this configuration here. So how does a breadboard work? Well, let's talk about it. Let's save this into my pictures. It's called a Stream Deck. We're going to make a new one to explain just very briefly how a breadboard works. So a breadboard looks kind of like this. We've got a square thing where you've got two different sides, and the middle is like divided by this kind of channel. I like to call it the valley. Okay, and inside of here, you've got these.
As you mentioned, there's a whole bunch of little holes in this thing.
Yeah, there's a bunch of little holes. It looks kind of like this, kind of like like that. And the holes go into lines from side to side. I'm not drawing them in because, of course, I can't draw them as well as I can just draw a line. But really, you guys need to know that these little dots, these little holes here, are actually connected.
What you do is you put wires inside them. So when you wire stuff together, we need to connect them up. So this is what breadboards are for. And the trick is, underneath all those holes, there's actually a conductor that ties everything in a line all together. So if you hook something up one hole over here, one beside it, they're really actually physically connected together.
Yeah.
To avoid you having to solder them, twist them together, do all sorts of stuff, which makes it hard to use.
The metal inside is kind of springy, so when you take something like one of these jumpers, which is basically just like some wire with these kind of little headers attached to the end of them, these jumpers are just kind of like wide enough to be able to kind of insert in those holes and just kind of stick there.
Yeah, the friction fits and it's a nice, fairly solid grip.
Okay, so now that we explained that, I can do away with this picture now. And what we're going to, actually wait, I'm going to use this picture to show how we're going to wire this up. So what we've got is we've got this channel like that. It's all set up just like that, right? And we also have these little buttons. And the buttons I have look like this. They've got a square center, and they've got a circle in the middle, like so. Oh, maybe a little less than that. Let's say like that. Okay, and then it also has these legs that come out the side of it like so. Yeah, like that. Okay, so these legs here actually can just stick inside the holes, and I actually did that with 3 buttons here, if you can see. Okay, but the way that these legs are connected is actually like, if you guys can see the legs here, I'm going to do another one that's like a X-ray version just below it. The legs are actually connected straight through the thing. So the legs on the outside appear to be separate, but inside they're actually like this. They're just one long connector. And what happens is when you press that circle actually connects both of them like that. So the electricity can now flow through the device.
From the upper conductor to the lower conductor. They get joined together by the button.
So kind of like that.
Yep.
And so what we're going to do with these is we're going to connect up to one side. It's going to be like this side or whatever. We're going to have this side be our power side or whatever, right? So all the buttons are going to be connected up with these sides connected to be power, right?
Ground.
Or ground. Sorry, ground.
Yeah.
And then when you press the buttons and connect it up, that's when it's going to connect it up to the power of the to our pull-up resistor, where we're actually giving it power. So we kind of want to have all of these connected to some sort of common ground here. So once we've got these buttons in place, we're going to let me just grab them. I'll put that off to the side so you guys can keep seeing that. I'm going to grab this button, and we're just going to multiply it. So it's going to be like one here, and one there. Okay, so now we've got our buttons in place. We're going to basically create the common ground. How do we do that? Well, we've got to take these legs, one side, and let's just agree on one side because it's all on, it just makes it easier. So let's say the left leg here. We're going to make this one join to that one, right? Like this. So we're going to put a little piece of wire that connects up that leg to that leg. Then we're going to take this leg here, and we're going to connect that one up together as well. And then these guys are going to go to ground. So once we've got ground all set up, now all we got to do is we got to set up this other legs to go
probably choose a color
to the Arduino.
Like maybe make it red or something.
Yeah, let's do that. Let's actually use I guess let's use like blue, green, and pink or something, so that we have different colors for them. But here we're going to have this side connected out, right? Let's just pull it straight out, and then we'll have another one. Let's do green, and this side here to Arduino, and then we're going to also come in here, take another one. And give me 1 second to check the chat. Doesn't matter if you have dollars if you don't have cents.
Canadian pesos are fine.
I feel like that's a really clever play on words that I don't understand. Oh, cents and cents. Ah ha ha. Funny.
Just spelled out for PH.
Punny. Okay, so we've got our things here. Now we've got this one here. This is going to be connected to our D9, like we said before, right?
Oh, should we draw it actual Arduino in? Or something?
Yeah, let's draw the Arduino in now that we've done...
A literal, actually, diagram.
Yeah.
So it'll probably make better sense to people if we draw a literal diagram.
Yeah. And we're going to draw in our thing here. So this is going to be our Arduino. Uno. And then we're going to have our pins, like D9, D10, D11. 11. Not D100. This isn't D&D. Okay, here we go. And of course these guys are going to just go a wire like that, right? They're going to go straight from their buttons to the sources. But what we're not seeing is the pull-up resistors, which is actually inside of the Arduino Uno. It's inside of the Arduino Uno, and it's doing that thing which keeps these leads from hanging, from floating. And that's a big issue because that'll make your program run funny too. So this is basically our full completed setup.
You probably want. You want to tie the ground, I guess, together. The ground.
Oh yeah, the ground goes into Arduino too. So we don't actually have to represent it by just saying it anymore. We can go in here and we can connect it all up. Kaboom.
And that's all you really need, to be honest, with Arduinos.
Yeah. Now here's the next trick. Is the thing that I have right now, because a lot of my Arduinos are actually plugged in and doing stuff right now. I don't actually have an Arduino. What I have is something that's similar to Arduino. I don't even know if it's similar to Arduino. You can program it with Arduino software. I think that's probably where the similarities end. But this is an ESP8266, which is a...
It's actually a originally it was designed as a chip that provides Wi-Fi. It communicated using a bit of a serial protocol, but in order to do that, they actually had to put inside an actual microprocessor as well too, and actually some ROM, some actually flash EEPROM, some RAM as well too. And pretty much, essentially, it was effectively a CPU, a microcontroller all of its own, despite the fact that originally it was designed just to provide Wi-Fi for circuits. And then the original a bunch of people hacked at it, and they realized, wait a second, we don't actually need an actual microcontroller. We can actually use this actual Wi-Fi controller as an actual controller. And that really let it take off. So people use these actually for full projects these days, and it actually incentivized and manufactured it to create new versions of the ESPs, which were specifically designed for this purpose, that they are full controllers in and of themselves.
Yeah, I think that this one here is not actually the ESP8266. So this is an ESP8266. It's one of the derivative boards, but basically, the crazy thing about this board is that all the stuff that's around it is extraneous. The actual chip itself is just this thing, right, Alan?
It is, but then you also need this antenna. See that little squiggle?
Yeah.
PC board, that's an antenna.
So I don't know if I can show it on this. I don't know how it shows on the screen.
Okay.
Maybe I should make the here. Let's do screen focus so that I can go here. Windows maybe. Screen focus or basic scene. Nope, that killed it. Give me a second. I'm gonna make this make it camera focus. You know what I mean? We'll do add. I think webcam 1 maybe. Is that it? Yeah, there we go. Okay, so now it's just us. Okay. But, I want to point out here that this chip at the very top here. I know it's kind of blurry, but just this part here, just that part here, the point I'm touching with my finger, that's the actual chip itself, and it's tiny. It's tiny. I'd say like that little chip is just about the size of like the tip of my pinky.
Maybe a thumbnail, perhaps.
Yeah. And it's got this little squiggly thing at the top. That's actually the antenna. That's how it does its Wi-Fi stuff. So that chip there has actually been mounted into another board. That I think that down here you can see it's got like I think that's the power supply unit there. The voltage regulator. There's a couple like I see. It's a USB chip. It's a 232R
it's an FTD.
Yeah. FTDI thing.
Yeah. It allows it to communicate via USB.
But without those components, this little chip at the top would probably just be completely functional. But it gives you a lot more nice kind of features.
It gives you flexibility to hack away and program at it.
Oh, it's got a little flash button and a reset button. I know, it's still really cool. My favorite thing about this by far, though, is the fact that it's got I got this little breadboard piece, and that's just going to make it
compatible with our Arduinos, actually. So
yeah.
It's the same pinout structure as Arduinos.
Yeah. So we can literally pin this out and use it just as is, because we actually have on here written on the side like D0 to D9 and stuff. Although, actually, wait, where's the other side? Oh, I see. That's there. Where's like D9?
Let's see. D9 is usually on the side. Let's see. I guess if we're going to use this, we're going to change the pin out because the link has D. I guess we're going to use D0 to D2 in this case.
Okay, let's do that. Let's do that. So let's just
change around.
Yeah, let's just erase this.
This we're probably not calling our Arduino, which is called ESP in this case.
Should I go get an Arduino maybe?
Should we? What do you think?
I probably should. Yeah. I have to go take a look for it, which means that might be another moment. Okay, I'll be right back. I'm gonna try and find an Arduino. Okay, we'll save this one for a project which we can fully use its capabilities, because it's got Wi-Fi access. So basically, I could put a server or something like that on it. So maybe we'll save this for a different project. But I will go find an Arduino Uno, and if I can't find an Arduino Uno, I'll grab a Hackduino. So actually, do you want it to be on the camera focus, or do you want it to be?
I guess we're good here. So this is what we have. Camera.
Okay, that's probably fine.
That's fine. So.
Okay. Okay, I'll be right back.
Okay.
1 moment.
Sure.
Is my Coke over there? Is my drink over there?
No, looks like it isn't. Or is
No.
yeah,
Is
this?
Yeah.
No.
That's an apple drink, though. I'll be right back. Okay, I'm heading downstairs.
Okay. All right.
I found one. Or I found one that I was using for something that
Okay.
I just want to show what I was using it for on the stream first. It's the one that we were using for the ARFIDs.
Oh, okay. It's still wired up, and you can demo it in something.
Yeah, I guess I can demo it, yeah. But you can see here I actually have this thing set up for ARFID. So cool thing is that you plug in there and then you take your ARFID ID and you scan it, and it'll tell you a bunch of information about the ARFID, which is really cool because I managed to make actually an access control system, which was neat. You were able to like scan it, and then you could like register or deregister IDs, and then there was like a master ID. It was a really cool little system, and it was just like based off of an access control system I found that someone had already made. It was really cool. I mean, why invent the wheel? Why reinvent the wheel when you don't have to, right? But yeah, I guess we'll demo it. Might as well. Well, it's all plugged in together. Let's throw the ESP back in here. Also, I searched all the way downstairs to find this little cord. This is the cord you gave me a long time ago for Arduino.
Oh, okay.
And it's like the perfect size because it's not
Too long. Not
15
too short.
feet.
Oh, that might be a little bit short in this case.
Yeah, you're right.
Mm-hmm.
What I could do
Do you have a
is
cable?
I do have an extension cable, but I would have to unplug the camera and then replug it back in.
Do you have any spare cables downstairs?
I do, but they're not reliable.
Oh.
So give me a second. I can reset the camera here. It's got the properties, deactivate, reactivate it. That should just do it. Yeah, see, I don't know why this camera works more reliably than the one that's expensive one. And I bought it for like $15 on Ali.
Another hint: if you need a webcam, buy one on AliExpress from China.
Yeah, they're ridiculously cheap. Okay, setting up Arduino Uno. Okay, let's open the serial monitor. Oh yeah, I guess let's go back to the build stream so they can see what I'm doing. I'm thinking I should probably open up the stream on my phone so that I can keep track of anybody. Oh, are you on the stream on your computer?
Yep, I'm on it.
Okay, cool.
There we go, right here.
Okay, good. Okay. So actually, yeah, let's do a quick demo of what this thing does, because all I gotta do is open up the serial monitor if I can. Port COM6. There we go. COM6. Serial monitor. There it is.
Yes,
Look at that.
it's live.
So I'm gonna be right back. I'm just gonna demo this thing quickly because it's really neat. The intention was that we were gonna try and make this into a dual disc at some point, and put the ARFIDs that like, you know what I mean, like take the ARFIDs, take the specific ID of the ARFIDs, register some sort of playing card, and then note that when you scan that playing card, you get the specific like card. So it can read Blue Eyes White Dragon and stuff. Okay, I'll be back. I'm gonna go grab the ARFIDs. Might as well show it, right?
Yeah.
Okay, it's clear, Alan.
Okay.
stuff. Ooh, that was fast, actually. I think I'm getting more organized. Slowly. Okay, I'm back.
If the internet is slow for you, let me know.
Yeah, no problem. So what?
Watching your stream and your latest YouTube video.
Oh, thank you. Cool. Okay, so we've got some stuff here. We've got a bunch of LEDs I brought in. A red, a blue, and a yellow LED, as well as some power resistors. So I brought 3 220 ohm resistors as well, and that'll be just when we complete our stream deck. I really want to quickly show what this RFID thing does, and for that to work, I also needed to go downstairs to grab the IDs. So you can see I actually have a bunch of these little IDs and stuff like that here. Let's just use the cards for now. There we go. My entire desk is covered with random crap. It's important to know that you're working. Otherwise, nobody would actually believe that I get work done here.
My secret is to have a small desk and pile it with shit.
Yeah, that way people know you're super busy.
Yeah.
Okay, so so we've got our RFID. It's hard to tell, but yeah, you just want to. You can actually show.
Does it go through
with the light. I think so.
Is it? No, it's just
kind of.
Oh, actually, no, you can't. So I have to hold it back.
Oh, okay, yeah.
So I have to hold it at that distance. So I don't.
Yeah, you can actually see through the card if you put some light on it.
Shows up or not.
That show up in the stream. Oh yeah, there it is. There it is.
Go. So
nice.
So inside these cards, like a credit card, there is a little chip with an antenna, and that's what you're seeing through here right now, the little antenna structure. So what happens, you bring it close to an RFID, a magnetic field from an RFID reader stimulates that coil. It creates a very tiny current that gives it momentarily enough power to power a little tiny grain-sized chip there that sends out a signal back. That's how RFIDs work.
Yeah. And what we can do with this little system here is there's the RFID ID reader in here that allows this to energize. And if we scan it, you'll see something here on the screen. Here we go. Maybe it should work.
Do you think it need to be programmed?
Maybe this one isn't programmed.
How about maybe one of these ones?
Yeah, let's try these ones. Oh, the paper ones worked really well last time. I think that maybe some of them aren't in the system, so if they're not ready to be scanned.
Ah, there it is.
Oh, there you go. Welcome. You shall pass.
We all hold it up. Welcome. You shall not pass.
See, this one is not registered inside of the system, but this one here is. So you can see that this is a good ID. It lets you in, and this one here does not. Now, in order to scan the Yu-Gi-Oh cards, I needed to get smaller RFID chips, so I ended up buying these little paper stickers. And would you believe that that's a chip? You can see you can scan it, and this one's not one that's registered. But if we keep going, one of these ones will actually be the master pass.
There it is.
This one's good. The other one was not. This one is good. This one is good. The crazy thing is I scanned these like years ago, which means that this chip inside of it has stored this information from years ago, even after from being depowered and stuff. Because I think it's written to the EEPROM memory.
There's just a little bit of flash inside.
Oh, wow.
Yeah.
So one of these is actually going to be the master chip when I get to it. One of these paper ones, I'm pretty sure. Is it this one? No. This one? No. This one? There it is. This is the master chip. So this one right here is the one that allows me to add more RFIDs to the EEPROM. So I can take any of these other ones that didn't work, like this one. I can add that. So this one is now added to the memory. That's crazy, right? That's crazy. And I thought this entire program was brilliant, and I guess I have to go back to the actual code to see who made it and give them credit. Let's take a look. I think I still have it on my computer. Or actually, I might not anymore. Yeah, I might not actually have this program anymore, but I'm sure that if you look up RFID, you'll find this user access control, because this is such a really cool program. And when I load this to YouTube, you guys can be sure that I will put it in the description down below who actually made the code, because I'll have probably been able to look it up by that time. But this system is pretty cool because it uses the actual flash memory on the chip in order to remember stuff. So even when I unplug it, it still remembers all the different little IDs inside of memory. It's so cool. I definitely want to learn and try and do more projects with EEPROM, but you know what? I'm just going to give a good little view there, and when I come back, I can go onto the stream, and I'll remember how to hook this thing back up again, because I'll just be able to go back to my stream at this point in time.
Documentation, who needs that?
Yeah, yeah. Okay, let's rip it apart.
Okay, too late now.
Yeah, it's too late now.
Trust the stream as shows up.
Yeah, hopefully I got a good image of it. Okay, I'm going to put all my RFIDs away. But this is such a cool thing, and I definitely want to do more projects with RFID. If you guys have any cool ideas of stuff to do with RFID, let me know. And we'll try and make it next time. Okay. I'm going to put them all in the same bag. I don't care. I'm a savage. Okay. So
now this is the basic Arduino that we mentioned. It was originally created as an open source hardware project in Italy, because previously, if you want to have some kind of microcontroller for a project of some kind, you had to go with bare chips. The PIC chips were really popular. Atmels have always been, but if you wanted to use an Atmel, you actually previously had to buy a programmer, had to learn assembly language, you had to design your own circuit and stuff. So the people behind the Arduino project said, well, life's too short for that. So design this board to do all that stuff where it's already pre-wired. It has a nice programming environment. You program not in assembly, but in essentially C. It's a great project. Lots of people use it for more than...
you can do so much with this board.
Yeah.
The sky is the limit with this board.
So something this actually shows up in professional products as well too. They start with Arduino. I'm really happy with all the software configuration. They boil it down to, as you know, a bare Atmel chip.
Yeah, and actually you can see the chip on here. If I bring it really, real close, actually let's switch to the camera focus again so you guys can see it. I'm going to get real close here. You guys can actually see the chip right there. That's the chip here. And I actually have with me some of my Hackduinos, so you can see how you take that chip and you're able to create your kind of own board, because all the other stuff that's around it, this is like the extras. You don't actually really need this. The heart of the whole operation is right there, and it's that little Atmega 328P-PU chip. That's the brains and really the heart of the whole operation. And I'll just put that off to the side, and I'll show you what you kind of do in order to make a Hackduino. So in order to make a Hackduino, you take that same chip and you put it into, what's a nice one here? Let me find a nice one here. Here we go. This is a good one. So you can see here that you actually just take that chip
side by side,
and you can see that this thing actually has some of the same components. Is that you can see there's this crystal here, crystal there, right there, and there's a crystal over here too. And they both do the same job, as they set kind of the clock speed of the chip and ensure that it kind of runs at a certain speed. Up here you can see there's like a reset button right here. There's also a reset button over here on the Arduino. That's kind of the thing that you kind of have to add yourself. And there's other features too that, of course, because they did surface mounting, I didn't have enough room. You can actually see on the back, you don't actually see any of the traces. You don't see any of the traces, but if I turn on the back here, it's like, whoa, what? Oh my god. So, sure, when you buy a chip, you do save money, in quotes. But I do see why Arduino made their project where it's all nice, one printed breadboard, because you don't have to do all this extra work in order to make it functional. You just gotta plug it in. In addition to this thing doesn't have USB on it.
So what this one does, it plugs into, has a USB port which you plug in the computer. With the Hackduino, you actually had to buy a programmer.
Yeah.
In order to kind of actually talk to it.
I don't actually have my programmer up here. Maybe I'll show you guys that next time. But it's actually a little device that hooks into the side of this, and it kind of changes them into a little connector that can hook into this part here, which is like
the SPI connector. That's a protocol for communicating directly to the ADMega.
Yeah, it's was it ICSP?
Yep.
And it's like I don't know, it's just like one of these little connectors. Like I don't know if it's a Molex connector or whatever, but it just sticks on there, and it kind of allows those 6 pins to be translated through the serial. It's a really cool device, but it's like another $3 or something, but it allows you to program endless amount of chips. And not just to mention that if you have the kind of the project in mind for this, you can actually save a lot of room by just using the chip and only hooking up the components that you need, rather than having this kind of whole package, because the whole package here is there for convenience. It's not always because you're going to use everything there, but because it's nice to have when you want to start wiring things.
Stuff.
Yeah. This is a really cool package, though. It's really great. If you want to just get into electronics, definitely recommend getting an Arduino. Aw, yeah. Okay, so let's get it all fired up. So first thing we're going to do, we're going to plug this bad boy in.
We should demonstrate maybe a blink circuit first?
Sure. Yeah, let's do that.
And then we'll talk about doing that.
So let's go back over the build stream here so they can see what we're doing. And we're just going to open up a basic blink sketch. I don't know if we even have one of those. Oh, no, this is a fresh install.
Actually,
so let's just make one.
Actually, it's already in there. If you go to File and go to Examples.
Examples? There?
Yeah, Basics. Yeah, Blink.
Basic Blink?
Yeah.
Blink.
Yeah.
Oh, nice. Here we go. So here's the original just Blink sketch. And you can see at this stuff at the top here, this is all grayed out. So this is just a note. Comment. So you can actually add comments by adding in, I think it's this, is it the slash here?
Slash star, and then end with a star slash, or double slash in beginning to a single line comment.
Yeah.
So it's essentially C. If you know C or C++, you know this. Or JavaScript or something.
Yeah. The only thing I think is a little bit different from C is that I don't think C has the setup. This setup is very special to Arduino.
Yeah, so this is it's a function which exists in C, if you know what we're talking about. But on Mac, there's 2 functions that the Arduino software environment needs to have that you have to create. One is a function called setup, which sets up the whole thing you want to do, usually initializing pins, hardware, variables that you need, loading information, that kind of stuff. And then there's something called the loop function, which means it actually repeatedly does this thing over and over again inside that particular function, and you have to figure out how to cleverly take advantage of that in order to do all this stuff.
And so the loop continues doing the work. So whatever in here would be the workload, hopefully polling and then adding or changing variables in order to do what's necessary for the work to be done. In this case, it's really simple. So let's talk about this setup function. We go up to setup, and we set the pin mode of this pin here, this is actually I guess a hardware constant.
Yeah, it's a constant.
It's a constant.
Which
So
is really a number 13, right?
yeah, I think it's 13. It's pin 13 on the Arduino here.
Yeah.
So pin 13 is actually a wireable pin, but it also goes out to the built-in LED, which is actually right here.
Yeah.
So actually, if you see actually where pin 13 is, the LED is like right beside it.
Yeah, it's another convenience.
It's really blurry, so
yeah.
I'm not going to try and show you guys. But if you look on the Arduino diagram online, you can actually see that the LED is like literally right beside pin 13. So it's in the same area. And this LED underscore built-in just refers to pin 13. We could type in 13 and it would have the exact same result. Down here in the loop...
we should tell it's configured as an output, because all these pins are totally flexible. You can actually have receive signals or put signals out. Each one of those pins can be configured to whatever you want to, which is nice. So then they're not dedicated to one purpose.
But this is how you would set the output, input, and then when we said like input pull-up, this is where you would configure that.
Yep. So in this case, we want an input. We'll do input pull-up. I think it's pull-up. I think that's what it's called. I can't remember exactly. I think that's.
Yeah, I think it's called pull-up. Yeah. We'll go look it up when we need to.
Later.
But this is how you set that kind of those pin modes, and it's really important to set the pin modes, because if you set them incorrectly and you start trying to put inputs in your outputs and outputs in your inputs, you could run into some problems. Okay, so down here in the loop, we have only really 2 things happening right now. I'm just going to do a little space here. The first thing we're going to do is digital write, which is our special function in Arduino that lets us choose the level or choose the output of a certain pin.
Puts a signal on a pin.
Yeah, puts a signal on a pin. So in this case, we're writing to that LED built-in pin, which is pin 13, and we're setting it to high, which is 5 volts. Then we have delay 1000.
That's another built-in function in the Arduino environment.
And I think it measures in milliseconds, Alan?
Yeah, it would actually cause the program to stop for that number of milliseconds. 1,000 millisecond, 1 second in this case.
Yeah, and it literally just stops the program. Like, the program can't do anything in the delay time. It just stops.
It stops before it doesn't progress any further until 1,000 ticks have actually gone by.
So it does digital write, sets it to high, and then once it hits delay, it literally just sits at delay until the program says, okay, you can go. And now we move on to the next digital write, which is LED built-in low. So that's going to shove it down to the ground, and it's going to turn that pin off. And then we're going to wait another 1,000 seconds until the program says, okay, you're good to leave.
However, it doesn't leave because it's a loop.
Yeah.
And instead, what does it do? It goes...
jumps right back up to the top again. Keeps on running and running. Now, there is a way that we could stop it after a certain amount of time, but that would be, we would have to set some sort of variable, and then once that variable got into a certain level, we could then say, okay, stop, or break loop. But in this case, we don't have any such variable, so it just keeps on going and going on going until you run out of power. Or until...
the heat death of the universe.
Yeah. Till the cows come home, basically. Okay, so let's hook this up so that we can see what it does. I'm now going to upload it. Yep. In fact, I don't even need to wire anything up in order for this to work. All I got to do is upload this thing. So let's do that.
Yep, compile and upload. So essentially translate this kind of code, which we understand, into code the chip understands at Mega Machine Language.
Oh, I should also mention that, oh, here we go. Here's a common problem that a lot of people have, is it says serial port not selected. So what is a serial port? A serial port is just how your computer determines where things are on your USB port. In this particular situation, all I gotta do is go down a port, and you can see that there's 2 comms. COM 1 is probably something else that it's detecting, and then COM 6 is the Arduino Uno. I'm willing to think that this COM 1 might be the webcam I'm using, just because it's such a simple device. But if we go to COM 6 here, it should be, yeah, it's detecting everything now. And you also want to make sure that your board is set to the correct board. If it's not, you're going to have some problems. So once those things are set correctly, I can now verify it, and it's going to tell me whether or not the code is readable and good, and because it's an example, of course, it's working. And we just upload that sucker.
And we kind of hold it up to the screen. It's blinking lights, and that's its communication, and it should be blinking now.
Done uploading.
Upload it.
So there you go. So actually, let me bring this over so you guys can see it. Maybe I can make it a little bit bigger. Yeah, I'll make it a little bit bigger so y'all can see the actual light in there. So you guys see that little light that's going on? I don't know if you guys can see it. There we go, like that. You know, I'll bring it back a little bit. But this light here, right there, that's the pin 13, and that little light is going on and off, on and off, on and off.
For 1 second interval. 1 second on, 1 second off.
And that's because of what we programmed. Now what we can do is we can actually expand that pulse outwards, and we can have it control something else so that we can make that signal brighter. Let's do that right now. So I'm going to take my, which color should we use, Alan? Red, yellow, or blue?
I think red will show up best.
Probably, yeah.
Blue sometimes kind of whites out, so to speak.
Okay, so what I'm going to do is I'm going to put my LED in right across the gap there. Yeah, and an important thing to note is that your LED is pointing in the right direction. So you can see there's a long leg and a short leg. The long leg is the positive side, and the shorter leg is the negative side. And you want to go from positive to negative, or else it's not going to work, because diodes only run in one direction. And from there, I'm going to need a current limiting resistor. So in this case, I'm using a 220 ohm resistor. You could use anything bigger than that.
Usually up to maybe about 680 ohms, because if you go any higher than that, then it starts to become too dim.
Yeah. You could even go less, but then you have a chance of burning out your LED. So
yeah, don't go below anything like 150.
Yeah. You're probably even safe with like 180. Here we go. So now I've got my LED in. It's going to the positive side. We'll be going to our chip, and then the negative side goes out through that resistor. So if you guys can see that those are actually in the same channel. I don't know if I'm able to show that, but basically this negative leg is actually connecting up to this side of the resistor, so that I actually have one complete circuit. And if I actually put this wire in here, you can actually see these would actually be like a complete loop, right? One side going in the positive, going through the negative side, through the resistor, and then out to ground. So let's hook that up now. So we've got one side here, and we're going to need one side on the on the ground. So let me grab one more jumper. Let's use a black jumper so that we can keep track of it being the ground side.
Tradition, folks.
Yeah. It's bad voodoo to mess with that kind of stuff.
Yeah, you don't reverse it.
Yeah.
You're guaranteed to have an explosion to reverse the colors. Yeah. Red is ground. But black is ground.
Okay. Yeah, it's definitely good to try and obey the colors. If you try to cheap out, or if you do what I used to do when I first started doing electronics and try and use one color for everything, you're gonna have problems. You're gonna have a bad time. Because it becomes way too easy to accidentally cross the wires because you don't know which one's the power and which one's the ground. So it's a nightmare.
Yeah. Never want to hook power directly ground.
No, because then the entire circuit becomes a gigantic fuse.
Mm-hmm.
Yeah, that's not a good idea. Okay, so let's we're gonna take this guy, and we have two little outputs here, right? We have two pins. We have this one here, which I use orange for the power, and then this side over here, black, for the ground. So what I'm going to do is I'm actually going to look on the Arduino, and I'm looking at the pins here, and I'm going to find the 5-volt output and the ground, and I'm just going to plug them in. And that's going to turn the LED on.
In this case, we're not doing anything fancy. We're just using our $20 Arduino as just a battery.
But wait, we want to go a next step further, right? We want to go a next step further. We don't want it to just turn on. We want it to blink. So now what we're going to do is we're going to use that pin. And what pin was it that we were using? We were using pin 13. So, yeah, let's go to that pin 13. So I'm just going to take this wire. Right now it's hooked up. This orange wire is hooked up to 5 volts. I'm just going to take it. I'm going to move it over to pin 13 where I see it currently blinking. And you'll find something really interesting. As soon as I do, it's now obeying that signal from that pin, because that kind of on and off signal is literally just a signal, right? It's coming through this pin, and depending on whether or not it's high or low, it's changing,
providing that voltage.
It's providing that voltage here. And it's not that it's stealing that voltage. If I actually uncover the Arduino underneath, you can actually see the pin that's on pin 13 is still actually flicking on and off.
Yeah, so the output pins Arduinos, for people who know what it means, it's able to output 20 milliamps. It's able to source that much.
Yeah, and if it tries to source more than that, you can actually damage your Arduino, and that's bad. You definitely, if you want to try and provide more power with your Arduino, you're going to need to make use of other components in order to.
That'll be a later stream when we talk about transistor theory.
Yes.
Stay tuned for the summertime show.
Yeah, we'll do that. We'll do that when we start working with the big motors and stuff like that, because those are definitely going to need more juice.
Yeah, I showed this on the stream a little bit earlier.
Oh, what's that?
Remember those little cheap motors you got for your students?
Yeah.
They didn't work well because they spun too fast. Recall, right?
Yeah.
This caused wheels to skate. This is a gear box.
Whoa! What?
So I got it in Thingiverse. So what happens? It's 4 gears inside. It's a 16-to-1 reduction. So therefore, it drops it down from about 3,000, 6,000 RPM down to roughly about maybe 100.
That's sick.
Mm-hmm.
That is so sick.
And it also increases the torque as well too, because that thing doesn't have any torque normally, but this now does.
Wow.
Yeah, so one of my students, he's actually working in robotics at his school in the robotics club. So I said, well, I told him we'll work on stuff together. So we need a robotic platform. So I said, I'll just help him put together.
This is so sick.
Yeah.
You got to send me the files for this.
Yeah.
That is so cool, because I got a whole bunch of these crappy little motors.
Yeah.
And it would be definitely awesome if we can do something like on the build stream that we're changing the motors and like doing something cool with them.
Yeah.
Because right now the motors aren't very useful by themselves because they spin so fast and they have such little torque that they're just not useful. It doesn't do anything. But if you can convert that kind of mechanical energy into like a much slower but more useful and more powerful kind of rotational motion, it's going to actually become useful. It's going to be great. Yep. That's awesome. That's really cool, Alan.
I tested a little bit, yeah.
I'm unreasonably excited about that.
So those are things that we can do.
All right, so back onto the Stream Deck. Back onto the Stream Deck. Before we go off on a tangent again. So now we have our outputs and we have the thing blinking. What we want to do now is we want to try to get a button to control an LED. Why don't we do that? So now what we have to do is we have to be able to read the status of a button. And I guess we'll just use the built-in LED.
Actually, we can use that one. It'll make more obvious for people. We can actually...
Yeah, that's right. Yeah, we'll just use that one. Yeah. And then now what we got to do is we got to do what I said before, which is hook up one of these buttons to ground and the other side to some sort of input pull-up. So we're going to do that right now is I'm going to grab another black wire. Okay, that's not a good one. Let's see here. Maybe this one will do it. Here we go. There's so many wires in here. Ooh, careful. Thank you, Alan. Nope, that's not good. Maybe in here. Oh, here we go.
See, it just randomly pops on.
Okay, so now that's gonna go here, and luckily there's another ground that I can plug into right there. And really, all I can do is I can just daisy chain them off that.
You can tie the common ground here, probably.
Oh, right. Yeah, no, that's a good idea. I should do that. I should plug it in over here. So I'm just, right now, just jumping one of those buttons onto the common ground. So I'll just lift that up so you can see. So there's a button here, and it's just going to the ground of the LED right now. So now I'm going to hook up the other side of the button, the other side of that contact.
One of these?
Yeah, let's grab one of those. And I actually want to get 3 different colors. So let's get a yellow, a green.
Should we just do one button first?
I know, I just want to get the jumpers out now ahead of time because we're going to do that eventually anyways. But let's let's use yellow first. So yellow is going to go here, like that. And then from yellow, we're going to go into our input, which we should now decide in the program what button we're going to use as our digital input. And generally speaking, you're probably going to want to use one of the specialized Arduino input pins. And those are actually labeled on the Arduino as A0 to A5.
Those are the analog ones.
Oh, that's not the one we want to use?
I want to use the digital ones. So this is why people use the D pin.
Oh, right. The analog input is only for sensors and stuff, right?
Well, you could. You can also configure them as digital, but you have to configure them. It's easier to leave them as analog.
Yeah, just leave them as analog, right? Because that's supposed to like give a variable voltage input, whereas digital input is like wants to have like logic signal.
Yeah, 1 or 0, either higher or ground.
Let's use digital pin 2 because digital pin 0 is the receiving pin and digital pin 1 is the transmitting pin. So we're going to use digital pin 2. That seems like a good choice. So we're going to go back to our thing here and let me open the build stream so you guys can see what we're doing.
Yeah. Although in practice you want to avoid using those 2 pins because those pins are actually our serial pins as well too. You can actually communicate to other devices using serial or pulses and stuff. So you typically want to not use those pins, but in this case we don't have any serial I/O, so we're going to use them.
So here we go. That's the reason why actually I'm avoiding using them because I'm like, it's just out of habit. Yeah. Because you can use the transmit and receive to do all sorts of things. It's just habit to kind of leave them available.
Flexibility if you decide to extend the circuit, so then you have to reconfigure things later.
Okay, so right now I'm plugging into T0, or sorry, D0 or D2. So D2 is going to be
pull-up input.
Pull-up input. Would that be pin 2?
Yeah, just pin 2.
So it would be. So we're gonna go to setup here, and we're gonna do pin mode, and we're gonna set our parameter, which is gonna be pin 2. And we're going to set that to input?
I think it's pull-up, I believe.
Pull-up.
We can check the help. One thing to do is that you can also refer to help. We go to help, you can actually get a whole list of...
Pull-up. There, input, pull-up. And then you have to put a semicolon and your statement, right?
Yep.
Okay, and then from here, we're also going to go down to...
LED? Yeah.
Pin mode. And we're going to say 13, or we could do LED built-in.
Yeah.
We'll use that one because it makes more sense. I like seeing words instead of numbers. Then we're going to set that one as an output because we're outputting a signal to that. So inside of our loop here, what we want to do is we want to read the button. So we're going to say, digital write, LED built-in. So we're going to write to the LED built-in. And what we're going to write to it, we're going to write in the status of pin 2, right? So what would that be? That would be digital read.
Yeah.
Digital read pin 2. Is that all we got to do?
That's what we do. You don't have to specify what output is. Yeah.
And let's just try that.
Let's run that.
Okay, so let me say I'm going to save it as. It's always good to save it. And we're going to do Stream Deck test. Well, Stream Deck. Should we call it Stream Deck test?
Stream Deck
test 1.
1.
Okay, so now let's just upload it and try it. It's compiling.
Uploading. Done.
Okay, done. Okay, so right now it's on. But if I press this button,
it goes.
It seems to turn it on and off. But the weird thing here is that when I'm not pressing the button, it's currently on.
Why?
But when I press the button, it turns it off.
Can anyone out there guess?
Why?
You there? Do you know what it is? How about you?
Why on earth is it doing that?
Okay, what is the default state of that connection?
Oh, because it's an input pull-up, the default connection is high. So when we press the button, it pulls it to ground, which is going to make it low.
And
so
off.
in a sense, it's literally just reading the pin and outputting exactly what it's reading. So if we wanted to do the opposite, we would have to do not digital read.
Yes, I think that should.
Is it like that?
Yeah, I think it's. I'm trying to remember if it's a logical
or is it not?
I think it's a.
Is it not? Can I write not?
Yep. That's. I think actually.
Can we try it?
Yeah, let's try it. It should work.
Who knows?
Yeah.
We might as well try it. That's the great thing about Arduino, is that if it doesn't work, you can just try it.
Okay.
What do the characters on the wall in the background mean? Oh, okay, so give me a second. The top one means Tomodachi, which means friend. The one underneath, I can't remember how to pronounce, but it means love. I don't know how to pronounce the bottom one. I feel embarrassed now because I can't. It was such a long time since I did that. I did that in a Japanese calligraphy class at the Japanese Cultural Center. Yeah, I really wish I knew how to pronounce that bottom one now. I think I even wrote the pronunciation on it, but whatever. I think that it is. Okay, so back to this. What were we doing?
Okay, so we try.
Let's try this. Let's see if it's working now.
Right now, you notice it's off.
Oh, it's working.
Yeah.
Okay, so now because we have it to not, when I press that button, now it's turning on.
So in logic, not is reverses. So not of true is false. Not of false is true. I.e. flips around the logic of it.
Yeah. So let me have. I think that I should probably explain just a moment here about why that happened and why we had to put the not in. Basically, the input pull-up is a pull-up that pulls it to high. So its default state is going to be high. But when we press the button, it pulls it to ground and therefore turns it off. And that's why when we first had it programmed in and we didn't have this not statement in there,
it was on all the time.
It was on all the time until we pressed the button,
and
which turned it
off.
off. And when we put that not in there, now we're getting the expected behavior of it turning on when we press the button.
So what it demonstrates is there's no correspondence whether you push a button or not, whether it goes on and off. You decide what to do, which is the whole idea of using a microprocessor. You have that flexibility.
Okay, give me a second. I'm going to unplug it now. Because now what we want to try and do is we want to try and move on to the next step. Because we want this button to not just turn on a LED on and off. we want it to interface with the computer. Now, how do we get it to interface with the computer, Alan?
Okay, well, there's a couple of different ways. The easiest way is that, well, way back in ancient times, in the time of dinosaurs, computers were the size of rooms, and they walked the earth terrorizing their children.
You lost me.
Caveman, man. Back around, distracted money.
The only way to calculate things was bang rocks together.
You can make a computer out of rocks. Can't you? Yeah.
If you have enough people passing rocks around.
Well, if you dig in the ground, you make a mine and stuff like that. It blocks material.
Buddy, that's not what I meant.
Oh, there's also a child that we have.
Okay.
Well, back to things. Back in the ancient days, one of the first places I ever learned how to program a computer was over a teletypewriter.
Oh, you made them out of trees, right?
Oh.
Trees, yes.
What? What?
Big rolling piece of paper, literally all trees, but you had to kill trees to get an output. Type a letter, shows on a piece of paper, and it goes to our phone line, and it communicates with what's over a serial line, on-off signals in terms of sound levels to a big mainframe computer over at John Oliver High School, and so that.
It
So
might as well have been John Oliver University. You learn more than most university kids learn in computer programming.
So what it is that there's a way you can communicate through the USB port and in a serial fashion. What it is that you're going to go something old-fashioned, something that goes all the way back to 1950s technology, a terminal, which is just letters, black and white letters, no colors, no GUI. Just letters and text.
No colors and no GUI?
No, I was reading about how like the world's entire financial system is programmed in a code that nobody wants to learn anymore.
Ah, COBOL.
Yeah. Because it was programmed like that. That could create some issues.
Mm-hmm.
I think that give me a second. Sorry.
Mm-hmm.
Keep talking. I didn't mean to interrupt you.
Okay. Okay, what we're trying, so in this case, we're going to go back an old-fashioned way of just communicating purely through text. And the way that the Arduino can fake being a terminal. And so we are going to configure a terminal connection.
Okay.
Yep. And I guess that's going to be that.
Just give me a second. I'm moving this
Sure.
down here. There we go. So now I can see the Arduino because it was annoying that when I kept on going back in OBS, it was showing infinitely everything. What do you think of the chat, babe? Do you like the chat down there, or do you think we should make the chat bigger?
I think it's great.
Okay, good, good. Awesome. Okay, so
So we're going to take advantage of code that kind of makes your Arduino act like a serial terminal. So
how do we do that?
Yes, we have to import or just include the serial library.
Okay, so do we have to do that at the top?
At the top. So we can take this code.
Would it be hashtag include?
Hashtag include.
Include.
And I believe it was angle bracket serial.h if I recall.
Is it capital
I think
serial?
it's capital. Yeah, there it is.
Serial.h, like
I
that?
think it's, yeah, or maybe just serial. Like we can check the help. Again, go up to the help at the top. You actually go to the reference.
Reference?
Yep.
Okay, cool.
And we need to kind of switch over to the browser.
Chrome.
Mm-hmm.
I should probably swap back over to the full screen, as much as headache-inducing as it is.
Yeah.
They can see what the heck we're doing. So here we go. We're now in the language reference, and we're looking through here.
So we have functions. I believe that's in the library, so we have to kind of go down further to the libraries. These are just the built-in ones. Likewise. Oh, there it is. Serial communication.
Ah, look at this. When we were just talking about that, how we don't use pin 0 and 1.
And okay, so we know to kind of communicate through computer. Those additional serial ports, but we should be able to talk directly to the USB serial.
Do you want to take over for a moment? I just gotta go to the bathroom.
Sure.
I'll be right back.
All right.
I will be back. I will be back.
Yep. Oh yeah, so it looks like we're going to have to take things off pin 0 and 1 because we're going to have to use those ones to communicate through the serial connection for the USB port. So we will have to worry about the code in that way, and I just want to just double check the documentation and check the library. Yep, there you go. So we need to kind of configure the pin as a serial port. We have to tell what speed to communicate at. And we also have, within a loop, we have to just keep communicating. I shall just double check here. Begin speed. Take a look at that. We just print to the serial port repeatedly. Yeah, okay. Just had to double check our documentation. So we have to decide how we're going to detect these buttons on the board and also somehow to indicate what's actually happening. So we're going to be using the serial port connection that this thing is able to communicate to the computer with. So what happens are, at least I believe, our plan of attack is first to reach each of these buttons. Then, depending whether they actually are on or off, we're going to configure some kind of text of some kind, like perhaps something like button 1 pressed, button 2 pressed, button 3 pressed, and perhaps maybe button 2, button 3 released perhaps as well too, or off, and I'll send it through the serial port every single second. And that's just test out whether our idea is going to work, that we're able to read from these pins and also in a very primitive way communicate with the computer. Later on, we're going to actually build that stream deck. In this case, we're going to be lazy about that and actually use someone else's pre-existing code. One of the reasons we want to do that is because the serial connection, we can make it work, but to make it work with any other program, that's going to require a lot more effort. So we're going to fake it, so to speak. There's a way to make a Arduino USB pretend to be a totally different device, not an Arduino. And in particular, we're going to make this pretend to be a regular USB keyboard. Why do we want to do that? Well, what happens is that we can actually configure these buttons, when we press it, to essentially fake pressing almost any kind of key we want on the keyboard. Any letter, any punctuation, any symbol, but perhaps maybe what might be most useful is to configure to maybe hit the function buttons. And then on the computer's end, it can interpret that and do whatever you want. And in particular, OBS Studio allows you to configure any kind of key combination to trigger a certain event. So those are the macros. So that's our plan of attack to make a stream deck, which luckily enough is relatively easy these days. And it saves you a lot of money if you're willing to kind of put in a little bit of effort to put this together and also to do a little bit of learning as well too. So that is the goal, and we just want to get a little prototype working tonight. So hopefully we get that working. So waiting for Jordan to come back. See here how we're going to do that. I'm just looking at the connection here. Yep, I think that's going to be the program. So we're going to call this Stream Deck Test 2. Hit save. We're also going to help ourselves out by doing some proper, I guess, programming, which means you want to write yourself documentation. Because the person looking at this code will sometimes be used 6 months down the line. And you may not remember what your younger self actually did. And then you can look at the code and say, he was such an idiot. And we don't want that to happen.
Back on.
Hi. Alright, so I just gave people a little bit of intro of what we wanted to do and talk a little bit about how we're going to handle this.
So we're going to do on D9 to
D11.
D11? Okay, yeah.
And then our goal is actually just, this is just a simple test to make sure it's even working. So what happens, we're going to have it output onto the serial port, print on the serial port, button 1 press, button 2 press, or button 1 release, and so on.
Yeah.
So that's our goal, and that way it gives a sense of what's going to happen. First, we need to set things up. In this case, now we want to configure our pins correctly. So
okay, so let's set up here. So we have pin 2 set up at input pull up.
Mm-hmm.
Should I set up the other buttons too?
Yeah, because we want to actually have D9, D9, 10, and 11.
Yeah. So give me a second. So sure. It may look a lot different from what we wrote down on the stream inside of the... here, let me open this thing. Mm-hmm. It may look a lot different from this, but it's not.
It's effectively the same.
It's effectively the exact same.
Mm-hmm. I had a bit of discussion with one of my friends, actually. He's actually trying to get into electronics for his school. Mm-hmm. And we're talking about how to wire circuit up. He had a circuit that looked a lot like this here and says, how am I going to make these wires join like a T? And because he thought he literally had to join this, because he had a circuit diagram, or a picture of circuit, and he thought he had to make it match exactly how it looked like. And it has to be, no, it's just what it really effectively is. It's just that connector is there. You don't have to get a siren and make that bigger wire structure.
Because you'll notice that, like, once we put this into real life, you'll notice that it looks a lot different than how it would look on the diagram.
The difference between theory and practice. Voila.
Voila. In real life, it's a lot less pretty.
Yeah.
But basically, all that I need to explain here is that all these black wires are all connected to ground. So one side of those buttons is connected to ground. The other side of these buttons comes out of these colorful wires, so it's blue, green, yellow. That's going to pin 10, 11, and 12, respectively. Then this orange wire here is literally just the wire that's coming off of D13. Which, again, is not really necessary, but it's kind of nice to have that extra button, or the extra light indicator. So, yeah. Should I hook up the other indicator lights, too?
I guess we could. So,
yeah, might as well, right?
That way we have indication on everything.
Give it a second. Might as well. Might as well. So, let's hook this guy up. Like that. And I'm also going to hook them up. It's kind of similar in the way that the buttons are, just so that I'm kind of mimicking the button setup. Mm-hmm. And we're going to put them all, I guess, here. Because they all got to kind of line up with the resistors, because each of these LEDs needs a resistor. Just so that we're making sure that the amount of current going through it is all the same. Okay, okay. Just double check that's going to ground. That's all going in there. This is going to there. Yeah, that's good.
We need I guess we need to configure conditional pins. So maybe we'll change those from input from.
So
actually, maybe we'll do it from
8, 9, 10, and then 11, 12, 13 for the LEDs. That's a good idea.
Yeah,
that's a good idea.
Or maybe 11, 12, 13 for the
For the LEDs, right?
LEDs, yeah.
Yeah, that's what I was going to do.
Yeah.
So give me a second. I'm just going to use all orange for the LEDs because they don't really need different colors of pins to know which ones they are because they're all just outputs. Is there another orange there or maybe another red?
You're looking for any other... Yeah.
Here we go. Perfect. Thank you. Now, it may look complicated, but it's still essentially the same circuit. It's just the same circuit 3 times. Each button is hooked up to ground and to one of the pins, and the LEDs are hooked up to ground and one of the pins. With a only difference between the buttons and the switches is that there is a resistor that prevents that just limits a certain amount of current to go through the LED so they don't burn out and die, and that's a good thing.
Yeah, because LEDs are like light bulbs. We just hook the power and they go on. They essentially have very low resistance, and it just hooks them up directly and burn out too much current flow through them.
Yeah, if too much current flows through them, it just they heat up, and they have what's called thermal runaway, meaning that they blow up. One moment, I'm just rehooking this all up so it's all nice and clean. There we go. But that's one part of the things, the reason why I love diagrams, is diagrams always look so pretty, and then when you get to the final product, you're like, ugh. Real life. Why are you so difficult? Okay, so here we go. Here's the full final thing all hooked up. It's kind of a mess now, but you guys can see that all these LEDs basically are hooked up to one of these pins, and then each of them go through a 220 ohm resistor, and then they go through this black wire to ground. The black wire here is also jumpered over to this side so that these buttons all have a common ground. And literally the first ground is daisy chained into the second ground, and it's daisy chained into the third ground. And then each of those buttons have a pin now too. So, I don't know if we really need to draw another diagram and explain how the other pins are hooked up. Maybe I should, just to very quickly explain. Should I? I should probably should. Yeah, I'll do it.
We can add that later, I guess, after the...
Yeah, we'll do it after. We'll do it after. Because I think that most people probably know how to hook up a LED. So let's go back to our code now. Okay, good. So now we have included the serial H, and we need to set up our pin mode. So we're going to set pin mode for 8, 9, and 10. So pin 8, pin 9, and pin 10. And they're all going to be pull-ups. Which, again, remember, because we did our little experiment before, these input pull-ups are going to default to being high. So when they're not pressed, they're going to be detecting as high. So if we want to take this here and make some sort of like readable or more accurate version of these statuses, we may want to set them inside of a variable and then also not them so that they are the opposite of what they are, so that when they're not pressed, they're low, and when they are pressed, that they're high. I know it's a little confusing. You kind of have to do a little bit of mental gymnastics, but you kind of... It's only because of that pull-up. Normally, it would just detect high and low. LED built-in output. Oh, and these guys would not be LED built-in. This would be pin mode 11, pin mode 12, and pin mode 13. And we're gonna explicitly state pin 13 instead of LED built-in, just because in this situation it's more helpful to be explicit. Okay, so now we have our pins all set up.
There's also another thing we need to do, because we want to be able to communicate with our computer through a serial port. We also have to initialize it, and we use run serial.begin. And in this case, we put the baud rate, which is 960 bits per second.
Okay, sweet. So now we have our 6 pins set up. our 3 button pins. So let's just write down here, button pins. And then we have over here our LED status pins. And really, this is really important to make sure that you set these up properly so the Arduino knows what to do and where you're receiving stuff. And over here in your serial output, this is so that, remember before I had that little serial monitor, it basically reads information through the serial, and then it spits out information back to you. This is what starts that, so you can read messages and print stuff to them, and then give yourself output. This is probably one of the most useful debugging features of the Arduino, actually, is this serial here. Super useful. Okay, so now we're going to go down to our loop. I think the first thing we're going to do is gather our information. So we're going to do button 1 status. Can we do that, Alan?
We need to create, it has to be var.
Oh, right, var?
Yeah, but you want to initialize it outside the loop. No, it should be fine. So var, you need to give it a variable.
Button 1 status?
Yeah.
Equal to digital read pin 8. Is that okay?
Yeah, that should be fine.
Var button 2 status. Oh, actually, I want not digital read, right?
Actually, so not var. I think about JavaScript. It's actually be int.
Int.
Yes.
Int.
Yeah, there it is. The syntax highlighting is working.
Okay, so now I remember something about this. I can't remember exactly, but this int basically determines the type
of
variable. And depending on what kind of number that expects this to be, this beginning part, this int, is going to be different. So I think that there's like, integer is literally any real number from like negative infinity to positive infinity, right?
Not real number. Real numbers are, if you remember the definition.
Oh, right. The real numbers is not
integers
decimals.
Are whole numbers and no fraction part, no decimals, but they can be positive and negative.
Yeah.
But in this case, computers, it has limits. So a typical int on a 32-bit computer is something roughly -2 billion to +2 billion.
But if it's a smaller number we expect here, we can use a different kind of here, right? We can use like num or something, or
actually, there's shorthand. But in this case, it wouldn't really bias anything because typically the ideal format we want to work with 32-bit. If we can actually optimize it, like we can also use Boolean as well too. So bool, yeah.
Bool is a better one to use because it'll use less space. I don't know. I'm not sure how that works, but
well, because it's 1 bit versus 32 bits.
There you go. That makes sense. Okay, and we're going to set not digital read 9. And that's because of what I explained earlier, that the input that we're getting on the input pull-ups is actually the opposite of what we want. We want to try and simplify our variable statuses as much as possible so that it reads what we expect to read, instead of having to flip it in our mind. Okay, so we're going to read button status. Okay, so now that we have our button statuses, we want to do something with that. So what we really want to do is we want to toggle our LEDs on and off, depending on these button status. So we need a new Boolean for our LEDs. So we're going to do bool red LED, right? Is equal to button 1 status. Yeah?
Actually, I guess we'll write it directly, I guess, to the digital outputs.
Oh, right, yeah. So it should be,
so digital write.
Right, I see what you mean. I see what you mean. So give me a second.
We'll comment this is just send, I guess, the...
Send LED information, or toggle LED information.
Yeah.
Toggle LED information, because really what we want to do is we want to read the transition of the button being pressed more than once, because every single time it presses it should toggle the Boolean, right?
That's only if we use an exclusive or, but we're just essentially writing it, so we're going to not.
Oh, we're okay. We're not going to use toggle then. Yeah. We're just going to do
reflect
or set LEDs.
Yeah.
So we're just going to do it in a really dumb way right now. First,
you don't want to get into the whole debouncing thing.
Not yet.
Not yet.
Not yet. So
it's because
digital write pin 11. And we're going to write that as the button 1 status.
Mm-hmm.
And we can just reuse this over and over again here.
Mm-hmm.
So we can set this as 12,
Mm-hmm.
and this is 13. So now with just this...
Status, button 1 status, button...
Oh, right. Button 2 status,
Mm-hmm.
button 3 status. Thanks for noticing that, Alan.
Mm-hmm.
Okay, so now if we just upload this, this should be usable already.
Mm-hmm.
Let's do it. Oh, gotta plug it in. Har har. Tech support. Call tech support.
Oh, okay. It should be, it's just called serial, not serial.h. Okay. Is it serial?
I just realized something.
Yeah.
Because Arduino uses hotkeys, we could set one of these buttons to automatically upload the code. Because all it has to do is spit out the command Control plus U.
Okay.
Right? Because that's essentially what it's doing in order to run OBS commands. Is it's doing some sort of hotkey, right? So we could set it to.
Oh, but that's, we have to make it pretend to be a USB keyboard though.
That's okay, right?
Okay, yeah, but we're eventually going to retest that.
Okay. Getting ahead of myself. Getting ahead of myself. Okay, so we got the serial in here. Now let's just see if this is working.
Okay.
Wait. Oh, it didn't compile properly.
Let's double check our documentation.
Serial, no such file or directory. Should I just comment this out for now?
Yeah.
Okay, let's comment that out for now.
So maybe it's built in. Oh, I guess it's built in. Because you use this often, you don't have to include it, so it just happens. So,
oh, I see. It's backwards. Give me a second. I see what the problem is. So this should be 1, 2, and that one should be 3. Give me a second. So I'm gonna unplug it first. It's a good idea to unplug a circuit before you start working on it. So that's gonna go there. This one's gonna go there, and that one's gonna go there. So okay, so let me explain what the problem was. Is that the LED outputs were not wired in the correct fashion, so I was not getting the expected output. But now it should be. There we go. That's the first button. Second button working. Oh, and the third button is not working. What's going on there?
Okay, it's happening either on the button end or the LED end.
So yeah,
or the code end, between many possible things.
Okay, so what I'm just checking here right now is I'm just double checking that the LED is in place and the resistor is all good. Right now it looks all good. And then another thing I might want to test is if this LED is alive.
You can swap a different LED. Actually, switch LEDs around.
Oh, that's a good idea. It's a great idea.
LED.
It's a dead LED.
Yep.
Okay, so I'll be right back. I'm going to go get a new LED, and then this one can go into the garbage can. Dead LED. Bring this thing up, just because we need to use more LEDs. Is all the leftover LEDs from our kids' classes. That's probably why I ended up with a burnt out one. Okay, there we go. And let's check the chat and say hi to anyone. Nope. Okay, so now,
let's see.
If I press the first button, that turns on the red. Second button turns on the blue. Third one turns on the yellow. That's great. It's working exactly as expected. Great.
And now the next stage is do some primitive communication between this thing and our computer.
Yeah. My favorite thing right now is that This is just fun. I like making the thing blink. There's something really satisfying about getting it all working, and once you got the buttons all working, it's like, I don't know, that's just satisfying. Getting stuff blinking is my favorite part of playing with Arduino. Okay, so now we've got it doing our thing.
Okay, now we're going to just do some primitive communication, and what we do is we want to take advantage of what's called serial print, which we can print anything to the serial port. So what we do is that we have to just, depending on the button status, we'll just do some kind of output of some kind.
So we should do F?
Yeah, if statements. And the way it works is that on if we need a brace, recall, this is C. So if brace button 1 status, then we say true.
There we go.
Yep. Then we do something, which is to...
Is it colon?
Oh, that's Python. It's
crap.
Curly bracket. and curly bracket. Yep, there it is. And then we can do it. It's serial dot print. Actually, probably want print line. And then SOB, blue light on, which one? Red
light on. Really, what we want to do is we want it to toggle. So with one button press, it switches it to being on, and then with another button press, it switches it to being off. But at that point, then we start getting into debounce.
Yeah.
Because we have to determine how long does the button have to be pressed in order for it to turn on.
Unless we put enough time delay, therefore it debounces naturally.
Okay, we can try and do that.
Let's try that. So do you want to actually toggle? So we need a new variable because if you want to toggle.
Oh, right.
Yeah.
Yeah, we do want it to toggle, though. Because the idea with the Stream Deck is that the first button is going to turn on and off recording, right?
Okay.
The second button is going to turn on and off audio. And the third one's going to do whatever the hell. Right?
That can be handled by the macros eventually. So the key.
Oh, yeah, that's true. That's true.
Yeah. But in this case, we want you. I guess we just want to demonstrate, I guess, serial communication.
Yeah, let's just demonstrate serial communication for the start.
Yeah.
So we have this here. If button 1 status is equal to true, then we print the serial print line red light on. And if we do the opposite, if we have another one, so I guess it would be elif or else if.
Or do you want just else?
Or else.
Or do you want just to check another button?
Oh, right. Yeah, that's a good idea. We don't really care that much, do we?
So we just say if button 2 status is true. We just want to have messages come out when the buttons are pressed and blank otherwise.
But we wanted to do it as dirty and simple as possible. And this one's going to be blue. And this one's going to be yellow.
And I think that's all we need.
Yep.
Yep.
So let's upload it. And now here's the cool part about this is that
error.
Oh, right. Forgot my that's one thing about C is that you guys need a lot of semicolons.
More punctuation.
Yeah, it's important. Okay. You sprinkle some semicolons in there, and that's how it all works.
Hey, done uploading.
Okay, cool.
Now, of course, we want to talk or listen to this. So the blinky light works.
Yeah, so the blinky light parts works.
So hold up, blinky, it works. But does the computer know anything about it?
Nope, not at all.
Unless we
open the serial monitor.
Yep. Ah, there it is.
So while that's on, it's going to keep printing blue light on at a rate of 9600. And the reason for that is, actually I think it'll be a little bit less than 9600 because it's literally how fast the loop can run.
Well, actually 9600 is how many bits per second it's actually doing. So
it's sending it out, right?
So
it depends on how fast the actual chip is oscillating at. So it's literally just spamming it out as fast as it can.
Although what we can do is we can put a little bit of time delay in the actual loop now. So we put delay like maybe 100 milliseconds something. That way it...
Oh, so inside the loop?
Not inside the if, but then maybe at the bottom of the loop. That way, before it goes back to top read another time, it delay 100.
Okay, let's save it and upload again. And let's run it. Oh, and we should probably clear output. There we go.
Let's give it a test.
Okay, give it a test. Okay, so now it's running, and now we're going to press that button and see what goes on. So the first button. There you go. That's much better, actually.
That's much reasonable.
So now it's telling us every 100 milliseconds when that light's on, or while that thing is on. And then when I press the last one, and there we go.
There we go.
Now here's my question. What if I press 2? Aw, yeah.
And all 3.
That's where it starts to kind of break a little bit, but that's okay. It's still reading them, obviously, because you can see that it's correctly putting the outputs where they're supposed to be, depending on what's being pressed. That's so fun.
And there we go. So this is pretty well all you need to do in order to make a stream deck. You need an Arduino with buttons, possibly some LEDs, and then a way for it to communicate with your computer. And at that point, it's just all just software.
Yep.
Hardware, we're done.
Yay! Yay! Build complete! Great success! Cheers.
Cheers.
Okay, now we can screw off for the rest of the stream, right, guys?
Yes.
Okay, no, not actually.
No. So we've done the proof of principle. That's all you need. Prototype. Proof of principle. You don't need to make it fancy. Make it work. Just make it work.
Once you get it running,
then you get fancy.
Yeah, then we get fancy. So I kept on thinking that we needed to just put some sort of toggle in here, but I realized we don't really need to do that.
The OBS does that for us.
OBS does that for us, and I think that there's actually even a button in OBS for setting things on and off. So actually, this is actually a good way to check this. Is actually because we got the stream open, we can go here.
Hotkeys.
Hotkeys. Oh, there is one for start and stop streaming. So here's the question here is we got to figure out one button that can do both.
Or actually, you can do a key combination. So I believe...
Oh, yeah, that's true.
Yeah.
But that might be more confusing. Maybe I should have one button for start and one button for stop.
Yeah.
You think so, Alan?
Well, no, I'm keen to... What happened in terms of key combination, for example, you can hit Alt on the keyboard. So what happened... How this stream... How this these hotkeys work, these are actually keyboard buttons and actual keyboard.
Yeah.
So, for example, you press Alt, maybe S, that's for start, or maybe Control S to stop, for example. You can choose which kind of, quote, key combination, or double. You map it to key combinations that you would never press in real life.
Oh, yeah.
Right? And the only thing is that we just have to configure our quote, keyboard, once we have the Arduino software done, to output that particular keystroke combination where it creates it.
So I guess that within our software, we would probably... Should we be detecting the toggle in here?
We may not need to, because we're going to be,
I'm just thinking that if it has the toggle inside the software, when it makes a transition from low to high, then it can output the play signal, and then when it goes from high to low, then it outputs the stop signal.
Let's see, we might want to do that then. Yeah, so
I think we'll probably want to do that.
We can probably do that. So essentially, it'll just be a Boolean that is button 3 or whatever state it is.
I also think that this idea where you're using the delay in order to, instead of debounce is probably a good idea, just because at this point we don't really need it to be constantly polling. We just want it to be able to read the transitions. So what we want to do is if button 1 status is equal to true, and then should we also be taking track of like the last button status?
That's what you have in Boolean. Essentially do an exclusive OR, the toggle, or not actually. So how you handle that situation is that this is
do I need to also create another Boolean for like last status? Button 1 last status?
Yeah. So
bool.
Actually, no. Here's what you do is that instead of if button 1 status, you just if digital read. Yeah. If not digital read 8, then you say
if not digital read 8.
And then...
Well, give me a second. I don't understand what that means. So, if not digital read 8...
Or just say if digital read, because in this case, we're just flipping around the state. Or actually, no.
We already took it here. We already took it here, though.
Yeah. But, but in this case, we need...
If you wanted not digital read 8, we could just take the button 1 status.
No, so the button 1 status, that's where we toggle here. So, in this case...
Okay. Yeah, so, give me a second.
Sure.
So, bool button status 1 equals to not digital read 8.
Yeah, but instead of actually being a reflection of digital read, we want to use it as a toggle if something happens.
Yeah, you're right.
So, in this case, we want to change that. We want to initialize. So, those bools, we want to put them into the...
Like outside?
Outside.
Even in a setup or something, right?
Setup, yeah.
Or should we put like them up here?
It has to be outside because it has to be...
Can I put it up here?
Yeah. And then also be initialized and maybe false. All those.
How do I dedent?
I don't think. I think you can hit Shift Tab.
Shift Tab. Yeah, there we go.
Yeah.
Thanks, Alan.
You set those all to false. initially.
It's false?
Yeah. Make them all false.
Okay, so
Yeah.
now at the beginning of our session here, when we set the read button status, we're going to set the button 1 status, right?
That's going to be in the loop, yeah. So this.
So 1 status.
Oh, actually no, because we don't want you to set the status. We want you to toggle it, which is different.
Oh, okay, yeah.
So because you want it on a plus, you want to flip it around. So this is actually what the if statement's up to. Remember, if it's a button press, so that means if digital read.
If digital read 8.
And
does equal to a certain value,
true.
Right? To true.
Yeah. Actually, no, it's
Give
false.
me a second. So it should be
False,
not digital read.
Yeah, or equal equals false. Because on all the time.
But we should have it not digital read so that it's like
equal to
true is button press and
yeah.
false is not, right?
Mm-hmm.
So if not digital button read is equal to true, so this is going to be, give me a second.
Yeah.
Button 1 on.
Yeah. Button 1 pressed.
Button 1 pressed.
Yeah. And then this is the secret how you do it. So you say button 1 status.
Button 1 status
equals
equals to
not button 1 status. Let's see if you can figure out what that does.
not button 1 status. Give me a second. Let me look at that. Oh, it's gonna flip it. It's gonna flop it. It's gonna flip it to the opposite of what it was before.
Yeah. So whenever you press it, it flips around.
So button 1 status will start as false. Then when we read button 1 pressed, button 1 status is gonna flip.
But the next time it happens,
I see.
it flips it over again.
I see. That's clever. I see. Okay, so now we have here serial print red light on.
Oh, don't hit semicolon at the end of that line you just did previously.
Oh,
at the end of the line.
Oh, right, yeah. Here. And we don't want this one here. We only want to when we read the actual status of the button 1 status,
so
right?
that means we just
remove that
reflect
off.
it, yeah.
So we should also go into here and set these ones like the similar line above. So give me a second. That's Gucci. So digital 9, digital 10, and this is going to be button 2 pressed and button 3 pressed. And we want to change these statuses here: button 1 status, button 2 status, button 3 status, and button 3 status. So now we've got the same statement here, whereas if any of these buttons are detected as being pressed, it's going to flip this button 1 status to the opposite status. Now here's the thing, is I'm wondering if maybe we might end up having to make this delay bigger.
Yeah, maybe make it half second, like 500.
Let's make it 500, yeah. Because otherwise it's going to be constantly flipping on and off and on and off.
Every 10th of a second. But
every 10th of a second, right? That's probably good enough, right? 500 seconds? Let's see here. 1 Mississippi. 1 Mississippi. Maybe I should set it 1 second. I don't know.
Actually, we're going to have to do a little more sophisticated code to ignore any changes over that 100. But we'll just make it simple. Like, just make it 500 for now.
500, okay.
Yeah.
This is just so we can do it really simply.
Yeah.
So now what we do is we set the digital write 1, button 1 status, digital 12, button 2 status, digital 13, button 3 status. This part here where it sets the LEDs should still be good.
Yeah, that should be fine. Let's just run this. Let's actually not worry about the serial part now. Again, we'll make sure this works.
Yep.
The toggle, and then we'll worry about the...
All right, so let's upload this. Expected a primary expression for token.
Yeah,
semicolon in there. Yeah. Oopsies. Okay, done uploading.
Let's see if it toggles.
Okay, so here we go. Oh, it seems to work.
Yeah, it's because of our time delay aspect, because they're doing it in a primitive kind of way. Ideally, you want to...
You kind of have to press it and hold it for a good second or a good half second.
For it to register, and then we release.
Yeah. But it seems to work.
Yeah, we toggle.
I would even say that that's working.
I think if you just take this and just maybe tune the time, like maybe quarter of a second, like 250.
Yeah, let's try 250 maybe. I would argue that this is working. Because like it's reasonable to be able to just press that button of course, if you hold it, it'll blink on and off, on and off, on and off. But if you...
That kind of makes sense. It's like keyboard repeat.
Yeah. But if I hold the button, you can see it goes... Dit, 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 dit. But if I just press that button once, it actually toggles it. Now that's pretty freaking impressive, because look at that. I can have the different ones set up on and off. And I think that the key thing here is that you really want to have those LED indicator lights so that you know the status of it if you're going to be using it in kind of like this fashion.
Because then you don't want to be looking up on your
serial monitor.
If it's working.
Is it working? Is it set it there?
You want to have some confidence that it happened by exactly itself.
I say that like there's a couple times. Sometimes I press it for too short of a duration, and it. Oh, there we go. So it is a little bit finicky, I'd say. But it is working in a very primitive way.
Which is, the key is to get it working roughly right, and we're perfection later.
Yeah, because otherwise we would have to be creating some sort of debounce script. And that's actually adds a lot more complication to this.
So maybe 150 milliseconds?
Yeah, maybe 200, or let's try 150. Oops. Thanks, Alan. My allergy meds fell down.
How's that feel? Slightly finicky. I guess we have.
It's still pretty finicky. I think that we can't avoid doing this debounce.
Do debounce.
Yeah, we started disliking debounce because of because I helped my friend Bizarro make a program, and he hates debounce. So shout out to Bizarro if you're watching. I know you hate debounce, and we're doing this debounce part just for you. Okay, so what do we do? So what is debounce, anyways?
Well, debounce is because we live in an imperfect world. It's not the atomic universe.
Yeah.
Yeah, so you press a button and you think, oh, it's either on or off, but it actually doesn't.
What actually happens is the contact will kind of like go on and then off and then on and then off.
Slams and vibrates before it settles down. But because computers work so quickly, and because normally that takes milliseconds, but computers operate in milliseconds. So it doesn't look like as one single press. It looks like a series of pulses from this perspective.
And so, if you're detecting, like, for example, how long a button is pressed, it's not exactly as accurate as it's on, it's off. Because what the computer is going to detect is kind of like this kind of like hammering sensation where the button kind of bounces up and down a few times before it finally settles on, okay, now the button's pressed. So, we need to add in some sort of detection mechanism that's going to determine how long does a button need to be pressed in order to count as pressed.
Or to ignore a whole bunch of these extra pulses until a certain time delay before it actually considers that additional settings, additional on states and stuff.
Okay, so we're going to take a look here. I guess I have to do button last status.
See, we actually have to.
Or should we just go steal some code?
Actually, this is not button. This is toggle. We should really call this toggle status.
Toggle one status?
Yeah, because essentially it's not the button. We want to think about this distinctly different. The toggle state versus the actual button itself state. Because we're going to have to make a distinction because the button state is off and on a couple different times a second, but the toggle state needs to be different.
Okay. And so now what we do here is digital read 8 equals true, button 1 status is equal to not button 1 status. Okay, this is doing the toggling stuff.
I think actually we had some code previously, but probably got lost when we did Bizarro's thing. We had to create a code for that.
And we created our own code for that, and unfortunately I think it's lost to time. I might be able to dig it up somewhere though. I just don't know at this point how.
Okay, but we can go and think our way through this whole thing, and from one button.
Yeah, we might as well think it through again so that you guys understand the thinking process that goes behind this kind of thing.
So again, the whole key idea is that when a button comes down to contact, it doesn't actually make immediate contact because it hits it and bounces off a few times like this, which looks like a series of on-off presses on order of milliseconds. So the key is that the moment it detects this here, it ignores the button state for the next little while until you finally release it. And then it triggers it to be able to recognize another button state. So there's two stages. The initial button, when it hits, you put it into wait for debounce. And then what happens then is after it's waiting for debounce is wait for button release state. That triggers that. And then it can prime it for another button press. So we have three states. Waiting for button press, while bouncing, and finally wait for release.
Yeah. So we got to so when we read the transition, that's when we're going to have the debounce, right?
Yeah, so what happens on a transition, we have to enter or trigger some kind of wait for debounce cycle.
So let me think here. Let me think how we're going to do that. So digital read was true. That will detect the button press, right? Then now we're going to go into the button press mode, right? So within this loop here, this is going to be toggle status. This is toggle status.
We still want to do that, but then we want to actually only.
I know. I just got to change the variables. Here. The name of them. I changed them up above, but I didn't change them down here. And then down here too.
Toggle.
I moved the mic a little closer to you so that hopefully it can hear you a little better. Okay, there we go.
Okay, so the question is how we're going to do this. Well, we're getting into sticks now. Again, we're getting into complexity. We're going to talk about state machines.
Yeah.
So a moment ago, we kind of thought a way through what actually happened and what needs to happen. So we have to wait for a button to press, and then what we're doing, we're waiting for an actual digital read of contact. The moment it triggers that,
so that's here, right?
Yeah. So essentially, we have to trigger. But on a read, we have to think what's current state is. So if based on the current state, we actually will branch different actions. So
if it's pressed,
and then we check now its state. So if button one state equals okay,
or does not equal, or
okay, well I say equals
does equal to last button one state.
Actually no, we want to do something else. In this, we're going to have triple state and stuff. So the way a state machine works is that within each state, it's waiting for a certain specific output, and it does specific actions. So we're going to have three different states. So in this case, we probably want to define ourselves some constants. So let's say that we go to the top and create different constants for different states. So at the very top, we're going to create three constants. So const. I think we can do that. I believe. Yep. And then usually, for tradition, constants are all caps. So in this case, we'll say wait for press equals 0. So that's the state of waiting for press. And then const, and then we'll call it debouncing equals 1. And finally const, the third state is going to be wait for release equals to 3.
3. Why the 3?
Sorry, 2. So we have 3 different states. We're going to give numeric numbers each of the different states. But we use something that easy for us to read. Computers are actually. So those are the different states. But each button needs to be in state. So we need to have button 1 state, button 2 state, button 3, and they're going to be ints.
Okay.
So
int button 1 state equals false.
No, equals 0. Because we want to initialize it. Equals wait for press. We're going to make them all start out in initialize them.
Int button 1 state, or sorry, button 2 state equals 0.
Actually, let's say wait for press. We're going to use constants.
3 state equals wait for press.
Yep. And then we're going to rename all those the same way. So this is actually, computers is perfectly fine with 0, but it's all for human beings. We want to know what state we're in. Wait for press.
Do you also need the button 1 last state?
We don't actually need that, actually, because in a proper state machine, you only need to know what your current state is and do some action.
Okay.
We also need another thing we need to do is that while it's waiting for a debounce, we want to have a countdown.
Debounce length, right?
Debounce countdown.
Okay, so
so I guess we need
const debounce wait time.
I guess you want
debounce period.
Period, yeah. I guess because that makes it easy to fix 50 milliseconds. Okay, now we need to record that. So as
an int debounce timer.
Well, actually, we're gonna have each key needs a timer when you press it.
Oh, button
yes.
one.
Yeah.
So
button one timer.
Debounce.
Debounce equals 0. Button 2 debounce equals 0.
Okay, 0.
Yeah, because this is time. D3 debounce equals to 0 milliseconds.
Here we go.
Okay.
So give me a second. Let's just add some things in here. So toggle one status is var that toggles on and off. So let's just add those here so that we know what they are. Okay, now these ones wait for press.
Okay, so this is part of our state machine for the button debounce.
So let's just add that here.
Yeah,
We're going to type in here state machine variables
for debouncing.
Okay, and this one's wait for press.
Yeah. So and these
default state.
Yep. Well, normally we should be fine because you don't need, it's kind of redundant. So I guess while debouncing, yeah. And state after
toggled.
Actually, not toggle because once you wait for the
state after pressed.
Yeah.
Time for debounce.
And
or length of time.
Length of time.
And then this is the debounce var 1.
What's it called? These are all the debounce timers for all the keys, for all the buttons.
Okay. I don't know. Just it makes it more readable if I can say it's what it is here.
And these are the initial. These are all the states of the buttons.
Initial state.
Well, actually not initial. These are all the states of the buttons.
Button initialization.
Yeah, button state initialization. Actually, maybe when you put that as setup, maybe I'm trying to think what to make smarter sense. That should be fine. So this should be fine.
Okay, that's fine. Okay, cool.
All right.
So we've got this here. Now we're going to go down here to read button status. So if this is as true,
okay. So in this case,
then we detected a button when pressed.
Also and then of course, if it's pressed, then we have to figure what state we're in, right?
So now we're going to set button 1 state to the debouncing state, right?
Okay. Yeah. So actually, no, we have to check if we are already because maybe we're waiting because it depends what mode we're in. So what happens?
So if
button state
one state
equals
debouncing.
Debouncing. So then what we do is that we kind of ignore things. We just decrement it. Well, actually, no, we decrement the timer, right? So we do sorry, here we go. And so if button state equals debouncing and button 1 timer is greater than 0, then we always just decrement the timer, ignore anything else, right?
So button 1 timer negative equals to 1.
Yeah.
Semicolon.
Yeah, and then else, because if it is 0, right? Actually, I realized we should have done it this way. So if button state equals debouncing.
Yep.
Okay, and then that should be a new if end brace, and then we have to do an if statement because then we have to check 2 possibilities, right? So then curly bracket. Yeah.
All right.
Yeah.
And.
No, we need a whole new curly bracket because we need to need a whole another nested if statement. So then we have 2 possibilities. So if it's debouncing, if the button timer is greater than 0, then we just decrement the button timer.
Okay. But if the else, that means that just button timer is elapsed, right?
No, so the else, but then it's else button timer equals 0. But that should be the case. It's greater than 0. That's automatically should be equal to 0 once it decrements enough, right?
Yeah.
Okay. So we don't need an else. We just
else, right?
Just else, and we don't need. There's no else.
There's no other situation.
Yeah, and then that's when you reach end of the timer. And then what happens? We have to go into wait for button release state.
Yes.
Then you say
button so button 1 state is equal to wait for
release.
Release.
And hopefully that makes sense. Yeah.
So that makes sense. So
yeah, okay. But
so we also have to turn it to this debouncing set.
Yep. Well, let's actually do this in order. So when you do a state machine, you actually do an order of the state. So that handles the button state if it's debouncing. We should actually check if it's what? Wait for press.
Yeah, wait for press.
So we should do that above.
Above this, right?
Yeah, above this.
If button 1 state
Oh, actually, I realized we should put the button read inside here, actually.
Oh, right.
Yeah. Yeah, so actually, so that digital read, we actually have it inside here. So cut that if statement at the very top, because what we do is we check the state machine. No, just the top line. There.
This one here?
Yeah, that one. Just get rid of that. That should really go inside here.
Oh, you want me to take that one?
Yeah. Take that, and we're going to cut that inside. That actually goes. So the way the state machine works is that you figure out what state you're in, then you do the actions based on the state.
So I think I need to dedent this whole thing. Give me a second.
Yeah.
There we go.
Right. So if the read equals true, then what happens? Then we actually, that means you pressed it while on it, right? Then what happens is that we go into, we set the timer. So button timer equals to
button one. It was button 1 debounce.
Debounce.
Should change the timer.
Yeah, maybe timer.
The timer makes more sense.
Yeah.
I thought it was going to be good with debounce, but it actually is way better with timer. Because that makes more sense to humans.
Yeah.
Like me. I'm a human.
You are?
According to my mom. Okay, here we go.
I thought she said you were the devil.
Yeah, I think so.
No. I wouldn't use that example.
Debounce period. Because now we set the timer now. Right?
Yeah. Let me just double check and see if that's all good.
Yeah.
Debounce. Did I set that debounce? Where's the debounce period? Oh, here we go.
Yeah.
Couldn't read that because it's so close to all the other things. So let's just move that up there.
Actually, no. That's not state, because the tops are state and other.
Okay, so this is debounce variable.
I guess debouncing.
Okay, so now we did that.
Okay, so now let's just see if it makes sense. So once you press it, you set the timer, and then you set it into the debouncing state, and then next is that you say button 1 state equals debouncing, and that puts it into the mode. So therefore, it will trigger on the next loop to actually go into the next state.
So now it's going to start counting this. Yeah. And it's going to wait for that timer to be held down for a certain amount of time.
That's an else if or LF, because otherwise it will go directly into this.
LF?
Oh, no, actually in the line above.
Right. I see.
Because if the button state 1 state equals, and then that should be the one above here. So you want to actually have that line else if as well.
This one here.
Yeah, because what it is that we're checking each state in turn. If
this,
else
then
if
else
this.
if. Yeah. What? Shun88. Thank you so much for following. I really appreciate you following. Thank you so much. You are awesome. Thank you so much. Okay, so what we're here. So
so the way state machine that you have to on the big picture you have all these states. So you check what state you're currently in. So if we're in a wait for press state, if we have a button press, we trigger, set the period, and we're in debouncing. Else, if we are already in a debouncing state, then if the timer is greater than 0, we just count down the timer. Else, if we reach 0, then we trigger ourselves to the next state.
Let me just put a thing here. Timer elapsed.
Timer elapsed. Yeah.
Because we like those comments. It helps us.
Actually, it shouldn't be else if. It should just be else, not else.
Right. Yeah.
So
because we don't have any more if statements, right?
Yeah. And now we have the next one. And
so let me just stop for a moment here, because again we kind of jumped into doing if statements.
Yeah.
How if statements work is that the first statement that you're going to check is the first if statement, and then if that statement isn't what you are comparing it to, then it'll go on to the next ones, because it has an expected value of the first statement that you have. So it's going to check this one first, and if it's not this condition, it's just going to jump onto the next else if, and so on. So once this one has been checked, it goes on to the next one, and what's really important is this indentation.
For human beings, to make sure we know where things are.
Yeah, because it goes on the ones that are closest to the margin first, and then it starts reading the ones that are closer on in.
Yeah, that one should be dedented a little bit.
Which one? This one?
That one, you're on the cursor. See the blinking cursor? That should be dedented.
This one here?
Yes.
Else?
Yeah.
How come?
Let's see. Oh, actually, no. So that is...
Yeah, that's inside. That's inside.
The problem is that curly bracket is the wrong place. It throws things off.
This one?
No. I'll just point out again. It's about indentation. It's about human beings. That one's wrong. That should be indented.
Oh, yeah.
That's throwing things off.
There we go.
Also, another thing, at least for me, I like to put them on the same line. That's easier to tell.
Which one?
Yeah, this else should be over here because it makes it easier to kind of follow the logic.
Like that?
Like that. That's my own kind of personal style. That's
okay. Cool.
So that one
I like your style, Alan.
This one dedented because it makes it a little bit easier to try.
This one?
Yeah.
Dedent?
It, yeah. And then dent
Why?
again.
But if it's on the same indentation as the loop, won't it?
It's no, you dedent it one more time. You want to actually attach to that level. Dedent one more.
So shift, like that?
Dedent, and then hit back.
Oh, I see what you mean, like
yeah,
that.
like that.
I see,
So
I
it
see.
makes it easier to kind of, this is a block. And then there should be there's a curly bracket that should end over here. You also want to...
Oh, thank you for your raid, Magromancer. You rock. You seriously rock. Oh, bless. Okay, so just give me a second. I would like to make a big shout out to my homie Magromancer. He just gave me a raid. I am so appreciative of that. I'm gonna give my homie a shout out. I know he was playing bully, but thank you so much, Magro. You rock. Thank you so much, bud. Welcome to the Vo Gang. If you're new to the channel, you're in the place to be if you want to learn how to do some electronics kind of invention kind of stuff. Because today we're making a stream deck, right? Isn't that crazy? That's cool, right? Actually, I was unreasonably excited last week when Alan's like, "Hey, we should make a stream deck." What's a stream deck? Well, I guess I should very quickly go over what a stream deck is and what we're doing. Basically, we've got this mess of buttons here, and then depending on what button we press, it'll toggle on like this. Imagine that this red button represents your stream being playing or off, right? So you press the button, it turns the stream on, and then if you have like, I don't know, some music or sound effects, you can toggle that on or toggle that off. Right now we're trying to solve the problem where if you hold the button, it turns your stream on and off and on and off. So that's what we're doing. Thank you for the facepalm, Mew Mew. Thank you so much. That's how I feel right now. So right now we're adding a whole bunch of new code just to make it so that it doesn't turn on and off and on and off repeatedly. I think Magromancer is a streamer. Hey Magro, maybe we'll build you one of these and we'll send you one when we have our prototype. Because we're gonna be 3D printing our own. Oh, he's gonna get the Elgato Stream Deck because he's pro. That's why. Because you're a pro, Magro. You're the best. Okay, so let's go back to what we were doing here. I got super distracted by being followed by Shun8. Again, thank you so much. Thank you so much. It really helps out following the stream.
Okay,
so we're here. So let's just go through from the top here.
One thing is that whenever you use curly brackets, always do a matching curly bracket right away. That's one thing that you do in terms of programming. So what I'm seeing here, there's a curly bracket. There should be a matching one at the end of this.
Right here.
Right there. Hit enter. Dedent, and that way we have a closed block.
Okay, there we go. So that's closed there.
Yep.
And this statement here, this curly bracket matches up with this curly bracket. Yep. Basically, I know it looks kind of intimidating, but these curly brackets determine what's happening depending on something else. So right now we're reading the button press, and if it's waiting for the button press, then it'll do some other stuff. Drew Jordan will have a custom one though. That's the cool part about DIY.
Oh, so you can't see the code. I guess you want.
Oh, right. Yeah, oh, yeah, sorry. Yeah. I'll switch it to the code. Sorry, I'll switching it to the code. There we go. Is that better? Now we're on the code. So button 1 state, we're waiting for the button press. If the button is read as true, then we'll wait for the debounce, or we'll set the debounce period, because if this timer is already counted down, it's going to need to set back to the 50 millisecond period that it was already before. And then we set this button state to debouncing, so we know that the button is now we're waiting for it to elapse a certain amount of time for it to read positive. Then what if it's not waiting for the press and it's already debouncing? Then we move on to this chunk of code where it says if button state is debouncing, if button timer is false, or sorry, if
7 viewers, you should probably say hi to all of them.
What, really? Oh my god. Okay, I'm gonna say hi to all my viewers. I'm jumping on the Twitch stream, twitch.tv / no, not Magromancer.
Give him all your views.
Oh my gosh. Oh my gosh. Okay, I'd like to say hi to all of my viewers. Let's say hi to. Whoa! There's actually a lot of guests here. So let's do it. Let's do a quick shout out to all the different people who have seen here. I see Abbott and Casello. I see Alan Wong is. I see another TTV viewer. Alan Wong is also right here.
How's that happening?
Right?
Where am I?
Where am I? How'd you get on the stream?
How am I doing this?
Shout out to Bing Cortana, Casino Thanks, Commander Root, Droop Dog, Electrical Longboard, Extra More, FTO Payer, Go With Him, Have This Too, Ice Wizards, Ildalara, Joint Effort, of course, my homie Magromancer, Shoon88, thank you so much for the follow, and Smeeth13. You guys rock. Thank you so much. I know, right? It's the stream use. Oh god, we're getting sucked into the middle. That's what happens when I stream my screen and I accidentally open up the OBS page. Okay, so what do we have to do?
Okay, yeah. So we got the bracket state. So toggle status. We just want to make sure everything kind of.
Yeah, we're just making sure everything's flowing down.
Yeah,
so we do the button debouncing.
Yeah.
We go after the if button timer is greater than 0. We de-increment the timer. And else the timer has elapsed, then we switch the button to state for waiting for release. So it switches to that next state.
Oh yeah, actually we toggle the status up over here. Actually, that should be cut and in because we hit the press.
Should it be in the timer elapsed?
No, actually, because it is. Otherwise, it'll toggle each time you go through the loop. We don't want that.
Oh right, yeah.
We want it to trigger the moment you pressed it. So if you're waiting to press and you do read it,
this one here.
Yeah.
So actually underneath all that, right?
Actually within that, because you want to actually
here?
there.
Like
so, yeah, you want to talk that.
I don't know why I wanted to put it below here instead of above.
And yeah, so then we go into the debouncing state. While it's debouncing, we have a timer elapse, and when the timer has elapsed, we trigger it to the next state, which is wait for release, and then we do another else if button state equals to.
Oh, so we're doing can we just take this block and copy it again?
No. Actually, we do one third state, which is the wait for release state. You want to actually we want to dedent it there.
Here?
Because it makes your
else
code look
if
else if button state.
Button 1 state does equal to wait _for release. Release me. Release me from this prison.
And then what we do is that we just if digital read equals to of 8. Not digital read, because
Can you
say.
to your stream at the same time?
Not really. I'll come back and say hi though.
This is where Michael Reeves was like.
Talk nerd to me, Magromancer. Seriously though, for 6K there are some good stuff on the HUD, so to speak. Yeah, that's true. That's true. You know what I should do? I should really open it up on my phone or something else so that I can. Do you mind opening up on your laptop so you can chat with everybody at the same time?
Let's see here. So
else if button state equals wait for release. Yeah. Then we're gonna do some stuff.
Yes, and then of course we're waiting for what? We're waiting for it to become 0 again, right?
Become 0 again.
Yeah.
So it's holding down there. Do we need to set the debounce again?
No, because it's already.
Oh right. So we're looking for if digital read 8.
Not because you're flipping.
Oh right. So that we can understand it better. Yeah. Digital read 8
equals
false
released.
So it's off.
Yep. Then all we have to do is just have to change the button state to wait for press again.
Okay, so that button 1 state equals to wait for press.
Yep.
So now we're going to be setting that button so that we can
the moment to release, then it
can do the whole loop again. So now what we got to do is just take this block and repeat it 3 times.
Let's actually wait until that happens. Make sure this works first.
Right. That's a good idea. You know, Alan. That's why we have Alan here. He's the expert.
One last thing, just for safety's sake, this else if we do one last else.
Yeah.
Put it back level, because then what happens? Ends up in an unknown state. So just say else.
Else.
Else, and then curly bracket, and then we do something like
serial.print.
Serial print. This should not happen. If it is,
something strange happened. It's actually a really good thing to have these kind of weird, just kind of like error checker things, because sometimes weird things happen, and when they do, you want to know about them.
Yeah.
So
instead of something happening.
Okay, that looks pretty good.
Okay.
So let's just try it.
Hopefully logic makes sense, and we'll just see. The one last thing is that now that we have these debounds, we can change our time delay to something short, because now we want 50 cycles, but we want to change that serial delay to maybe a millisecond.
So
delay,
1
millisecond now. Because the 50 is taken care of by the timer now.
Oh, yeah.
50 milliseconds.
Okay, so let's run it.
Okay.
So let's just do Control V.
Yep.
Oh. No, we want to do verify.
Yep.
I thought Control V was verify for some reason.
Oh, yeah. Wait for press to not name it. Okay, we have to say const int.
Oh, const int?
Yeah, because it has to const space int, because it's constant integer. Because
Oh.
these are numbers, yeah.
I did not know that.
Yeah.
And let's go shout out the chat a little bit.
Hi, chat.
Magromancer, if you want to see a list of the things I'm planning on buying, it's available on my profile. I've got most of the things I'm planning on buying. Most of it's higher tier stuff. Yeah, I saw your build on your profile, Magro. You're an insane lad. Your computer's going to be a beast, no doubt.
Yeah,
So
you want to wait a couple months before buying things, because prices are insanely high at the moment.
It's true, actually.
Yeah,
it is.
Stuff with the VR headset, that's cheap. Processors, nope, hard to find. Graphics card, forget about that.
Yeah.
All the Bitcoin miners have bought them up.
The graphics card are definitely like really exploded right now. For some reason, they've just kind of inflated in price to the point where even my graphics card, even though it's super old, is still like kind of expensive. And it's not a good card, so.
And I've seen the prices. The RX 580s, just about 6 months ago, they were going for about $200. I've seen prices about $400 now.
What?
And they originally sold for about $200.
Oh my god. So Mew Mew asks, what's the weirdest thing that's ever happened to your code? That's a really good question. I gotta think about that for a second. Okay, so a few times I had one of those if statements, and it was set to the else. And else usually says, like, the debug statement is like, something strange happened. And for some reason, every single time, I was getting this this result where it was going to the else statement immediately and saying something strange happened. And I'm like, what on earth is making this happen? This value should be 1 or it should be 0. Why is it telling me that it's getting something else? Because that's what else does, right? It catches if you get something else. So I went into the code, and it turned out that the variable that I was spitting to was actually getting like a variable input, so that the actual value was not getting 1, it was like getting 1.1 or like 1.2, or it was just getting a different value than expected, so it ended up pushing it to the else value, and every single time I ran the code, I had no idea what the heck. I had no idea why. Oh, thank you so much, Smee13. It says, I have not watched someone code since high school. Cool to see. Honestly, I'm super excited to be doing our build stream. Me and Alan have been wanting to do this for a really long time, and I'm super excited to do it because it's super fun. It's so much fun just to get stuff like blinking and blooping and stuff. Considering, oh yeah, Magromancer won the LG 27-inch Ultra Gear 4K PC monitor. Honestly, I'm so jealous. I think that's so cool. I've never even looked at a 4K PC monitor, so I wouldn't even know the difference. I've been using my 1920 by 1080p monitor for ages.
Not even a monitor, it's a TV set.
It's not even it's a TV set. Yeah, so I've heard some things, like if you have a monitor with a good refresh rate, it really helps with gaming and stuff like that, especially like first-person shooters and stuff like that.
It's the milliseconds count.
Yeah, the milliseconds do count, don't they? Yeah, it's a freaking TV. Okay, so anyways, okay, let's get back to the code. Let's get back to coding. Okay, so we've got this thing here.
Assuming wait for press to not name a type.
Let's verify.
Change the default message from something strange happened to something like it looks like there's a demon in your code. Better go slay line 242.
Sure.
Is that a thing that you can do?
Yeah. A demon occurred. Demon occurred. What do? What do? What do? Panic? There you go. Are you happy now, Mew Mew? It says a demon occurred. What do? Because when this happens, it really is like...
It should never happen.
It should never happen. And so when it does, it's not great. Another thing that was really funny with the code that I had one time was I kept on running the code, and I got this weird output on the serial monitor. And what happened was that I was trying to upload it, but I was uploading to the wrong COM port. So I was re-uploading this code and getting these debug messages that was from a completely different project that I had uploaded to Arduino previously. So when I was running my code, I was getting these debug errors that I didn't write. And it really scared me. Like, I was like, what? Where are these debugs coming from? What's going on? Another thing that also is really funny that's strange, that's kind of strange that happened is if you read on the serial monitor and you're on the wrong baud rate, you get a whole bunch of like wingdings and stuff. I don't even know how to describe it.
It's just
like,
line noise.
It's line noise. Yeah. It's basically, it can't read what you're outputting, so you end up getting like a bunch of wingdings thrown at you at 1,000 miles an hour. And of course, wingdings are not super helpful unless you can read them. Okay, so we've got this thing now. Should we just try it?
Let's try it.
Okay, so it seems like it's verified.
File.
It's uploaded. It's plugged in. Let's upload it.
Okay, debounce here does not name it. Oh, we have to give it int as well too. So go back to your defined.
Oh, const int. This one.
Yeah.
Try that again. Let's do. Just try verify and see. Because verify will tell us if it's blown up.
Oh yeah.
Okay, it seems to be good. Let's try upload now.
Mm-hmm.
Once we upload, let's go back into the chat and say hi again. It seems that the chat's blowing up right now. Yes, it's true. Your internet actually has to be good. Your donation was well spent, and I do appreciate the love. Thank you so much, Mew Mew. And thank you, Mew Mew. Panic at the Disco? Yes. Creepy code pasta. I don't think anyone wants a wingding thrown at them at any miles an hour. Fair enough. Fair enough. Okay, so we're inside here. Let's see what we've got in the serial monitor.
Actually, well, we're actually... we'll get some nonsense mostly, but we want to see if it debounces button 1.
I'm breaking the fourth wall here.
No freaking way!
Here you go.
No freaking way. Okay, guys. So let me just hold this up so you can see what's going on.
You a chat screen.
So over here, you guys can see that is that button. The red button is the one that we configure it for.
Previously, it was kind of flaky because you had to get the timing just right to release in order to kind of toggle.
Yeah, you had to hold it for exactly 1/10 of a second in order for it to toggle correctly. Otherwise, it was just flashing on and off, on and off, on and off at a rate of 1/10 of a second. So now, when I press this button, you'll notice when I hold it down, it only toggles it, and it doesn't turn on and off repeatedly. And if I press it again,
instantly toggles
on, and I don't have to like hold it for any finicky amount of time. It's working like a charm. Oh my god! Yes, that's what we wanted.
Where's your drink?
What drink? Oh. Guys, let's do this again. I did this at the beginning of the stream. As we mentioned before, the stream is sponsored, not actually, by Vegito Cola. Drink Vegito. The strength of a Super Saiyan Blue in one can. Vegito.
Not sponsored, but it's
I really want to open it and try it. Okay, here we go. We're doing on stream. We're going to open up the Vegito Cola. Let's do it. We're going Super Saiyan Blue in here. Oh, it smells really good. It smells like green apple. How would you describe that, Alan? Like green apple or something, right?
Yeah, very very apple-y, yeah. Yeah, green apple, definitely.
It smells super good. All right, let's try it. Bottoms up. That is really, really good. It tastes like Jolly Ranchers. Like green Jolly Ranchers. That's what it tastes like.
Can I try?
Oh my gosh, that is so
Actually,
awesome.
put it in here because this one will like be harder to.
Where did you get this?
TNT.
Vegito Cola is awesome.
It's technically like.
I know it's Ocean Bomb Cola, but I call it
Bomb.
Vegito Cola because it's
Ocean
cooler that
Bomb
way.
is an awesome name for a beverage. Oh my god, it is like green jelly ranch.
Oh, sadly, Magromancer, I haven't posted the everyone commands on the profile yet, but I hope to do that before the next time we stream so that we'll have a whole bunch of cool commands. Maybe I'll even add some commands tonight. I think right now I have... Oh, man. Okay, so now we've got this going.
Okay.
Should we... I mean, it seems to be working. Should we
Okay.
just take it and copy it again?
Okay, well, we could do that. We could do that. Do you really want to copy and paste code?
No, we want to create a function for this, don't
We
we?
want to create a class.
A class, that's what it is,
Okay,
right?
so first thing before we do that, this is working code, and we don't have version control. We don't have Git on this.
Right, so should I make a test 2, right?
Save as.
Test
well,
2?
Test. Well, it's already test 2. Already
Test
named it
3.
Test 3.
Test 3. Here we go, test 3.
This
So
is
now we're going to...
primitive version control. Okay, so now...
I really should be firing up GitHub. Do I have GitHub? I'm always so paranoid that I'm going to... You know what? We'll do that later. We'll set up GitHub next time.
We'll do a proper coding project
I will
next
do
time.
it properly. We kind of like planned this one last week, and we're like, oh, you know what? We know enough stuff. We should be able to do that all from scratch with no help, right? And yeah, it's true, but really we should be practicing our version control and showing all of our good habits, good programmer habits, because when you program stuff like this, you end up creating spaghetti.
Yeah, you do. You want to create code, and then you overwrite your working code. Oh, then you can copy it back up.
Mew Mew says, do not give Jordan energy drinks. Why would you give me energy drinks? I love energy drinks. Give me some energy drinks. Muser, give me the energy drinks. You're holding out on me. Okay, so we gotta put this into a class.
Okay, now we're going to talk about classes, object-oriented programming.
What is a class,
Ooh.
Alan? I have no idea. I'm so scared.
Okay, it's scary. Okay, classes. Well, in this case, we're going. Luckily, it's C++. We're actually going to create a class for this thing because we don't want to copy paste this code over and over again. So we're going to encapsulate this so it does the job for us in a much more reasonable way. Okay, so what happens? So a class.
Sorry, I'm reading chat. Mew Mew's roasting me. Why don't you come into every stream and roast me? I'm sure that I would get better viewership if you did. Come in and roast me every time. Yeah, if I was sponsored by an energy drink, I would be like foaming at the mouth and going like, give me some Monster. It's 2 a.m. and I'm still bouncing off the walls. And this is even energy drink. This is just a normal drink with sugar in it.
Sugar.
Sugar. Flavor. Okay. Okay, what do we do?
Okay, well, okay, in this case, we're going to actually do something. We're going to encapsulate this. We actually want to have a debounce button class.
Ah, yes.
Okay. So we're going to. So luckily, the key is that okay. Well, now that we have this, how do we handle it? Okay. Well, we're going to create a class.
So class
Debounce button.
and it should be like that. That's probably the parameter. But button.
It's not parameter. Okay. So I guess what do you call it? Debounced? Maybe we'll call it that.
Debounced.
Debounced. Okay. But then we want to capitalize a D because convention that classes start with capital letters. Yeah, we can tell them apart from variables. And all you do is, in this case, I believe we just have a...
I'm so happy I have you around because I if I don't program for a little while, I always forget these little convention things.
Okay, so that's the name of our class. And in this case, we're not going to subclass anything. We just keep it simple. So we want to do a curly bracket because inside the body of this...
Seriously, pity follow Jordan if you feel bad that I'm roasting him. Oh, are you gonna make a bowl of matcha? Can I have a bowl of matcha? Oh. Aw. I think I'm not allowed to drink matcha at 2 a.m. Sad day. Okay, so we do debounce.
And then we need curly bracket, not round bracket.
Oh, right, yep.
And any curly bracket, so this is a class. So then we're going to have to create what's called constructor, a function that makes up our And so we call it public. Okay.
Yep.
And the name of and then it's colon. And we have list all the public members of our class. In this case, all
button 1 state, button 2 state.
Yep. So we need first. We actually no. Those are actually. I guess we'll leave those outside. We'll keep them as constants.
Okay.
However, we're going to do. Okay. We need what's called instructor. That okay. We need to kind of say, for example, which button pin we actually want to debounce, and possibly want to maybe give it a name or something like that as well too.
Okay, so we do public,
and then hit enter.
Okay,
and then indent. And
I've actually never used the public function before.
Okay, well, public is not a function. In this case, it tells you what things are visible in class. So all of a class is that it's something that does a bunch of stuff and it contains information. So debounce contain button state of whatever debouncing, but I want to tell what you can actually see inside because we don't want to give all the dirty details and stuff to avoid confusion. So the first thing we need to do is what's called a constructor, which means it was from nothing. You want to be able to initialize everything. If you remember a double underscore init in Python.
Oh yeah.
This is the equivalent.
Okay.
Okay. So how we do is that we have to create a function called debounced. So it's just called debounced, same thing.
It would be def? No,
just call it debounced.
Debounce?
Yeah, but capital, you have to match.
Oh right,
class,
yeah, okay.
Debounced. But it's a function name, so it's and then of course you have to say what parameters do we have. So you want to have an int, probably want to call it its pin. And
right, so pin.
And then comma, and then we probably want to maybe call it a name or some of that because you want to have a reasonable name. So and that'll be maybe I think we do string. I believe that's a string. Does that do?
Or string? Nope.
I'm trying to think, what do strings do? Just remember.
Isn't it like Modulo or something like that for string?
Let's see,
I can't remember what it is.
I'm trying to remember what this is. I'm just remember Arduino. We very rarely deal with strings, string variables. Arduino.
Now we gotta talk on that. Where's that guy who was in there before? I think his name was like Sheen or something like that. We gotta ask Sheen. Or Smeeth. Smeeth 13. If you're still in there, if you're still in here, let us know if you know.
Okay, I think it's a string type. I believe. Just call it capital string. I believe.
Capital string?
Yeah.
Okay. String like that?
String? Oh, yeah. Okay, and then call it name, I guess.
Name?
Like
that?
Pin name. Actually, sorry. Pin name.
Pin name.
Or button name or something.
Button name.
Maybe button name might be better. Okay, and that's semicolon. Okay, and
semicolon.
Yep. And the other thing we want to have in terms of is a tick function because you want to call it per bounce. And so call it tick.
Tick.
Yep. And that's lowercase because it's an actual function. And that has no parameters, I don't believe. Yeah, because we just want it to do the state machine kind of stuff.
Okay, so what do we do with tick?
Yeah, I'm trying to think here. Tick. Yeah. I'm trying to think of any other actions you want to do. I think that should do. Yeah, just call tick brace and brace. And I think that's all we need there.
That's all we need, right?
Yeah. In terms of public.
Because it basically needs to do the initial function, and then it needs to pick the timers, right?
Pick the timer, and then it'll send. I guess currently we're going to want to actually. We want an LED pin.
Right.
Yeah. So in the debounce, we want to tell its
string LED name,
button pin, and also the LED pin. Int.
So int. LED pin.
Yeah.
Or LED underscore pin?
Yeah, underscore pin. Because that way we can tell it which pin it should read from and which pin to light up and stuff.
So how do we then take this and shove all this stuff into it?
That's your tick code.
Okay. Is that inside of this public class?
Okay, no, we define it outside. So in this case, so the way it works...
So it would be def tick or void tick?
Okay, then how you do this...
void means it's not returning anything, right?
So actually this should be void up here. We want to give a return to a void. It has to match the signature. So how you create a the tick class, it should be debounced. So what is that? You have to give it... So what happens, we have to dereference the name. So in front of this tick, type in the class name, debounced.
Debounced dot
colon. I think that
colon.
I think it's double colon one.
Colon.
Yes, I think that is.
Hey, let me check the chat here. The chat is exploding with a lot of coffee talk right now.
Yeah.
It's 2 a.m. guys. I'm not gonna drink coffee. Are you insane? Yeah. Oh my God, Magromancer is trying to feed me blonde ristretto espresso shot latte. No, thank you. Coffee gives me heart palpitations. That would probably kill me. Oh yeah, Macromax has been working at Starbucks for 3 years. He's probably... Thank you so much, Smeeth. Smeeth says this. He says, it's been almost 15 years since I last coded, but you're doing a solid job. I really appreciate you saying that, because I feel like I'm doing bad. But at least I got Alan here, and he's awesome at this kind of stuff, so he can keep me on track while I'm flying off the rails.
Okay, yeah, so that means we kind of copy inside that. So the thing is that your software needs to know which tick function belongs to which class, because you have multiple classes with the same function, unless you can use it. So that's what the debounce. The tick function of the debounce class, that's what a colon does for you.
I've never used colon before.
Yeah, so that's how it works.
That's crazy. I honestly didn't even know that that Arduino had class structure in it before.
Yeah, it's the C.
So like the colon is kind of like showing
like
that the tick is derivative of debounce.
Yeah.
Okay, cool.
And then we can copy that code that we had, all that stuff here. We just take all that.
Let's do it. Let's take it. Including the demon occurred. What do?
Yeah.
Panic. Okay, take that. Move that up.
Yeah.
Oh, and actually we're going to take the comment too.
Yeah.
I'm going to push in here.
Yeah, push in there. Okay, and now we have to clean it up. So now, of course, you know that each button needs a button state, for example, right? So this is actually, it needs to be kept track of, right? So for example, button state, a timer, and anything else in here, and also we need to know which pin is the...
And this one would we gotta change this to be, it would be button name, right?
Okay,
because we'd be receiving the button name from the debounce class.
That's the button state.
Oh my gosh, another follower, Smeeth13, thank you so much.
Now you have to do a dance
Oh my gosh,
I'm
gonna do a dance. Thank you so much for following. This is my maker build dance, because Smeeth is awesome and he likes programming. Thank you so much for following. You rock. And you're the reason why I'm able to continue doing these kind of cool streams. I hope that we can do more awesome build streams. In fact, people like you are going to be the ones who encourage me to keep doing the build stream, because the build stream rocks. And that's how we're going to make cool stuff. Oh my gosh, I'm so excited. Thank you, Smeeth13. You awesome. I like how you like jumped out of the way as I jumped up to do my dance.
I didn't want to get my head knocked off. Insane. I've seen you dance before.
He knows how it goes. I get wild. I don't even need coffee. All I need is the strength of Vegito. Oh boy. Okay.
Okay. So going back to this now. Okay, but you see, okay, we have a couple of different variables to keep track of. We need a button state variable, a timer variable. We also need to know which button is the pin button for actually detecting presses, and which LED pin. So those are 4 variables to keep track of. So where do you keep track of those? In this case, a class keeps track of them in, over here, a private section, private variables. So we go over here.
Okay, give me a second. Sure. Let me just type that. He's in his head. Smeeth, I donated $88 to him today for Chinese New Year's, and he didn't get a dance. The real Jordan Vogt, can you go Super Saiyan? Powering up. To come back 20 episodes later. Okay, sorry. Totally went off on a tangent. I'm bad at that. Okay, sorry. So we're back again. We have to take here the button one state and figure out what button we're using,
but
right?
we need to keep track of them. Remember, for example, each button, we're going to have multiple instances of these.
Yes, yes.
And they need to be keep track of them. And the next thing we do is that how you keep track of them going back to our class, we had our functions, but also need variables.
Okay, okay.
So, but these ones we don't want everyone to know about them. So they're going to be private. So underneath that, hit enter on that line.
Yep.
Degent by 1, and we say private. And all this current next stuff is private. And what do you want? Private. We want variables. Colon. What variable do you want? Button state.
Button.
Int button state.
Int.
Button state.
Button state. What?
Oh, and we also need a button timer because each button requires a variables. But rather than
creating I see.
Int
button timer. Should I use camel caps?
Yeah, I guess so.
Just to make it readable, right?
Be Pythonic. And also,
I like being Pythonic.
Yeah, so this is C, so then There's no rules for C.
Okay. Actually, maybe we should be consistent and use an underscore like we did all the other ones. Yeah.
Oh yeah, we'll do it that way.
Yeah. So we're consistent.
Yeah.
I realize it's not Python.
Pick one.
One convention.
One convention. Okay. Another thing.
And then demounts.
We need to. No, actually, no. We don't need to worry about that. Then you need to know.
So each button has a state on and off. Each button has a timer. Oh, that is the demounts.
Yeah.
So we don't need anything else.
The state handles debouncing part.
Okay.
Okay. We also need to know which is our pin.
Oh.
So just say pin.
Pin.
Yep. And then also LED pin to light things up on.
Okay, that makes sense. That makes sense.
And don't forget the semicolons on each line as well too.
Right.
Yep.
Can you give me a second? Someone just said something else in the chat.
Sure.
Magromancer says, Mew Mew, I'm getting the HTC Vive Cosmo Elite VR headset for when I get my gaming PC built. Alan, is that a really good headset?
It actually is, actually.
Oh my gosh.
Yeah, it is quite nice, yeah.
Okay, Magromancer, when you get that, you gotta let me check it out. Or like, play a game on it, stream on it. Just do something with it. I really would love to see what a really high-end headset can do. I love VR. Oh yeah, did you guys hear the good news? Me and Alan finally figured out how to get the headset working. The problem is that I was using the USB 3.0 card that I bought specifically for the headset.
Which, because it broke previously...
Yeah, previously it broke, and it wouldn't work with the native USBs. We had to buy the USB 3.0 card.
But in the meantime, I actually reformatted the whole computer as well, too. So maybe that helped out, too.
So we reformatted the whole computer several times. And then finally...
Made it legitimate, too.
Yeah, yes. We also legitimized the Windows, because for the longest time I was using an illegitimate copy of Windows.
Who knows? There must have been something in there.
And it still wouldn't work. Until I tried plugging into the native USB card, and then it freaking worked perfectly, like a charm. Like, I don't even comprehend how these kind of things work, but...
It's Windows.
It's working now.
In the future, of course, Apple's come up with their own VR headset. Buy that instead.
Oh!
Although it's going to cost $3,000.
Oh my god.
Or an Apple ecosystem.
Yeah, Magro says the HTC Vive Cosmo Elite is $1,700. So I'm going to basically need to take out a loan, mortgage my house or something to get a VR headset.
But apparently Apple's going to have 8K per eye.
What the heck? Yeah, I definitely got to get the Apple headset then. Because, I mean, 8K per eye? That's like almost as much as your eyes can see for resolution.
No, I think the eye does more.
Does it?
Yeah.
How much can an eye see?
I think actually, who was it again? Quarter Crew did actually something about that, about how high the eye can actually see.
Oh wow!
Go on YouTube, something. Look on a YouTube video on Quarter Crew.
But still, like 8K is already going to be like insane. Because right now, like the highest resolution we have, or at least the one that I was using, or the Rift S, is only like 2K per eye.
2K.
I think it's like 2,500 by something else.
Okay, yeah, about 2K.
Like 2.5K, but I don't know. But just I can't even imagine what it would be like to have double that. Like, that's nuts. Okay, so we're back up here. We've got our private. We've got our
LED
button
pin.
states here. LED pin. Should we call it LED pin?
No, we need the regular pin.
Right. Because it's called from here.
And also we need also regular pin.
Int pin?
Maybe int pin.
Okay.
Okay, so now that we have those, of course, those need to be initialized now. So we actually took care of the tick function.
Mew Mew says, I'll need an Apple room to run my Apple headset, an Apple lights, and an Apple computer. Okay, that's fair.
Well, don't forget an Apple manservant.
The Apple manservant? My Apple robot? Oh my gosh. Okay, sorry. I keep getting distracted.
Well, apparently Apple's going to cars too.
What?
Yeah.
So you hook up your Apple VR to your Apple car and you ride to the Apple store. Honestly, I used to hate on Mac, but Mac actually makes some really good computers, so it's hard to hate on them. Button state, button timer, LED pin, and then pin, right?
Yep. So those are all the different state variables. Well, different variables that keep track of each object. So now we have to create the constructor. So how we do that is that's outside. That's a new function.
Oh yeah.
So again, void, debounced, and then colon, debounced, because we call debounced. That's the constructor.
Oh, this is lowercase debounced, right?
No, uppercase, because it matches the name of the constructor. Debounced.
What?
Yep.
What are we doing? Is it round bracket, round bracket?
Yeah. And
so empty function call.
Yeah, but of course you have to put the parameters in, which is int pin, int string. So we copy.
Oh, so this one?
Yeah.
Yeah. Okay.
Those parameters.
So wait, what are we doing right now?
We need to initialize all this stuff. So all these things have to be assigned values. Right?
Whoa.
Okay. So then.
So I'm just trying to figure out what the heck is going on here.
Okay.
So class debounced. In the public domain, we've got this debounced and void tick
that's
thing.
just a signature that describes what our function is. It actually doesn't define it. Tell what the code does.
Okay.
So we're telling that all these functions are going to be public, and these things are going to be private variables for ourselves. Underneath that, we have to actually create our actual functions that do the stuff. So it's kind of like Python. Remember in Python, you had to create, you had to init, if you recall, and you named the stuff. But then remember what happened next. Then you self dot variable name equals whatever that is, right? So if we had, we want a constructor for something like example, a character. Remember we had car name and then I guess strength and all that stuff. But then you had self dot car name equals car name, because that variable name had to be assigned to its own.
Oh, I see. So we're saying this is debounced dot debounced.
Yeah.
So this is the one that actually.
This is like the init thing.
Yeah. Okay.
Right. So, but then now we have to assign it to each one's objects, actually values.
Yep.
Yep.
Sorry, give me a second. I'm just reading the thing here. Mew Mew, you should save up the Mac Pro. Oh my God, what? Mac Pro will cost you $40,000? Is that correct?
Depends which one you want. You have all the bling. You can have that.
That's insane, though.
You can get the $3,000 monitor with the $600 stand.
Yeah, it's true. The Macs are very hard to repair, but I think that the point is that you send them in to repair, I guess,
and
right?
They actually don't break down that often, to be honest, either.
Yeah, that's what I've noticed. Is that with a Windows computer, you're probably going to have to open it up because you set it up in the first place. Oh, you know what? I agree with you too, Mew Mew. There is some sort of I don't know, power you get out of assembling your own PC. There's something really fun about that, because you get to put a bunch of stuff inside your computer, and when something blows up, you're like, oh, hey, it's probably my fault. It's a good feeling and a bad feeling. It's a good feeling knowing that if it blows up, you can fix it yourself.
Yeah, but you don't want to have Grandma do that.
Yeah.
Why do you blow up my computer? What do I do now?
What are you doing? Why are you inside my computer?
Learn some coding, Grandma.
I'm learning coding.
It's your own computer.
Where's all this smoke coming from? You're grounded.
Oh well, I'll get you a Mac then.
Oh, did you see what people were doing with the new Xbox? Where people were vaping into it to make the smoke come out of it, and they were.
They had to release a notice that said, "Please do not vape into your Xbox."
Yeah, please don't vape into your Xbox, because people were vaping into their Xboxes for some reason, and that was upsetting to Windows. So, or Microsoft. Okay, sorry. Okay. Totally keep getting distracted. Okay, so we're in debounced here. We've got this thing here.
So it's not have to save. So again, if you remember from Python, it had to be self, because again, self is the object, and its variables had to be set. So what happens in C, it's not self. It is called. What do you think it's called?
No idea.
It's called this.
It's called this? Really?
Yes, this. And then see.
Oh my God.
Can I count on you guys to put the food away later?
Yeah, sure, babe. Are you passing out? Okay, well, thank you so much for jumping on the stream, babe. I really appreciate you jumping on the stream and talking to people and kind of moderating and stuff. I really appreciate that.
I'm more like starting shit than moderating, but okay.
You know what? It's fine. You can moderate. If you moderate, then you can start shit, okay? As long as you ban yourself.
I already unfollowed you once today.
So you can refollow me?
Follow you again.
Okay, so we do this dot.
Okay, and that's not dot. So because this referred, this
That's
is actually
colon?
No,
Colon?
not colon. Okay, this is okay because this is actually a pointer.
I see.
Because so how we access it is use an arrow.
I'm gonna need a power up for this. Vegito, give me strength.
You should just fill that with water and always drink out of it. It's your new streaming cup.
I tell you, I'm not throwing out that can. I love the can.
Okay, so you make an arrow. How do you make an arrow?
Oh, like that?
Nope. It says you minus sign. There, an arrow.
Oh my god! So this arrow.
Okay, and arrow, and then what is that? Okay, it'll be, let's say, pin equals pin. So the so that's like this dot pin.
So this
arrow
button name equals to button name. Oh, this is very familiar now.
Yeah.
Basically, in Python, you kind of had to reiterate everything so that the stuff that you pass into the arguments can then be passed on to the constructor.
Yep. Okay. But we also want to do some other things.
If that doesn't make sense, don't know how to explain it else. Other ways. Semicolons?
Yeah. And okay, actually, so in here we can actually we should also do some other initialization because we also want to configure maybe the pins here possibly. What do you think? I guess we should set this here. So we want to.
We probably should.
Yep. Yeah. So we set input because you can configure it here rather than writing the code twice. So then we actually have to say pin mode.
Give me a second.
Yep.
Pin mode.
And then we have
LED pin. Comma output.
And then
wait, this doesn't get set up in setup?
we're gonna create objects in setup.
Okay.
Yeah.
And then pin mode. I guess I should probably do it in the order that I commanded them in. Invoke them in. Pin mode. Pin. Wait, what is pin then?
We're going to specify that. We're going to give a variable because to assign it in the constructor. So we're going to tell it in. So later on in the actual code,
okay, so yeah, I know that pin is equal to pin, but what is actually pin?
It's a number. So remember the pin mode, you have to tell which number of the pin you're using. So later on, okay, let's do some demo code.
Is this the button pin?
That's
the
button pin.
So should we call it button pin?
Maybe call it button pin for more.
Button
pin, and then we'll rename it pin equals button pin.
I know it adds a lot more typing to my.
The point is, it's
a little more explicit.
And then we'll rename the button pin and deprive it above.
Yeah. Give me a second. I'm just going to write button underscore. And night musers. Oh, thank you so much for joining us. I really appreciate you. You rock. Thank you so much, musers.
No problem.
And this is going to be output or input, right? Input.
We had to
input pull up.
Input pull up.
Okay.
All right, and I'm trying to think
now we want. So we got the button name. Button name. Yeah, we forgot to set the.
No,
we don't need the button name.
No, that's fine. Next thing we want to set is the initial button state and the button timer to be. So we want to set button state equals to wait for press.
Okay, so button.
This, it has to be this.
Oh right.
Yeah,
this. Button
state.
Wait, what?
Oh
right, button underscore state
equals, and we want the initial button state to be
wait for press. Oh my gosh, this is crazy because we did all this like all this extra things. It's actually kind of readable because we changed it to wait for press instead of being 0. Yeah. So
this is
it's reading a lot better.
Yeah.
Here's I'm very quickly reading this here. You can always give someone a PC war with Windows Vista, make it look broken. Vista, wow. Stands for doesn't often work. Won't often work. I gotta go to work at 8 a.m. Aw, poor musers. Yeah, Linux is good, but the thing is with Linux, you gotta learn your system. Whatever your system you're learning, you gotta dedicate some time to learning how that thing works. Linux is great. I'm not gonna say anything bad about Linux because if you know how Linux works, you're really playing. You're cooking with gas. You can get more work done that way. I just know that because we set up Linux downstairs, and for things like Arduino or for like trying to set up like camera drivers, if you're trying to make custom camera drivers for like an OV7670, then you're going to find that it's a lot easier to run those unregistered drivers on a Linux computer than it is to try and run those unsigned drivers on your Windows computer, which is going to tell you, hey, this is unsigned, I don't like it, go away. Yeah, it's just way better for development, especially for doing this kind of stuff. Why am I not using Windows right now? Because OBS is a little annoying to get running on Linux. Not impossible, but it's different. Also, yeah. I'm more familiar with Windows because I'm a scrub. Okay, so we've got this wait for press. So set that there.
Okay, so now you see how it's kind of working out. So we have these variables associated with the individual button itself by accessing this.
Yeah.
So then all we have to do is go to the debounce tick. We have to modify that. So in this case, is it if button state? No, if this arrow button state.
If this arrow button state underscore state
equals to
wait for press digital read.
And not 8. It's what? This arrow read button pin.
Oh. And then this is going to be
this
arrow button timer.
I think that do we
call it something else? Let's go up here. We called it something. Button underscore timer.
Yeah.
Okay. Is it with a debounce period?
Yep.
Yeah. Just stay logged in.
No, sure, I'll do that. Okay. All right. Okay. Yeah, I'll stay
what?
There.
This.
I think everybody else went to bed.
Underscore state.
Did they go to bed? I can go check and see if they went to bed. I will check on them and shout at them. Oh, T-Cray's lurking. Mew Mew Knight. Okay, let's see if what else is in the stream here. New users I see. Go with him. Have this too. Join effort. Thank you guys for joining the channel. Thank you guys so much for joining the channel. Appreciate you guys. Okay, so
I think you see
this
what's
button
going.
state debalancing, and then we want to.
Oh, okay. We want. I guess toggle status. Actually, we need another variable, toggle status.
So in private.
Yeah, private. Toggle
int
status.
toggle underscore status.
Yeah.
Should we set it to something? We don't know. We need to, right?
That's off.
It should be bool.
Bool actually. Sorry, bool.
Bool. Toggle status equals 0.
And we go. Yeah. No, we don't. Remember, we don't do it here. Right. We do it in the constructor.
Yeah. So this.
This. Toggle status.
Toggle status equals false. Okay. So now we're going to go down to this public function here.
Yep. So we got
making sure everything's generic. Button pin. This button timer. This button state.
Toggle.
And then this toggle status.
Yeah.
I've never done this before, Alan.
Yeah, you notice how it's actually not that bad. You understand how it works, right?
Yeah, it does.
So cool.
And then it should be this as well too.
Okay.
Not this equals to not toggle status.
Yeah, so it'd be this. Oh, be not this.
Oh, not this.
Yeah. You might put more bracket around that. Makes it a little more clear. So that bracket around that, and underscore on the toggle status.
Right. Yeah.
Good night, Karen.
Night.
We'll clean
Night,
up.
babe. Yeah, we'll take care of everything. Okay.
Appreciate it.
Yeah, no problem.
Okay,
Thank you so much for jumping on the stream. I really appreciate you.
No worries. Just do me a huge favor.
Yep.
And when you're done later and you're cleaning up, please plug in my iPad.
Yeah. I can do that.
So that I have it tomorrow morning. Can you pick up over by the iPad?
Oh, sure.
I'm updating all these to do this. Okay. So this would be digital read. This button pin. This button state wait for press. This is crazy. How did I not know about all this?
Well,
this
you never
stuff?
got a chance to get around to it again.
Yeah.
Yeah. But also, we can actually toggle the button on, I guess, as well. Yeah. We should do... Yeah, after you toggle the button, we should actually reflect the actual button itself.
I'm just making sure that everything it says this button state Okay.
Yeah.
Magromancer says, "Wow, I can't believe that this year marks the 20th anniversary of the Moulin Rouge movie. Is it really 20th anniversary of Moulin Rouge?
Yes, it was.
What the
2002.
frick? What the
2001,
frick?
2001.
That's nuts. Why are you gonna make me feel old, Magro?"
Some friend you are.
Oh god.
I think, yeah, we should actually talk about LED as well too, because we flip the status, and we can actually, since we record LED pin, and also we can also send a signal on the serial port at that point as well too.
Yeah, we should do that.
Yeah.
So where?
Okay.
Here,
Under this one it toggles. This is actually triggered
toggle status.
Yeah, we can actually,
And then we should maybe add enter, and then we do serial dot print ln, and then we want to say button, and then modulo s. Which is it? Plus modulo s. Plus modulo s, right?
Okay.
Plus pressed. Like that.
Okay. It's not.
And then it's going to be like modulo again, and
Yeah.
the string we're going to put in there is this button
Toggle status.
toggle status.
Actually,
This-
no. Sorry. Actually, we want the button. Actually, we want the string. Actually, so we should called button name.
Is it underscore button underscore name?
Yeah, that's what we call it. I think that's what you called it, if I recall.
Yeah.
Yeah.
Okay, sorry. Yeah, that's insane. I remember going to see it in the theater with my mom. How do you think that makes me feel, right? Yeah. Honestly, it makes me feel kind of like I think that's so nuts. I remember seeing Moulin Rouge, like, it feels like it was just yesterday.
And
So
we
got
also
this.
want to turn on the LED itself as well too, because and then on this same place, so then it'll be
I think this will work, right, Alan?
yeah.
It should work.
I think actually.
I don't know if I said
actually,
this correct.
I don't need to put.
You don't need the pluses,
You
right?
don't plus. It's actually you don't need those quotes as well too.
So like this?
Inside there, it should go like that, I believe. Not for sure.
We'll
but
try
we can
it. We'll
check.
try it. And if it works, it works. If it doesn't work, it doesn't work.
We'll look up the
Can
document.
we test it yet?
We actually want to display LED as well too.
Right.
So
we say digital right.
And then
this
arrow
LED pin,
comma toggle status. This arrow toggle status.
This toggle status.
Right, and that makes sense, right?
Yeah, that makes sense.
Yeah. Looking at all that, I think we kind of covered this stuff now. I believe.
I think so. Can we should we try it?
Okay. Let's compile it first to debug it, because then we're going to have to modify
verify,
the main
right?
Yeah, verify. Okay.
Class debounced.
Okay. They expect.
Expected a semicolon after something.
Okay. Let me just see here. Let me double check. Here.
Expected a semicolon after class definition. So here.
Let's see. Just looking at what it is. Let me just double check the Arduino, I guess, library.
What is Cool World? Magromancer says, "Oh my God, yes! Cool World is on Amazon Prime. I need to watch that again."
That was Brad Pitt before he became famous. He was a detective and ended up in Anime World.
Whoa. Okay, Magro, if you're gonna watch that, you should do a watch party. I will definitely join you on your stream and watch that with you. That sounds like fun.
Oh, I see. Should be a semicolon right there.
Yeah, that's what I was thinking. So it doesn't need one here too at void.
Not for function call. That's for
verify?
classes. Yeah. Return type. Okay.
Type specification for constructor invalid.
Let's see. There's no void type on the constructors.
So no void?
Yeah, no void. It all returns itself. Yeah.
So verify again. Verify. Okay, down here, class debounce has no member name button name.
Actually, let's go. Did we have button name?
This equals button name. Button name.
Yeah. Let's see here. So we did have this. See, because I guess it's string. Does it allow strings or not?
Class debounce has no member name button name. Did you mean button state?
Just take a look here. I'm looking at debounce tick. No, we created actually go to private. Go back up to private.
I just realized the stream elements here is like faded or something, or maybe it's less. Properties, is the opacity less? Maybe I can make it a little bigger. Oh, I see. The opacity has to be changed in stream elements. So, yeah, it should be alright. It's kind of more like a mature version of Who Framed Roger Rabbit. That's pretty cool. I just noticed that it's like really, really faint down here, the chat. And you can kind of not read it. So maybe what I'll do is I'll change... I feel like it's going to get over top of everything. Actually, you know what? I'm going to change this one for... Or remove that one. And we'll add stream elements for... we'll use the other stream elements. I'm going to use the one from Dual Links because that one actually has a nice chat box. Look at that. I have a custom thingy. So that should be a lot better and easier to read people's comments now. Okay, so what were we doing again?
Okay, going back to here. Okay. Actually, I think we don't have a private variable called button name, maybe. So go into
the button name
class
here.
Definition. So we go up higher.
Private.
Yeah, oh yeah, we don't have one. Yeah.
So it should be string.
String, capital S string. Button name,
comma. So now we're gonna. Do we have to initialize it or anything?
We did actually. We had a construct in the constructor, but we forgot to put it into the private. That's why I was complaining.
So should we verify again?
Let's verify it again.
Magnermaster says, I found a better one for us. Now You See Me is available for free for Amazon Prime members. Now You See Me is that magician one, right? With the I want to say Michael Cera, but
Jesse Eisenberg.
Jesse I called him something else. Oh my god.
Michael Cera's happy to hear that.
Oh, he probably is. He's probably really happy to see
so
that.
Jesse Eisenberg. And I did Lex Luthor for this.
Oh my god. Oh. Whew. Okay, so what do we do here?
Okay, I realized we should maybe, instead of using string, we should use car pointers instead. Okay, so going back to the class definition, instead of using string, call it car pointer for button name.
This one?
Yeah, so car, and then star, asterisk, that's a pointer. And the same thing up into the up there.
Right here?
Yeah.
This one's car star?
Yeah, car.
Why are we doing that?
Well, in this case, because it's C, we're using what's called a pointer. That means it's a reference to where string really is. Because strings are really a series of bytes stored in memory somewhere, but you don't want to be copying them all the time. You just want to get their address. So in this case, we have to use a car pointer.
Okay.
So then in deep down.
So what is a pointer, anyways?
It's like
it's just like a reference to memory, right?
Reference to memory. It's just an address somewhere. So the thing is that unless you know what kind it is, it's just an address. Just this by this location. Or
okay.
So, but and that's where. So how you know that to point to some memory location? It's a little star symbol and stuff. So
Magro says that Back to the Future is free as well. Wonder if 2 or 3 are as well. Yeah, the trilogy is available for free. Alan, you've watched Back to the Future, right?
It's on in theaters originally.
Yeah. Okay. Well, it's good, right?
Yeah, it's good. Have you ever seen them?
I've watched them, but I haven't watched them in completion. Like I only ever came into them while they were halfway done and stuff like that.
You have to watch them from the beginning at some point.
Yeah, I think that would be definitely a good one to watch.
Do a react video or something.
Magro, we should compile a to watch thing, and maybe we can do some watch parties together and watch some of those things, because I definitely would love to watch Back to the Future, and we should do that on the channel.
And yeah, we want to change that string to car pointer as well too, right there. That one.
This one, yeah.
Yeah.
So car star.
Yeah, car star. Think that should take care of that. Let's see if that compiles.
Okay, let's try again. Verify.
Okay.
Invalid operands of type const car 18 and car.
So, this is so then that is trying to think here. Is this conversion?
Is there any way that
it's not. So it looks like it's not that operator. I thought
that was for string though.
Strings, but I think that one's incorrect there.
This one here?
Yeah. So let me see here. Let me just double check.
For some reason, I thought this was the way that it's supposed to be constructed.
I think that was. Let me just see here.
Maggermaster says Jeff Dunham's old comedy specials are available for Amazon Prime members as well. Not sure how many though. My friend Norman actually gave me a couple of Jeff Dunham's DVDs, so I have some of his comedy specials on DVD. Although I think that Yeah, it'd probably be better to do it on Amazon Prime because you can actually stream from Amazon Prime onto Twitch without worrying about stuff. So maybe that's probably a better choice. To be honest, I would love to watch. I know it's probably blasphemy hearing that I haven't watched the entire thing of Back to the Future. So we should probably watch those. Because those, I've heard those are really good, and I really want to watch them.
Excuse me.
Magromancer says, my favorites are Spark of Insanity and Controlled Chaos. I never watched them. I've never watched, I wouldn't know them by name. I've only watched, the certain skits. I've definitely seen the, Ahmed the dead terrorist one. I don't know what that one is. I kill you. Okay, I think this is probably a good time for me to take a moment.
Mm-hmm.
I will be right back.
Sure.
Gotta go visit the little boy's room.
Mm-hmm. And now to fix this up. There we go. So I got to compile. So all I did was just kind of broke them out into separate little print statement and said that would have done. That seemed to have done the job instead of the format. So if it compiled. Okay, so it's not going to work because we just want to make sure it compiles. And actually, you have to actually utilize this class. Mm-hmm. Okay, so
should we do we verify it?
Yeah.
Should we upload it? We have to use it now, as in we have to start an instance of the class.
Yeah. Mm-hmm.
Okay, give me a second. So Spark of Insanity is when Jeff introduced Ahmed. Yeah.
Okay, so how are we going to
So how do we create an instance? We got to do it down here, right?
Yeah,
the loop?
So inside loop. So we're going to get rid of the existing stuff.
Okay.
Right. And so in this case, we have to...
D is equal to debounced? Like that?
Actually, we're going to have to do the outside loop because otherwise it creates it every single time.
Okay, yeah.
So we have to go... we have to create a variable outside it. So go to the top.
Okay.
Actually, after the class. Now we can actually create a class variable. Call it button equals to debounce bracket. And which pin do you want? Pin 10.
Right. We have to take a look at where the buttons are.
Yeah.
So pin... the button 1 is on pin 8.
Okay, so we'll go 8, comma, what do you call it? String.
This was... what we had to take a look at the constructor here. So button pin, button name, and then...
LED pin.
So button 1?
String. Button 1.
Like that?
Yep, comma, and which LED pin? That was, I think, 11.
11.
And that's how you make it become...
Whoa, dude!
Yeah. Okay, and then in the loop, how do we actually use this? Yeah.
So we got to create a couple more. So there's going to be 8, 9, and 10. And this is going to become button 1, 2.
Or red, or whatever you want to call it. You can call it whatever because it's going to display a string.
Oh, we call it red button.
Yeah.
Red button. Blue button.
10. Because a string can sound whatever you want.
Yellow button. Oh. Here we go. And then we want this one to be 12, 13.
Yeah.
Okay, cool.
Yeah, okay.
And then for our
oh,
loop,
actually, we'll call it button 1.
Oh, button 1, button 2, button 3. There we go.
So they're all debounce buttons now. How you handle the loop now is that they've been initialized, and then what you do is that you go button 1 dot tick.
Button 2 dot tick. Oh my god, that's so clean and beautiful.
Yep.
Does it need a semicolon at that?
Yeah, semicolons, yep. And then button 3 dot tick.
Oh
and
my
then
gosh.
you set your delay.
Okay, and then delay 1.
And there, that's how we can use this class.
Hey, give me a second. I gotta hold up for a second because Alan's brain is working at 10,000 miles a minute. Okay, I gotta get up to his 5,000 IQ level right now and figure out what the frick is going on.
Okay, let's see if you understand what's happening. I think you can now.
I think so.
Yeah.
So when we call tick, we're actually calling this entire chunk of code.
Yes.
So when that entire chunk of code happens, we're running through here and we're doing all this stuff where we're inheriting these attributes from the instance that we're putting into it. And in this case, that's like this, right?
Yeah.
Where we have button 1, and the instance has all of these arguments. And these arguments...
Instance state variables, yeah.
The first one being the button pin, literally the pin on the Arduino that the button is hitting. The middle string being the actual description of it. And the last one being the LED pin that we output to show the status of it being on and on. Give me a second, I'm reading here. Magamancer says, also, Now You See Me 2 is available for free with Prime. Did you ever see the new Bill and Ted movie? No, I did not see the new Bill and Ted movie, sadly.
Heard it's good.
Yeah?
Yeah, but it was hard to find streaming and stuff, but I never got around to it. We should sit down sometime and
Yeah, we should watch
it.
it. We should watch it. I know that my buddy Norman downstairs, he rented it. So he said it was really good. I never saw the original Bill and Ted movie, though.
You should watch the first two. You have to watch the first two.
Really?
Especially the second one. But first two, yeah, you have to watch it first. Yeah.
Oh my gosh, I feel like a cave child. I don't know any of these awesome videos. Can we watch Amazon? Can we watch on Amazon? Bill and Ted? Magro, let me know if you can watch Bill and Ted on Amazon, because I will watch... at least I have to watch the first two, because I haven't watched any of it before. I love those kind of movies that are kind of stupid but funny ones. I love those kind of movies.
Yeah, it's Bill and Ted's Bogus Journey. The second movie. That's one of the, again, it's one of those movies that some actually the sequel sometimes better than the first movie.
Should we try and run this?
Okay, we have to double check initialization, because we have to go to the init. Because if we have some extraneous stuff in there we don't need, and that's fine. Actually, a lot of this stuff can go.
Right. So we don't need this button one timer now.
Yep.
Because we have it all contained inside of the thing.
Initialize either.
This one?
Yep. That stuff is fine.
That's
the toggle status, we don't
need that either.
No.
Oh my god!
Wow.
Oh my god! Did you guys just see how much code we just deleted? Somebody call somebody. We need a witness for all this code getting murdered.
The setup, of course, all the pinwheels are set by each individual instance. Well, too. That also gets all deleted too.
What?
What?
Oh right, because we're individually initializing them, so we don't need any of this crap either.
No. And you just need zero begin. That's it.
He says, you definitely need to watch Bill and Ted 1 and 2 to watch the third one. Okay, I will definitely watch them.
Let's actually also take that setup and move it close to the loop function, because right now it's sitting as lonesome. We have all the kind of setup beforehand.
Yeah, and then this is going to go down here and do its thing.
Yep. Like that.
Really, all we're doing is setting up the serial.
Yeah.
Okay, and let's go up and check our initialization.
Yeah.
Okay, with this stuff we still need, right? Debounce period, we still need that, because that's going to be 50 milliseconds.
Yeah.
Really, 50 milliseconds is such a short amount of time, you can't even really comprehend how short that is. It's like the flap of... It's probably like 3 flaps of a hummingbird wing. Probably... yeah.
And now our debounce button class encapsulates all that stuff, handles all the messy details.
Debounce, public, all this stuff. Private, this stuff.
All the variables he tracks.
I'm just trying to... I've never seen this before, where they do this. So public is debounced. Okay, so this public stuff is stuff that everybody gets to use, right? Yeah. It's the stuff that everybody references.
It's a public interface that you're supposed to ignore the details. You don't need to know anything else. Leave the rest to us. That's the whole idea.
Yeah.
So all you need to do is create a button called a tick.
And so private, this is the stuff that gets changed on a specific instance.
Yeah. For instance, it saves all the stuff, because that needs... Each instance needs a stuff for its own purpose to retain. Each button needs to know its state and its timer and all its own pins.
Okay, then down here in the debounced thing.
This is the constructor.
Constructing
whenever whenever you create it the first time, what do? Well, we need to save all the names of all that stuff. Also have to separate inputs and do all this. This is all initialization.
So once we have an instance of debounced,
yeah.
we're inheriting all of this information from the stuff that we put in to the constructor.
When we construct a pin, we give this information, build us a debounce button, use this information. Oh, take this, take this, take this.
Take this. It reprints it inside. Then it passes all this information down into the function tick. Once we got this function tick going on, we're taking all this information from this.
Each button, when it ever gets called on its own tick, it does all the stuff.
Okay, yeah, this totally makes sense to me, actually. This makes a whole lot of sense. Okay, well, I guess the only thing left to do it is to try it.
Yeah.
Nothing left to do it but to do it. So let's get to it. What program am I using? I am currently using the Arduino IDE.
Which is more or less C++.
Yeah, it's essentially C++. Magromancer says you have to subscribe to MGM to watch it for free on Prime. Also, you can buy the UHD of 3 and have it for as long as you have Prime membership. Okay. But yeah, we're just using the standard Arduino IDE, which is essentially just C or C++.
Is it C++?
It's C++?
Because you have class in C++.
Okay. All right, time to hydrate. Vegito. Kick, kick, kick. Vegito tastes blue. Or green, or should I say green? I don't know. Okay, so shall we try it?
Try it. Let's upload it.
Let's try it. Upload it.
What?
What?
Oh, okay. You have to tell the type, which is debounced.
Debounced?
It's a debounced object.
Is it colon?
No colon. Just debounced. Because if you say debounced, it's kind of weird this way. So.
What?
Because I also tell you what kind of type of thing it is. Okay, I believe that should be fine. Let's try that now.
Sorry, I've never done this before. I've literally never used this weird constructor scheme. It worked! It worked!
Okay, let's see if the buttons work.
Oh my god. I'm scared. I'm a little scared here. Holy crap!
Buttons.
Hallelujah! 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 It's working. It's totally working right now, guys. You can see that when I press the first button, I can press it down and hold it for as long as I want to, and it only turns on once. And when I press it again,
it only toggles on a second release and press. This would help Bizarro a lot.
Oh, yeah. I don't know if you were here for the beginning of Magro, but we debounced. We dedicated this entire debounce section to my friend Bizarro, who really hates debounce. So if you if you're watching this, Bizarro, we love you. Oh my god!
And now you can handle any kind of debouncing now with this class. You just include this class.
Oh my gosh!
You say this is a library now.
This is freaking sexy.
And let's actually check the.
That's pretty. Oh my gosh, that is so cool! Right, we have a console. We can read the information as we're processing it.
And it only happens once.
That's freaking amazing. So let me go in the column here. Red button pressed.
It only gets triggered once.
That's crazy. I'm pressing it repeatedly, and it only checks on the press.
Yeah.
That is so sick. That is, oh my god, I'm so stunned right now. Smith13 says congrats. I literally want to jump up and do a little dance. I think I want to. We got it going. We got it working. Oh yeah. So the software is finally complete. Yes. We did it.
Yep, there you are.
We did it.
Yes.
The hard part has been completed. We now have it reading and toggling correctly. Now we need it to do stuff. So now that we have this, I'm going to save this first before we do anything else to mess it up. we're going to create a Stream Deck Test 4. Now that we've gotten to the 4th iteration of the software. But I would just like to take a short moment to just appreciate this, what is it?
The elegance of the code?
The elegance of the code. We managed to create this really sweet button toggle system in 82 lines of code. That's pretty good, I have to say. Oh my gosh. Oh my gosh. Smee13 says this, that's why it's all making sense. He started in C++ and then went to C on Python. I honestly love Python, so if you program in Python, you rock. C is awesome too. But Python is like my first love, so. Magramat says, want to feel even older, Jordan? How the Grinch Stole Christmas starring Jim Carrey came out 21 years ago.
That was a great movie.
Oh my god. Woo! Okay, well, oh my gosh. I can't even believe that we've gotten this far.
As well, too.
What?
Now you can do asynchronous stuff as well, too.
Yeah.
In your loop, you just put things that do their own ticks and stuff.
Okay, so the big problem is that normally, remember how we were doing it the first time, where we were using delay? The problem with delay, as we mentioned before, is that when you hit the delay function, it literally shuts down the processor within the unit for the time of the delay. So if you say like delay 10 seconds, for 10 whole seconds, your chip, literally the only thing it's thinking about is
nothing.
And so when I was doing the project with Bizarro, we kept on having issues where if it was in the delay, it wasn't doing things like reading the sensors. So when you went to go press a button, it would hit delay, and then suddenly it would stop functioning for a few seconds and then continue onwards. And what he really wanted to do was make it so that you could read multiple inputs at once. And of course, if you're currently delayed and your chip is thinking, "Doi,"
and it can't check the next button.
It can't do anything. It can't check the next button. It's obviously not going to be able to. So that's the reason why we have this kind of this system that we put in here is so that you can actually read multiple buttons at once. If you notice here, when I press this here, I can like release one button. I'm still holding the first button down, and I can like you can press multiple buttons at once, or turn them all on at once and stuff like that. So even if all of these buttons were pressed at once, it would still be able to read individually which ones were pressed and then pressed again to untoggle them. So I think that's pretty nice. I think that the entire, like, I'm just like, I'm really elated that we got this far. Why? Well, I've never used any of this stuff before where we're...
Now you learned a little bit about how to program classes in C++.
That is so cool.
Not as hard as people make it out to be.
Yeah.
At least if you don't worry about inheritance. Then it's messy. But these days, don't use inheritance.
Yeah.
Use composition. Don't use inheritance.
This is really sweet. Okay, so now we're in the Stream Deck Test 4. So what do we need to do for the Test 4? Well, we need to make this little device turn into a USB keyboard. Right, Alan?
Or not. But now that we have access to the console, you actually create a little Python program that reads the console and issues keystrokes.
Oh. Is it better to do it with Python in there, or is it better to do it all in one?
Well, I guess it's all in one.
Because I remember we were looking at it before.
Yeah. Or do you want to do your own version? Or do you want to depend on someone else's library?
Oh yeah, let's not depend on someone else's library. The thing is, I don't know if I want to use a Python program on top of an Arduino program, just because it's more of a stack. I would really like to be able to just like
plug it in and use it.
Just plug it in and use it. So if we can, I would love to have all of the stuff we need in this one program, if we can.
Yeah.
So maybe we'll take a look and see how to do the USB library thing, yeah? The Arduino USB keyboard thing. Yep. And Magromancer says, hey Jordan, season 1 to 7 of Buffy the Vampire Slayer is free for Prime members. Oh, that's really cool. That's really cool. And I would be super into that if I didn't have this. CareBot this bad thing, which has all 144 episodes and more. I'm reading that off the back. But this thing, me and Kara have been watching. This is some good stuff in here. And then after we finish watching this, we're probably going to watch Angel. So, although now that I think about it, if season 1 to 7 of Buffy the Vampire Slayer is free on Prime, you know what I could do is I could do a watch party. And next time I go to watch some Buffy the Vampire Slayer, I could watch it with all my cool friends. All you guys, all you fine folks. That's what I was referencing. This is crazy. I'm actually so proud of us that we got this far. Oh my gosh. Okay, so here we go. Is the stream following what I'm doing on the screen right now, or is it not? Let me see here. Build stream. Okay. Okay, it's following my desktop. Good, good. So now we're going to go in here. Oh, my stomach's not doing so well. I better drink some more Vegito. Maybe that's the reason why my stomach is rebelling. It's because I can feel Vegito inside my my stomach kicking in the walls.
Alrighty, okay. Actually, looks like there is a library. Here we go.
Actually, do you mind? I'm going to be right back.
Sure, no problem.
I'm going to grab a glass of water.
Okay. Okay.
I'm back. Okay, give me a second. I'm reading what people are saying in the chat.
Yeah.
Magro says, 9-year-old me is screaming right now. Season 1 to 11 of the X-Files is free for Prime members. Oh, I love the X-Files. I really like the X-Files. As my stomach was a little upset, so I went off and drank a little bit of Pepto-Bismol. Hopefully that'll settle my stomach. Nothing but a little bit of pink bismuth to help my stomach settle. Ugh. Okay, so what do?
Okay, well,
what do we
looks like there is a way to make Arduino emulate a USB keyboard. It depends how new it is as well too, because
this is the Arduino Uno.
Uno, yeah, because in the new ones, it depends on the. Let's double check here. Looking at this here, so you need to flash an alternative firmware onto it in order for it to talk to.
I just realized I'm blocking my own screen right now, so I'm going to make this a little bit smaller so that everybody can read the same thing that we're reading. Lost is available for Prime members. Norman actually gave me seasons 1 to 3 of Lost, but I haven't started watching any of it just because I sadly haven't had time yet. It's so hard to have time to watch all these awesome shows. I do love watching TV shows. I think it's crazy that Buffy is on Prime because I bought the Buffy DVD set specifically because I couldn't find it on Amazon, so it's really surprising to see it there. Magromancer says, "I got one word for you, Jordan. Don't." Well, thanks, Magro, for your your very concise review of Lost. So there's a way for it to emulate a keyboard, right?
There is. So it depends on the version of the Arduino as well too, because it requires.
Do you think it'd be easier for us to use a Python program?
Well, I guess we could try running this program. For example, there's an example mouse, I guess, keyboard message example.
Okay.
It might be compatible. They may have updated Uno to it, so we can do is we can run the sample code first.
Yeah, let's try it.
All right. So so apparently all you need is.
Magro says, "You know how people say the ending for The Sopranos sucked? What, is Lost even worse?" What do you think, Alan? Did the ending to The Sopranos suck?
I think here. No, I was fine with it. I was okay with the ending.
Alan says the ending was okay. He was okay with it.
I know that some people didn't like the I guess the fact that it left everything hanging.
I mean, with something as big and kind of like Sopranos is kind of epic with how long and all of these different characters it hinted on. So like, it's really tough to take all of those characters and then wrap it up in a satisfying way. Just because like the whole world there's so much there. I don't know. I think that's really hard for all these creators who create these huge, massive worlds and then trying to give absolutely every single little character and every side character and every single person like a good conclusion. It's really hard to do that. I don't even think it's possible if you have so many characters. Because, like, yeah. That's another one I really want to watch is The Sopranos. I really like The Sopranos. At least as far as I watched it. What do we do here? Oh yeah, do you want to send that link to me?
Okay,
Did you send it to me?
So give me a second. So there's an example.
Oh, should I just look it up? It's called keyboard?
Just look up Arduino keyboard.
Keyboard.
Input. Here we
This
go.
one?
That function.
Is it in examples?
There is a. If we go back a step, there should be an example code.
This one?
Let's see. I think.
Oh, this one? Hackaday?
Yeah. Let's look at that
Well,
one.
let's check out Hackaday. Hackaday is what we want. We did call the stream hacking a stream deck, so we're on Hackaday now, so you guys can tell that we're hackers. Leonardo's Anicle explains the build he sent in. The lowly Arduino Uno can serve as a USB HID keyboard. Oh my god, that's sick. Lufa firmware to emulate everything from joysticks? That should be another build. We should do a build where we create our own, like 3D print our own controllers. We have, like, these buttons would be perfect for creating, like these buttons here would be perfect for creating, like an NES style controller, where it's just like a little block, and you've got 4 buttons for up, down, left, right, and 4 buttons for A, B, X, Y, or whatever. And if we wanted to, we could even give it little shoulder buttons, right? Oh my god, that'd be super cool. I think that'd be fun. That would be a good project for the future. Here's a great one for you, Jordan. The 41-year-old virgin who knocked up Sarah Marshall and felt super bad about it. What the fuck? Macro. What? I know that those are all movies. So, there. Okay, let's keep going down. Should we look in this? Watch the video?
Let's see what it involves.
Should we watch the video? Yeah. Okay, let's go on the video. I hope we don't get in trouble for watching a video on stream. Are we going to?
I don't know what it's like.
Oh my god. You guys, am I going to get in trouble for watching a YouTube video on my stream? I'm so scared. I'm actually legitimately scared right now, you guys.
We can watch it offline and then
Yeah, I might have to switch to... Here, let me switch this off. I'm just going to switch my camera off like that. I'm sorry I have to censor this part of the video, but that's just life. Being a streamer and worrying about DMCA coming and doing bad things to me. So... oh, and I probably have to mute the audio too. Give me a second. I'm not going to mute my mic. I'm just going to mute my desktop audio so y'all can still hear me talk crazy crap and stuff. Here we go. Whoa, his freaking video's bad.
It's only 18 seconds long. I was just demoing it.
He's just demoing it here.
It's
like a 3 FPS video. What the heck?
So I think, is this the one where he...
Maybe this one doing it? Oh, this guy's got volume up and volume down with it.
Okay, but he doesn't show how to actually do it. He just shows net result.
Oh, that big jerk! Ah! Oh, here we go. Maybe this one? That... Okay, so actually we can turn on our screen again so that we can show what we're looking at. Give me a sign. It says here, as long as there's no copyrighted music, you'll be fine. Yeah, I'm agreeing with Smeeth here. He says better safe than sorry. I'm going to have to agree with that because I don't want to get DMCA'd or whatever. So, I don't know. I would love to watch, like, random YouTube videos on my stream. I've heard some horror stories about people going on the wrong video. I think some videos are more demonetizable than other ones. Is that a word? I don't know if that's a word. Atmega 8U2 chip on the Arduino Uno. Okay, wait, hold up for a second. Yeah. They're using a different chip than us.
This is why, because the early Arduino Unos, they had an FTDI USB chip. Okay. They can't be reprogrammed. They're just communication stuff. The later models actually use the actual Atmega instead of FTDI to emulate it. But then but since it's an Atmega, it can be programmed to not just be a serial port anymore, but also be different kind of firmware and stuff.
So will this one work? This is the
know,
Arduino Uno
Yeah.
with a... Jeez, that's really dark.
Mm-hmm.
Can I borrow your light? Thanks. Thank you, Alan. It's got an Atmega 328 P-PU. Yeah.
But that's the main one. But then we're looking at the where the
Oh, the FTDI chip?
Is it?
Okay, that's really tiny.
Yeah.
Give me a second. Hold up.
Sure.
Hold the phone.
So is
Yeah, actually, can you hold the phone?
Sure.
Magro says, as long as you don't show I spit on your grave, it'll be fine. Yeah, thanks, Magro. Thanks for the hint. That was a really awful movie. or I don't know, gritty movie? It's a very gritty movie. Okay, here we go. Atmel Mega 8U2.
Ah, it is.
Okay, good. Yeah,
Okay,
yeah.
so
That's what that's what we want.
So that means it's programmable. So
Okay, good.
The thing is that it looks like we might have to use Unix and stuff.
That sounds hard.
Or they say they also install Windows and Mac instructions, official DFU documentation. So to download this file, they were supposed to upload it, I guess, to it.
So should we try?
Let's take a
Should we open this official Arduino DFU documentation?
Yeah.
And then we need to download these suckers, right?
Server files, yeah.
So let's download them. Oh.
They're
No!
gone.
The file died. Guys, this is a really bad problem. So we're going to figure out our own solution for
maybe
this.
someone else has it. Or okay, I guess maybe we'll do it next time. We'll just write our own little Python program or something like that.
Yeah.
You know? Or if we can track down the hex files, then we'll be able to do it.
That's like hitting a brick wall right there. We really need these firmware files. Oh. Crud.
There must be another place that has it. Someone must have cached the file somewhere.
Okay. Shall we Google it again? Arduino USB keyboard. USB keyboard.
Keyboard, hex file.
Hex file.
Oh yeah, looks like they're in GitHub now.
Borat subsequent movie film. I wonder if you could stream that one. That movie is really funny. It's definitely. I honestly didn't expect them to make a good second Borat film, but the second Borat film was really good. I don't know. I thought it was even better than the first one. I know, controversial, right? Okay, is this the one we want?
It's on GitHub. Let's see.
Oh, I think this is what we want, right?
Okay, go to firmware.
Firmware?
Let's take a look. Is it signed 9 years ago?
Uno.
Uno?
So we probably want to use this one, the Uno one.
We need both. Remember, we need both Uno and also the keyboard file.
Okay, so wait, give me a second.
Sure.
Control-Shift-T. I accidentally deleted that one that we were using. Is it here? Can I go back? Nope. Now we're in Streamlabs. So should I just download all three of these?
You don't need a Mega. This is only we only need
only three in Uno, right?
Yeah.
Okay, so how do I get this?
I think you can. You have to kind of.
I have to open it maybe, and then
go to raw file because this is all hex code.
Raw?
So yeah, raw, and then you can right click and save as.
Just copy it like that, or maybe
you can can you right click and save as? Yeah,
save as.
And then there it is.
Okay, cool. So let's put it, I guess, in our documents for now, or maybe we can. Should we add it our Arduino?
Let's put it in the same folder as the current stuff.
Okay, so.
Oh yeah, right
Stream
here.
Test 4?
Yeah, let's put in the root folder.
Maybe make a new one here. Let's say folder Arduino keyboard files.
Yep. Okay, and get for the TXT.
Yeah.
Yeah.
Save.
Save. And we did that for the other one as well too. That was the serial, and then also the keyboard one.
Okay. And the Uno, this one?
I thought we got that one already.
Oh wait, we got this one. We didn't get this one.
Yeah, need a keyboard.
Let's go to raw.
Right click.
Save as. TXT. Save. Boom.
Okay.
Okay, so now this is another crazy thing. I've actually never flashed a file with a hex file. Wait, except we did do that one time when we were doing, I think it was like the Atmega 74 or something. I can't remember.
Yeah, you're trying to actually
some
make
weird
it
thing
operate off the internal oscillator. I think.
Yes.
You're trying to do that before. Yeah.
this is really cool. We're doing new stuff with Arduino that I've never done before, so that definitely gives me a thrill.
So yeah, updating the firmware.
Magro says, "Oh my god, that's awesome! Sausage Party is on Netflix." That movie was weird. That movie freaked me out. I kept on hearing my potatoes screaming and stuff like that afterwards. Messed with my brain a little bit. So we have to download one of these DFU programmers, right?
Oh, we have to download the Flip Programmer.
This one here?
Yep.
Okay. Okay.
Do you want the one without the JRE? So... let's see which one is it. I guess it's...
We want
one included, yeah.
I guess we have no option, really.
Yeah, you don't have Java installed.
I definitely don't have Java installed.
So include the one that includes its own runtime environment.
Alright, let's run this puppy. Magro Answer says, "What do you expect from Seth?" I mean, you're right. At the same time, I remember when we went to the theaters and watched that movie, and your mom had no idea what we were going to go see, and yeah, it was a weird movie. Oh shit! Should I have gone custom setup?
Should be fine.
Okay.
Let's see if there's anything else we need to download and install. Well, it's actually going quite quickly.
That reminds me. I really want to go back to the movie theater, and I want to do that. What is that? VIP seats again? I mean, obviously once the pandemic is over or whatever. But that was really cool. They had this cool thing that was like everything was like in the dark, and you could order like burgers and stuff like that and eat them in the movie theater and beer. That was nuts. I honestly never thought that I would live to see the day where I get to drink a beer in a public movie theater
and not get tossed out.
Right? So just install?
Install.
Good? Okay. We don't really need a desktop shortcut, do we?
No.
Do we need the remake? Probably.
You don't need, well, you don't need to read
We
it.
can all delete it, right?
Yeah.
If we need to.
Okay, so let's go back to that page.
Okay. Which one?
Arduino. Yep. So we download it. Okay. So we now, I guess we go down and install it. So we go down further. We have the firmware we already have. Yep, we got that.
Do we need this?
Oh, they have their own version. Okay, we could have got to here too. But let's see this new link.
At Mega XXU. Do we want any of these?
I think the file we got already is fine, I believe.
I think so.
Yeah.
I just don't know.
Yeah.
How would we know which one would be the most recent or most useful?
Well, I assume maybe that might be. Oh, actually, I see here Uno and DFU USB serial combined. No, that's interesting.
That has support for Genuino boards.
Let's go to USB serial.
This one?
Yeah, let's look at that. What does it say here?
Mine is an 8U2. These ones say 16U2. I think we got the right one, Alan.
Yeah. Okay. So apparently you can't brick it. Apparently.
You can't?
You can't brick it. So I guess.
Okay.
All right. So we'll give it a try. We'll try the firmware.
Maggermaster says, I hope all the points that I accumulated don't have an expiry date on them. Here's a good one for you, Jordan. All the Twilight movies are available on Netflix. Maggermaster, how dare you? How dare you? I don't like my vampires to sparkle, thank you very much. Okay? Vampires are supposed to be mean and scary. Can't believe they made vampires sparkle. That was my biggest problem with that. Okay, so now we should check on here what we're going to see what do now, right? Version suitable for your board.
We already have the hex files.
Uno and Arduino USB serial Mega hex. Okay, so we got those, right? Firmware is also okay within the Arduino software. Oh, hey, look at that. It's actually in the Arduino software.
Okay.
So we didn't even need to download it. If your board is Arduino Uno R1. Whoa, what the frick? We have to jury rig and put a frickin'...
Is it R1 or...
I don't know if it is. Oh, it's R2.
Okay.
We're good. We're good. Oh my gosh. See, like, look at this janky shit that you gotta do in order to make this work. So please excuse my language. I did not mean to say the S-bomb. But that is some janky ass crud right there. Look at that.
Is everyone seeing this on the screen?
I think so.
Yeah.
I think they are.
Are they? Oh, yeah.
Oh, yeah. It's going to take a moment for it to re-update a bit.
You have to solder a resistor.
That's crazy. You got to solder a resistor to the bottom of it. That's janky. Okay, so let's keep going. Connect the Arduino to your computer with a USB cable, just like you do whenever you're programming it. Magro says, you know I had to do it. Did you have to torment me? Did you? Okay, and what about What We Do in the Shadows? Oh my god, I love that movie. What We Do in the Shadows is so good. What I'm looking forward is What We Do in the Shadows 2, I think? The new one?
You mean the series?
I guess it's a series?
It's a series.
Oh my god, it's a series.
It's a series.
I really want to see that. I've never seen it. I don't even know where you would be able to see it, but I would love to see the series now. Okay, reset the 8U2 or 16U2. To do this, briefly bridge the reset pin with the ground. The pins are located near the USB connector as shown in this picture. Connect them briefly with a piece of wire. So, give me a second.
Probably want to disconnect other stuff.
Hold up. What? What the fuck am I supposed to do?
Yeah, near the USB port. Up over there.
Oh, okay. So give me a second. I'm going to grab a piece of wire that I can use as a jumper. This is crazy. We got to do some crazy stuff to make this work, boys.
We have to plug it in, though, when we do it.
Do we?
Power it on. Yeah, they say to power it on first.
Okay. This is weirdness. Yeah, I really like What We Do in the Shadows. The original one was so funny. So I got to plug it in?
Yeah.
Does it matter all this other crap is connected?
Maybe want to take it off just in case.
I mean, it wasn't that hard to connect it up anyways, so let's just yank it off.
Yeah.
So I'll put that off to the side. We'll make use of that circuit again in the future. And now here, we have to connect this pin here?
Yeah, those two pins at the very end. So
is it going to be that one and this one?
Yeah, above. Yeah, you reset it. So then disconnect.
Okay.
So we reset it, so now it's no longer...
I connected them briefly, and then that actually shut off the Arduino briefly.
Yeah, essentially reset the conditions. Reset the firmware.
Do I have to do it again? Or
no,
is that
we did it. So then check the serial ports, and the serial ports should not show up, which is okay. So let's go there. Yeah, that's fine.
Oh my god, it doesn't show up anymore. That kind of panics me.
You killed the serial port. now I have to reprogram it.
It's dead, Jim.
Yeah. So now we have to use flip to upload the hex file to your board. So we have to scroll down. Let's just double check here. Okay, that is... I guess we have to use a flip program. I assume it'll detect it, I assume.
Okay, let's use flip.
Okay.
So we go on to here, flip. Magro says, I can't believe they have on Netflix Canada the original Police Academy. Police Academy, ever heard of that?
Yeah,
Alan?
I remember that.
I've never heard or watched it before. Select target device?
Yep.
It would be like 8U2 or something?
Yeah.
At Mega...
Yep, there it is, 8U2.
Oh, yeah, there you go. 8U2, right? And then we want to add the selected communication medium. We're doing it.
I guess
We have to add a file, load hex file, right? Let me actually look at what it says. Upload. Use flip to upload the hex file to your board. But we had two files.
Yep. So we should
Which one do we upload?
We should check the full information. So there. Yep. So we want to erase it first. Then we want to flash the serial, reset it. Okay, looking at this. Yeah, assuming that you know what you're doing, they're using Linux or Unix.
But they're doing it. They're doing it like this. Apparently,
Yep.
I think that maybe we just have to use the flip.
Yeah,
We have to use the flip entirely.
So first we have to erase it. So DFU programmer, we have the device.
So we got the device. Chose the device.
Select it. And
That
then
communication
next
medium.
USB.
Oh, frick. Do I have to choose a device? Select?
Select.
Okay,
Okay, we
no, we
did that.
selected that.
Go to settings, communication. USB.
Communication USB.
Let's just unplug and plug back in.
Just unplug
Yeah,
it back.
maybe.
Unplug.
Okay.
AT-lib USB
Okay, let's Google search
DFU.dll.
on that. At lib USB DFU.
At lib DFU.
Yep, there it is. There we go. Solution. Why is it not found?
Check this one out.
Yep.
On AVR Freaks.
Okay. Oh, we have to install a driver as well too.
Device driver from Flip 3.7/4.7/UB.
Oh, okay. Let's just go to device driver.
Okay.
Yeah.
Where?
Just Windows device driver.
Device manager?
Device manager. Yeah. Sorry. Okay. Is that it? No, that's the thing we found previously. Oh, yes.
It would be this thing.
Let's actually uninstall and reinstall that. Update driver.
Uninstall?
Yep.
Should I plug it back in?
Yep. Plug it back in.
There it is.
Okay. It still shows up again. I guess let's try it again. Let's go back to the Flip.
What the heck? Close that. Flip. It's broken.
And we have to reopen it again, maybe. Maybe it
It's
didn't
dead.
Didn't like to be open in the middle.
Yeah, I did not like
Okay.
that.
Device manager.
Task
Task
manager. Kill it. Where's Flip? Where's Flip? Where's Flip? I'll find you, Flip. Well, I'll find you. And when I do, Flip, I'll shake my fist at you.
Oh, I think I know what it is. Look for Java.
Java?
Yeah. Sort under name, look for Java. There it is. I just saw
Oh,
it.
yeah, you just saw it.
It's because this is running under Java.
A, B, C, D, F, G, H, I.
Okay, it looks like it's running the system.
What the frick? What the frickin' frick? What the frick? Is it here? System here? Windows
Yeah, because
processes?
I remember I saw it a moment ago.
I just saw it too.
Yeah.
I swear I did. It was like the little box for
Yeah.
Java runtime environment or whatever.
Yeah. Oh, there
Here
it
it
is.
Die!
There it goes.
Okay, let's run Flip again. So we check this thing, 8U2, right?
Yep.
And
Communication.
then a USB.
Yep. Let's see if it does. No, it's still.
AT
Okay,
AT
so it
lib
looks like we
USB
need to
DFU.
find a. Okay, it looks like you have to manually kind of direct a certain directory. Okay, all right. So it looks like there's a folder of the drivers. You have to identify it. So I think we have to reset it again first, and I think maybe if we
So reset it again?
yeah reset again.
Okay, I'm resetting it. Give me a second. Okay, reset.
Okay, and then unplug. Okay, now we have to.
Do I have to unplug it, replug it?
No, don't unplug it because I think it needs to be in the reset state. So then we actually have to go. Let's go to the device manager.
Okay.
Yeah. And okay, there it is. Right click.
Yeah.
Go to update driver.
Update that driver.
Browse my computer for drivers. Browse.
Browse.
And we go to your C drive. Go to your programs 86. Go
Okay.
to the Atmel.
Okay.
Go to the
Flip.
USB. Go to the
Upper driver?
AMD 64 drivers.
This one?
Yep. Hit OK.
Okay, hit
And
okay.
then hit next. No. Okay. Let's try looking for update drivers. Nope. Can't seem to find it.
Huh.
Okay. Yeah. So from what I can tell, looks like that's how a person found it. They had to go to.
Alright, this is requiring another power up, guys. Vegito, give us strength. Oh my god, you guys, it's working. My key is rising!
Okay, so x86 flip. Maybe it's just USB. Let's just try that. Just USB.
Okay.
Okay, let's try it again.
So go to Device Manager,
right click,
update driver, browse my computer for drivers, browse, and just in USB?
Yep.
Just here?
Just that one, yeah.
Okay, next.
Okay, install.
Oh, okay, there we go. Oh my god, it worked!
Okay, so yep, there it is. Now shows up in Atmel device.
What did we just do to this thing? Why did the Arduino turn into an Atmel USB device?
Because we reset to act like a generic USB, but not as a FTDI device.
What did we do? Did we brick it?
No, it's in receptive mode to talk for it to command to do whatever we want.
Okay, so it's not broken?
Not broken. No, it goes flip.
I'm sorry, I'm scared. Open.
Oh, could not open.
Should I close it and reopen it?
Okay. Let's restart this program maybe.
Yeah, let's close it and reopen it. Flip. Mega Man says, here's a good one. Fear and Loathing in Las Vegas is leaving Netflix on March 1st, so if you haven't watched it yet, you should check it out. I haven't watched Fear and Loathing in Las Vegas. Is that a good one?
That was actually good. It's weird, but it's good.
Okay, I'll definitely check it out then.
Yeah.
So 8U2, USB, open.
Yeah. All right.
Oh, that's so weird.
ISP exception. Let's see.
Should I look this issue up?
Yeah.
com.atmel.flip.lsp exception. Atmel.flip. ISP. Oh shit! Let's just run it again and see what the fucking thing was. I can't. I'm sorry.
Com.atmel.
Com.atmel.flip. I'm sorry. I'm swearing so much, guys. I apologize for my filthy language. I'll try and behave in the future. Com.atmel.flip. Ah!
Can you alt tab? Try alt tabbing.
Alt tab.
Yeah. Oh, I saw it a moment ago. Alt tab again. There it is. That window right there. So ISP exception.
There we go.
Yeah.
Should I cancel this?
Cancel.
The ISP exception?
Yeah.
ISP exception. Need help ASAP. I'm frustrated.
Stop shouting.
Stop shouting. I love that. That's some funny crap. Communications on via USB. Once I press OK in the window that popped out, it says com.atmel.flip.isp exception cannot open USB device. Deleted. How do that? Deleted. Oh my god, this entire freaking... People are getting freaking banned. I have another problem. My Arduino doesn't enter DFU mode. When I try to do the steps I'm putting the board into DFU, it just doesn't work. There are no new drives detected. I can't flash it because it says it could not open USB device. Nope, nothing. And now I see in my device manager if the board enter DFU modes. Any other alternatives? Why do you want to mess around with a 16U2? Why do you want? Okay, let's check the second page. Please, God, there be something more useful than just a bunch of deleted comments and people being a bunch of glue eaters.
Okay, so I guess not the forum here, so let's actually go back out. Let's go back to Google. See what else there is.
Trouble with flip USB drivers? This one? I really like The Clockwork Orange. That's one movie that I have watched multiple times, and I recommend that anybody who likes that kind of psychological thriller kind of thing really should check that out. I love Clockwork Orange. Even though it's not really a movie that you love, I love it. I'll tell you that these USB problems are about to push me to the point of ultra-violence. So just a little bit of ultra-violence.
Actually, this is from 2008. That's years ago.
Yeah, it is.
Yeah, let's actually go.
Try Reddit?
Mm-hmm. Yeah.
Oh, he's flashing a plank. Completely different device. No, I don't want to be signed in right now. Okay, whatever. How can I get this thing to work? This is the actual data thing.
Mm-hmm.
Now we're getting into the real jungle now. Device firmware upgrade. What do we do?
Keep scrolling down. So we kind of come across something. Keep going down.
Okay.
Set to protocol.
Oh my gosh. Okay, Magrabaster says, it's on Crave. It's an amazingly well done movie. Really resolved that well if you like those kind of movies. If you haven't seen it, you should check out Existence. It's got a similar feel to it with the way it ends. I know, I like the ones that don't resolve perfectly. Then they leave a lot of questions in your mind. And then it makes you think about the movie instead of being like, oh, that was a neat story. Everybody lived happily ever after.
Can't watch that again.
Right? That's probably the reason why I keep coming back to watch Clockwork Orange again, is because you kind of get you get a little more every time you watch it. I think that's like a lot of Kubrick films, actually.
Yeah, this is kind of deep in the stick, so let's get out of this.
Yeah,
one.
as I said before, we're in the jungle now.
Yeah,
We're in the jungle now. I don't know if we're where we should be.
Let's see
Should we look at this? Upgrading USB firmware using a flip?
Let's take a look at that.
Let's watch it. There, let's turn on the sound so that we don't get...
Hello all. In this video, I shall explain how to upgrade the firmware for the USB UART IC on Arduino board.
I feel like this is where we should be right now.
This is the USB UART IC, 80MB8U2 or 80MB16U2, found on the Arduino Uno board. This is behind the USB connector and above the crystal. A small assembly chip. That is this chip provides the USB functionality to the Arduino Uno board. When the firmware on this IC is corrupted, even if you connect the USB wire to PC, there will be no response. The LED may light up, but there will be no response inside the device manager.
Huh.
If you open up the device manager and plug the USB wire, there will be no response. That plug and play response is not there. To upgrade the firmware, we have to collect first the hex file, which is the firmware itself, and the flip software, FLIP, from Atmel. First you have to download the flip software, FLIP. That is a firmware upgrade software of Atmel. Go to Atmel's website.
I just realized that it's getting mostly me. I'm going to turn this a little bit so I can get both of them.
Typing flip.
Okay, so we can skip ahead a little bit.
Yeah, we've already done this part.
You know, .hex.
Yep, we have the.
There is no down click.
got the same
save
thing.
Yep, we got the same thing, yeah.
We have the hex files. Yep, we got
Do not
.sh.
change anything in this. We have collected for hex file too. Now the flip.
Installed. Yep.
Click finish. The first pin of ICSP should be grounded. This is the first pin of ICSP.
I want ICSP
Connect the wire to the first pin of ICSP.
Yeah,
So we did that?
We did that. Yep.
Although he just wait, he did something different actually.
But he used a different ground, but it's the same
So
thing.
we connected those two pins together.
Yeah, but that is ground. Yeah, one's reset, one's ground. He just did a different way.
Okay, good.
But it did end up in the right mode, which is DFU mode.
Okay, good.
Insert another wire into the ground pin of Arduino. LED. Right below the RX LED, there is a SMD component capacitor. To the
What?
left-hand side,
Why is he doing that now?
Let's actually watch it to see what he's doing.
Connect another wire to ground and use another end and touch on the left side of surface-mounted capacitor just below the RX LED.
just touch. Now this LED blinks up, indicating that Arduino has gone into DFU mode. Be careful while touching this wire. You have to touch the left side of the SMD capacitor that is found just below the RX LED. Some boards may have two capacitors. Touch the one
Do we have to do
right
that?
below the RX LED.
Let's see. Seems to be in the right mode in the device manager.
After touching the second wire to the left side of the SMD capacitor, just remove the jumper wire from ICSP pin 1.
Okay.
Now
So
you can see under the device
got the
manager,
DFU mode.
the Arduino Uno has entered the DFU mode.
So we did that. We succeeded
Yeah,
that.
succeeded.
An
that.
So we don't have to do that
exclamation
crazy
mark
stuff he was
indicating
doing.
that the drivers are not there. You have to install the drivers.
Which you did.
Just right click on Arduino Uno DFU and click on Update Driver Software.
Okay, so we did that.
Click Browse My Computer for driver software.
Yep.
And
did
you
this
browse
too.
to the location
Okay.
where you install the Flip software. In this case, it is under C Program Files, Atmel, Flip 3.4.7 and under USB folder. Click on Include subfolders and then click Next.
You got that.
Okay, yeah, we did that already.
Mhm.
We succeeded at that.
Click Install. Now the drivers are being installed. Now Windows has successfully updated your driver software and you can see the display 8090 USB 8.2.
So we did that, right?
Yeah,
we
we
got
did all
we
that.
actually succeeded that.
Yeah.
So we
show
have
us
the
out.
Atmel USB
Under
device.
Manager, you
So
can
there it
see
is.
under Atmel USB devices.
Okay, so we're actually
the
pretty
same
far through
display,
here actually.
8090 USB 8.2. Now your Arduino board is ready to
I think I
accept the
might know
firmware.
what it is. I think it might
Close
be
the device
networking
manager.
or
Fire
firewall
up Flip
issues.
software.
That makes sense. That makes sense. Last of
Flip
Vegito, guys. Here goes.
This is the Atmel's Flip firmware upgrade software.
Give me your energy.
Now the software has already recognized your device 8090 USB 8.2. And at the right bottom you see communication is off. To make that on, select the under settings, under communication, select USB. Click USB port connection open.
So this is where we didn't succeed
Now
to.
Yeah.
So should we try and turn the firewall off?
Okay, let's actually, let's turn off Windows Firewall. Or open a firewall for the Java or something.
Okay.
Or maybe just turn it off for now.
Let's just kill it for now, yeah?
Mhm.
So, is it this one?
Yeah, open that up first. And
Okay.
then we go to,
Allow an app through the firewall?
yeah. So we have Java in here.
Yeah. This one.
It's already been allowed. We do have Flip in there. Nope, not there. Okay.
Should we
that's
add
not
one?
it.
Allow another app?
I wonder.
I have to change settings here.
Yeah.
So let's allow another app.
Mm-hmm.
Path. And we want Flip, right?
Mm-hmm. Are you in System 32 right now?
Oh, crap.
Mm-hmm.
This one, maybe Flip.
Yeah, Atmel.
Atmel.
So-
Open. Where is it?
In bin.
Bin.
There.
This one?
Yep.
Add.
Add. And I guess.
Private and public.
Yeah, I guess so.
Okay.
Okay.
Okay, now let's
try it again.
close this and
Close
reopen it.
rerun it.
Should I run it as administrator, maybe?
Maybe. Yeah, let's try that.
That can't help. I mean, it can't hurt, right?
Yeah.
Okay. I'm sure that can't hurt.
Mm-hmm.
So we've got device selected,
Mm-hmm.
device open, USB, open, and cross your fingers.
Mm-hmm. Oh,
Crap!
Okay, it shows up. So we're not getting the signature bytes. He did get his. Actually, let's see here. Go to select.
Huh, that's so bizarre.
Mm-hmm.
Is it select? Device. Load hex file? No. We can't even open up the USB right now.
Yeah.
Should we look up this this error again?
Mm-hmm.
ISP exception?
Has to be accepted.
Okay. Com dot
Yeah, it's already there.
ISP exception.
Oh, can you I noticed that I could not open USB device. That one.
This one?
Yeah, 3.47.
Uninstall and reinstall flip.
Yeah, you got the same message. You got message com @mail flip ISP exception. Cannot open USB device.
Yeah.
See what the response is from someone below.
You think it's the cable? It could be the cable.
Could be cable.
Let's try it without the cable. The reason why is because look, we got a connector on it.
Okay, let's actually put directly. Okay, but we have to do a reset while it's connected directly.
That's fine. That's really funny that if that's going to be the issue. Should I connect it to a USB 2 or a USB 3?
USB 2 is fine.
Okay. Although I think that the only port I have open right now is USB 3.
It should be backwards compatible.
It's okay?
Fine. Yeah.
Okay, hopefully it'll work. Hopefully it'll work.
Okay, and now we have to do a reset because now it's back to a regular.
And
Arduino.
that's the two pins that are closest to the USB, right?
Yes.
Okay. Give me a second. I'm about to do that. Okay, that do it?
Okay, and yes, it shows up as Atmel device, and it should go to flip now.
Okay, and we'll try that again.
Yeah, close, flip, and reopen.
Close, flip. Oh shit.
You hit Alt Tab. There, you have to close that one.
Okay.
This is a fault of Windows. They create these hidden windows that you don't know about.
Yeah. Okay, should we try again? USB open.
Mm-hmm.
Damn.
Okay, let's see here. What is it?
What is going on?
Mm-hmm.
I don't understand. Maybe we should just try using the Python thing.
Yeah. Mm-hmm. So it's just very little Python script. You can install as a service and stuff.
We can also do that next time because we've also worked pretty hard today.
Yeah.
We did a 4-hour stream on getting this thing working.
Yeah, we got the hardware figured out and stuff.
I think we did pretty freaking good today.
Yeah. Uh-huh. Mm-hmm.
And next time I guess we'll try and make a Python program that handles it up because it doesn't seem that bad.
No.
That all you gotta do is plug it in and then run the Python program.
Yeah, you just tell the Python program that it connects to serial port and just reflects and it just issues, I guess, commands whatever you customize it to be.
Yeah,
actually, it might be easier because that way you can customize it on the Python program.
Oh, right, and then you can run a custom Python program for like whatever profile you want. So depending on if you want it for streaming or if you want it for like, depending on what streaming service you want to control.
Yeah, macros and stuff.
Yeah, that's a good idea.
Mm-hmm.
Actually, I think I like that better than using this Flip program because Flip is not working. Sorry, I spazzed out there a little bit. Okay, let's go back to the chat, see if anybody said anything. Nobody said anything. That's okay.
Okay, I think everyone's asleep now.
Probably. We've been streaming for 5 hours. For 5 hours.
Yeah, it didn't seem that long.
It didn't seem like that long at all. And honestly, this was super fun, Alan. I really hope that we can do this again next week.
Yeah.
Yeah? Because that was fun, wasn't it? And we usually build on Thursdays anyways.
Yeah.
So if we can kind of document our progress and the different projects that we're doing, we're going to be having a lot more fun anyway. So, but thank you guys so much for tuning in for another stream. I'm the real Jordan Vo. This is Alan Wong.
I'm the fake Alan Wong.
Don't listen to him. He's the real Alan Wong. The only Alan Wong that to me that matters, okay? Although there is another Alan Wong in Magic, so...
Yes. There's also an Alan Wong in Hawaii as well, too.
It might actually be a record for me, streaming for 5 hours. I didn't even realize that. But definitely, I hope that you guys go and check out Alan's channel. He's on Twitch as well, and he's awesome. He's super cool. I don't know. Do you ever stream on Twitch?
Rarely. In terms of 0.
So 0 times on Twitch. Well, maybe in the future we'll be able to do more Twitch streams together and stuff like that. And I would really love to make this build stream thing, like a every week thing. If we can do it every week, where we're showing off our cool builds and showing you the new stuff that we're working on, I think it'll definitely like motivate us to
build more stuff.
Build more stuff. And not just that, but also have a plan of an hour. You know what I mean? A plan of what we're going to do. Because I think that with this one especially, we had like a target right starting on it. We're like, hey, we want to build a stream deck. What do we got to do to make a stream deck?
What's the first step we need to do? What's the next step we need to do?
That was really cool because this whole stream we started from like building from the basics. And then we built up and up and up to the point where even I'm learning new stuff. Rebuilding like something that seemed to me to be super simple. So Magro says, get back to me when you beat my record of 11.5 hours. Dude, you're insane. You're a machine, Magro. How can you stream without 11.5 hours without your butt turning to jelly? I don't understand.
It doesn't count when you're streaming when you're sleeping.
Yeah. Well, thank you guys so much. I think I'm going to end there. I hope you guys enjoyed that. And if you guys are watching on YouTube, please like and subscribe. And leave a comment. Let us know what you guys think. And if you guys have any cool ideas for any future projects, please let us know. Thank you guys so much. And thank you so much, Magromancer, for jumping on the channel and keeping us company and stuff like that. I'd also like to say thank you to our 2 new subscribers that we got today. Sheen and... oh my gosh, I gotta take a look on my activity now. Give me a second. I think it was Sheen13, and there was someone else too. Give me a second. I'm gonna check on my channel.
Go to the stream chat and people in there. Does it show up there?
It should check on my activity. So if I go over here in my activity, maybe maybe channel producer, channel.
No, I think it's in stream chat. We click on the little icon underneath with the...
maybe friends or subscriptions?
No, should we go back to the chat window? Go behind.
Oh, this one?
Yeah, go see those little people.
Yep.
Click on that.
Okay, this gives me a bunch of users.
Uh-huh.
Just seeing if I can find... Maybe it's creator dashboard?
Or maybe subscriptions.
Oh, here we go.
Smith.
Smith13 and... Shoon88. Thank you guys so much for your follow tonight. That was super awesome. And yeah, he says that he was streaming Persona 5 Royal and that was super easy. You know what? I will try one of these days to try to stream for a super long time. But you know what? You're a machine, Magro. I'll tell you that much. You're a machine. You're a streaming machine. And thank you so much for joining us tonight. And I think that's about it, guys. Thank you guys so much. And I will see you guys next time. Peace out.
Good night.
Bye, everyone.